was it nose tackle, whatever, the guy that's right in front of the like the guy in the middle who was
Yeah.
of the scrum.
He's a fucking
I
enormous
don't
dude.
remember what he played, like middle linebacker or something.
Perry
No.
occasionally played fullback.
Fullback.
Yeah.
But
Okay.
yeah,
Oh yeah,
Yeah, fullback. There you go.
reminds me of Hershey Walker, Herschel Walker too. Hershey.
okay, yeah. Yeah, that he was like hitting a brick
In
wall,
the
that fella.
Cowboy days, though.
Yeah.
Yeah, well, I used to watch it because we had an Aussie. I think it was one of our first Aussies that went over there, and he
Oh
was
yeah.
kicking.
What was the what? We kind of just blew up on Perry, but what about your boy again? The dude.
I think it was Green. I think his name's Green. Yeah, it's going back too long ago now. He was a kicker, a punter.
Ah,
He used to kick it a mile. It was like a bomb launching. Yeah, that's about all he did. Kick.
oh yeah.
God,
Those
man, that'd be such a boring. It'd be
kickers
such a
win
boring
games, dude.
job. It'd be such a
Shit,
boring
kickers
job.
win games.
As long as possible.
Let the guys get downfield.
Uh huh. But yeah, it's a little bit too slow for me. Gridiron, just too slow. Like a game that should really take about 15 minutes to complete takes like 4 hours sometimes.
Yeah, I mean, but how are you going to sell 4 hot dogs per person in that amount of time? I mean, I gotta sell some hot dogs, you know.
I do occasionally still tune into the final, but that's about as much interest I take in it now.
Yeah, who's got time for that anymore? I just get jealous. I can't do that shit anymore. I'm just kidding.
Oh, oh, little Daisy.
So what's the craziness over in the other channels, Grim? Are you still going hell for leather?
I mean, there's guys that are, you know, that are all jabbed up, you know, and then they're still, you know, on their third row of having already had COVID over and over and over again.
Oh, really?
And they're still in denial, as if
Gee.
and then these same assholes, right, that are popping up with this monkeypox are the same ones that were multi-jabbed also. It's just no escaping this. It's almost as if stupid is stuck on the high road and everybody thinks that's where it's at, and it's so stupid. To me, it's obvious, you know. I don't know what I can say or not, but I mean,
Yeah, well,
get the fuck away from me with your vaccines. I'm telling you.
Yeah.
Those people.
Hey, well, I'm lucky where I am. I'm isolated from all that sort of stuff.
Well, you think, you know, until those fucking orders come down and they're like, oh, we're going to protect the world by killing the world. That'll do it. That'll
You
We
could
had
do that.
ribs. This was so good. I need one more. I think.
Nice.
Oh yeah.
Nice.
I'll be back though.
All right. Mm.
Do. Might have some Nutrigrain, Bandy.
Nutrigrain.
Nutrigrain.
Mm.
Then I should go and
Wasn't
pick up my daughter.
wasn't that was Kenny Grant's cash cow back in the day, wasn't it?
Yes, Kenny Grant, Lisa
Curry.
Curry.
Yeah.
No, I have a Kenny Grant. Yeah,
Mm-hmm.
Grant Kenny. Yeah,
Grant.
Grant Kenny.
Yeah, Grant Curry. Mm. Their son was on that Australian SAS show a couple of years
Yeah,
ago.
is that Sean Kenny or something?
Maybe, yeah.
Oh,
Anyway, he ended up tapping out.
yeah,
Pussy.
as would I.
Really?
Oh, weak as piss, man.
Oh, you see the challenges they do? Really? You tap out?
No, I've never seen the show.
Oh, they're not really all that extreme, to be honest with you. They really aren't.
My lung capacity is about 75-ish%. So yeah,
I don't think any of the challenges that they do would require any more than that, to be honest with you. Actually, I was surprised there was a what was her name? The woman that went quite far in it. But she was a whiner. She was always whining about anything, everything, and you know, my wife used to love the show, and so we'd have predictions of which one was going to tap out that episode. You know, who's it going to be? And, I'd always say her name. Oh, what was her name now? It was oh God, the Australian hurdler. She was known as a bit of a whiner and a bit of a drama queen.
Pitt, Yana Pittman.
Yes, Pittman. Yes, Pittman. Yeah. Yeah, I was actually quite surprised at how far she got, but she was always whining about something, you know, to cringe level it was. It's like, yeah, she'll be gone, but she ended up getting to the last three, I think it was, last three. G'day, Matt. How you going, mate?
Hey, Benny. I don't know what I'm doing over really. I should go to bed.
Oh, really?
Yeah, it's 4:45 in the
Time.
morning.
You're in Ireland, yeah? Ireland?
Yeah,
Scotland?
Northern Ireland, yeah.
Yeah,
Mhm.
yeah, Ireland. Yeah, I thought so.
Mm.
It's only 4:45. You're pulling an all-nighter, are you, on Discord?
Yeah, that's pretty much the norm for me. I probably don't go to sleep till about 4 or 5 in the morning these days.
Oh, there you go. So who have you been battling today then?
Nobody really today. Nobody.
No?
No, not really. I've been a good boy. I've been pretty quiet.
Okay.
Makes a change.
Are you winning any of your battles is the question.
I don't know. Maybe.
Maybe?
Maybe not. I don't know. I had a pretty heated discussion in here yesterday. Well, no, day before yesterday now. I can't remember the fella's name. Flat Earther and Geo was here as well. Got heated, but it was fun though. It was good natured in the most part. I mean, Nash Shields was here, and that didn't turn out very well between him.
Was it Vaxy Waxy about the moon phase?
No, it wasn't that. No, that was day before yesterday. I'm talking about yesterday. Yeah, I know what you're talking about. Yesterday was the moon phases. Yeah. I think it was the day before that. Unless it was like the morning before that. I can't remember.
I don't know.
Yeah, it does all blend in.
Time zones as well. What was the topic though?
We were talking about pressure gradient and stuff like that.
Okay. What was the bone of contention? One would say.
Well, I mean, it sparked me, right? Because flat earthers commonly say that you must have a barrier, have a solid. You can't have a pressure against a vacuum, right? And I said, well, there is no pressure against a vacuum around the Earth. It's not necessary because of the pressure gradient, and it was just all really around that.
Oh,
That's
okay.
what sparked it off. Because there isn't, because I argued, well, there's no such thing as a perfect vacuum, and then he sparked up. Well, what you're saying is then that there's no such thing as a vacuum chamber. But no, even a vacuum chamber, there's no such thing as a perfect vacuum. There just isn't. And he made us another stupid comment. He says, "Well, okay, well, what about 0.0000000000005 torr?" And I said, "Well, you just said the 5, so therefore it's not perfect vacuum, is it? You know, it isn't. You can put 1,000 noughts in front of it and put a 5 in it, but it's still not a perfect vacuum."
So where they talk about is it the Kármán line or whatever it is? But anyway, does it go from whatever pressure it is, say, I don't know, whatever it might be, say 0.00001 psi, all right, and then just get lower from there? Or is there a distinct line where it goes from one pressure and then go down
No to both
you know
those
what
questions.
I mean?
Yeah,
Okay.
no to both of those questions, right?
So
The Kármán line, the Kármán line,
is slightly gradiated all the way. There's never a slight difference between any pressure. It's always gradiated out as far as you can go, according to the model.
yeah, pretty much. But what you got to bear in mind, obviously, the further out you go, I mean, it gets to a point where it's hardly detectable. Do you see what I mean? But the Kármán line, you see, what you got to understand about the Kármán line has got no relation to barometric pressure at all.
Oh, yeah,
I know
that, Matt. Yeah, no, I know that. I've got no dramas with that, but that was just a point that I picked where, at the end of the day, instead of just saying, well, that line there, but that,
Yes, if you take like from sea level, okay, to let's say 200 kilometers, right? For argument's sake, you said the Kármán line's at 100 kilometers. You mentioned, right? Okay,
Yep.
It's basically from sea level and upwards. It goes into like an exponential curve.
Okay.
All right, so it's not like a direct line. So it will sort of increase kind of the pressure will decrease rapidly the further you go up, but it's still a gradient. Do you understand what I mean? There's not a point where you just suddenly pop into space and you've got a vacuum, because a lot of flat earthers believe that. They think that's what the Kármán line is. You just suddenly pop into space in the Kármán line. No, doesn't work like that.
Yeah, I think that's
And the reason, I mean, one of the reasons why I know it's the case, because there's one, and I mentioned this during the argument, was that aircraft altimeters, or altimeters, whatever you want to call them, they measure changes of barometric pressure. That's how they measure their altitude, and that includes all commercial airliners. So they're measuring altitude, they're measuring changes of barometric pressure day in and day out, every single day, thousands of times over. And they're pretty accurate. So I think really altimeters kind of prove a pressure gradient. And all you need to do, and it's the same with military aircraft who can go to much higher altitudes.
Oh yeah,
in the most part.
Yeah, I'm not denying a pressure gradient at all, not at all. But any sort of pressure or pressure gradient really can only be demonstrated with a container.
No.
And if we had a tool, and I think it comes down to, once again, we don't have tools sensitive enough. Okay, so if you had a container and you let that container and you put it in the right conditions, let it settle, so everything was even around it, you could demonstrate a pressure gradient in a container.
Yeah, you could. Yeah, absolutely.
Yeah. I think that's the
Bandy, you can demonstrate a pressure gradient in the room that you're in.
Oh
Also
yeah, with
true.
my little thing on my phone.
Yeah, you could walk upstairs and you'll see a change in barometric pressure. Sure, it's not very much, but yeah.
Yes, but I think that pressure comes from being contained.
But why? Why? What would happen if it wasn't contained?
Well, how would you get pressure in the first place?
The implied in that question is that you need some sort of container.
Yeah.
You understand that there's a pressure gradient, right? There's no barrier required between 14.7 psi and like 0.07 psi. Where is this barrier required, and why?
The barrier in general to have pressure at all.
No, you're just repeating your assertion, your conclusion.
Yeah.
Your assertion is that it requires a container. We're asking why. Why do you assert that?
Because you've got pressure in the first place.
Right? Does pressure require a container?
One would think so, yes.
I don't, because I know that we have a pressure gradient.
Well, no, because that's what the model says. You don't need a container.
Right.
Okay.
Why would we need a container? What do you think would happen?
Well, I think there would have to be a container of some sort, even in your model, Rui, even in your model, okay, of space and stuff, okay.
Yeah.
I think there has to be a start, and I think there has to be a finish. It just doesn't go on forever and ever and ever and ever.
Okay, I'll ask you another question then, Bandy.
Yep.
Would you say that gas has mass?
Oh yes, most definitely.
Would you say the Earth has mass?
Well, yeah. Why are you asking me questions where you know the answer?
I know you know the answer, but I'm just trying to make a point, though, right? Okay, so
some people say no to the first one.
You say no to the first one?
No, I
some
said
people
yes.
say no to the first one.
Some people
Yeah,
say no
some
to the
people
first
say
one.
no.
No.
Yeah, but at least you said yes. So,
Yeah.
well, you know what I'm going to say next, right?
Yeah,
You know
of
where I'm going to go
course.
with this,
Yeah,
right?
I know exactly where you're going. Yeah.
Exactly. You know, so it's gravity. So why not? If you have two masses, gravity. What's the issue with it? So why do you need a solid barrier? And you also understand that gravity is also dependent on the distance between the two masses, right? So the further away you get from that mass, the heavier mass, in other words, the Earth, why wouldn't the gravity would get less, right? So why wouldn't the gas pressure get less?
Well, that's the theory. Yeah. But I still think, I don't know. Gravity is such a mystical, magical word that is convenient for many a thing, isn't it?
Mm. You can say
And
that
the,
if you like.
Acceleration downwards.
well, it
Andy.
is. Like it was conveniently hijacked in the middle of the night, gravity, right? And it was taken to a basement, waterboarded, right? MKR altered, right? And it came out as this new entity, right? It had all these magical, mystical powers about it. Because once upon a time, gravity was just weight. That was it. And then you guys hijacked it in the middle of the night.
Gravity
We all went to sleep, right? One day we went to bed and all it was weight. And then we wake up the following day and gravity was something else.
You know what? That's like saying, oh, why is it all of a sudden we've got cancer in the modern world when in the olden days there was no cancer? That's just, it's like saying the same thing. No, because you know, with modern medicine, we understand things more, right? And that's the same with science, Bandy. You know, we discover things and we understand things. You know, Isaac Newton explained what gravity. Well, okay, explained what gravity was, or what it thought it was, and Einstein came along and just expanded on it. That's all he did.
All he did was hijack it. That's all
No.
he did. He
No.
should have thought of his own word. He wasn't very original there, was he? At the end of the day.
Why does a scientist need to be original?
Well, God, if I thought of something new, I'd make sure it was bloody well original. I can assure you.
Call it vanity.
Right.
What was that, Ruby?
The theory of vanity.
Theory of bandity.
Vanity. There we go. There we go. And like you think about it, Matt. Like back in the day, like 2,500 years ago, thereabouts. So the story goes. All right, they watched a couple of ships and they were sailing off in the distance, and they went, "Oh my god, it's fallen off the edge." Right. Anyway, they sussed this out a little bit, and this is way before gravity, mind you, way before gravity.
Or way before gravity existed. Is that what you're going to say?
Pretty much, yes. Pretty much, right? Now, back in the day, 2,500 years ago, right, they knew how water worked, right? Water went from higher elevation to a lower elevation, okay? And they could see that. They did these things. They did these amazing things with water. They got it from point A to point B, right, by putting water at a higher elevation and taking it down to a lower elevation. And
yeah, the Romans were good at that. Yeah, Romans were good at that. Yeah,
exactly. So, and then someone was at a beach and they noticed a couple of ships potentially sailing off the edge, and they were all a bit worried. Or, oh my God, we've got to find out what's going on.
Is that what happened? Can you verify that they said, "Oh my God, it's gone off the edge"? Is there anything written in the text anywhere?
That's close enough too, right?
Oh my God! They went off the edge of the earth. Oh no!
Exactly. And so these people are very primitive people. Anyway, so then the story goes, you know what? We've got a solution. We have a solution. Right, because they sent out another couple of ships and whatnot, and they noticed that he was just a little bit further away. Okay, and they came back.
They noticed that, did they? Right. Okay.
Yeah. And they came back to the campsite. And they go, you know, we've got to think of something here. We've got to think of something. You know what? It's a big ball. we're on the top of a big ball. Oh yeah, that makes sense because then we're not going to like sail over the edge. And one of the little fellas, right, said, yeah, but we're on the top of the ball, guys, right? And there's water up here. Like, how does that work, right? And they killed him. They executed him. They shut him up immediately, right? And then they just ran with this whole ball thing, right? And then 2,000 years later, right, until a few more people started asking questions, they had to think of something to keep the ball on the water on top of the ball. And that's when, what's his name came in old 1600, whenever it was, and said gravity. And that kept the water on top of the ball. That's pretty much how the story went.
I've got no words. I have no words.
It's like, seriously, these were primitive people, and they thought that they lived on a ball when water would flow off it.
Well,
one of the really interesting concepts is that the idea of gravity or anything down here being the same like mechanisms that apply to the things in the sky. When you really think about the mindset they had when it came to some sort of geocentric globe model before gravity, right? They had to, I don't even know what sort of idea. I think they thought that the planets, right? Venus, Mercury, whatever, were on like some sort of like magical railroad track that they rode upon, right? Not that they were actually like being pulled into the center of gravity or anything like that, but that they were actually on tracks orbiting the geocentric Earth, right? Because they had no idea of some sort of force that would make things all orbit some sort of center point. They thought like, oh yeah, these things in the sky, it's geocentric, we're on balls, but the things in the sky, they're on like they're inside of shells, or they're on railroad tracks that they ride upon, you know? Because how do the people who think that the Earth is a globe and these things are orbiting it have an explanation of why these things are going around it if gravity hadn't been discovered yet or invented yet or theorized yet or hypothesized? They had to believe they existed inside of shells, that was their domain that they kind of rode upon.
There's a convenient 2,000-year hole in the story.
Yeah, exactly.
Well, there's not, because if you look back in history, I mean, our understandings of the world evolve, don't we? I mean, this is why we're talking on a device right now to each other. If I'd said to you, right, 40 years ago, right, okay, I was brought up as a kid in the 80s, right? If you'd said to me in 1981 that I'll be able to go on a machine where I can talk to anybody in the world, and I can write text as well right next to it, and it's going to be called Discord, do you think I was freaking nuts, right? But here we are. You're in Australia, I'm in the UK, and I'm fucking talking to you, and I don't need to use the telephone. You understand what I mean? So, our understanding of the world develops, and there's no hole in the 2,000 years that you're talking about. There's lots of people through history, gradually, bit by bit, we got a better understanding of the world and came up with better ideas of why things behave in such a way. Give you such an example, right? When you were talking about the geocentric model, and along came Copernicus, and he explained like one of the things was the progression of the planets. And sometimes if you look at the planets, I mean, I did this actually when I was in college. We tracked Mars, and we did that retrograde movement when it kind of loops back on itself and goes the other way. And for a long time, that nobody could really understand why that was, or religious leaders just said that's just pretty much almost said, well, that's just the way it is. God created all this. But then other people came along and gave a better explanation for it, and there was born the that we actually orbit the sun rather than the sun and everything else orbiting around us. And then gradually that was built upon. That at that point as well, they thought that the orbits were all perfectly circular, And then along comes somebody else and realise after observations that most of the planets are in elliptical orbit. And it just developed from there. It was a little bit by little bit. There wasn't like a sudden thing, there's no gravity and all of a sudden there is gravity. You know,
naturally,
it didn't happen like that.
But no. But if you think about it logically, though, right? They're on the beach, they're watching this ship, and it's sailing off the edge, boom, into nowhere, right? And they're all worried, so they go do a bit of investigation, and they work out that they're on a big blue spinning testicle, right? They go, okay, then we're happy with that, right? But they didn't have anything in place why that wouldn't happen the same for them sailing over the side of this ball and falling off it, right? Down a waterfall that is rushing down the side of this ball. Like they had no explanation for it. So the consequences are exactly the same, whether you're sailing off the edge or you're sailing around a ball. You're going to fall off a ball because anything that they could have done practically on the beach there, if they had got a rock on the beach, right, and put a little stick on it that represented a boat and then like pushed it, eventually like it just would have fallen off it. So the same sort of fear would have been exactly the same as far as sailing off the edge. They had no mechanism in place to keep them on it. No magnetism or anything like that, because on the beach there's a rock. They can.
You mean there wasn't an explanation for it, though? That's what you mean.
Yeah.
There was. You can't say there was nothing put in place. You know, it's always been there, Bandy. It's always been there. You know what I mean?
It's just an explanation. We're talking about very primitive people that were scared of bloody thunder gods and all this sort of stuff. So it's not as they walked around with magnets on the bottom of their feet. They weren't stuck to anything that would give them
but even cavemen realised that if you drop something off a cliff, it's going to go down. But they couldn't explain why. But that's what I'm saying. But
they could. I bet you they could.
How could they explain
They would have
it?
gone, because it's heavy. That's what they would have said. Because it's heavy.
I don't think they even could do that. But yeah, okay,
hey,
yeah, it may be eventually.
You know about the retrogrades though. I feel like there's a common misconception that only exists in modern days, just based on just ignorance and these stories we've been told about the past. No one ever thought that anything went clock like if you're laying down, if you're at the North Pole, you're laying on your back staring at the sky, right, and everything's going in circles around the north the Polaris counterclockwise from that perspective. No one ever thought that any celestial body actually ever went clockwise. Like that's like this weird idea that people just do their ignorance think nowadays that when it comes to retrograde, things are actually moving clockwise against the grain of the overall primary motion of counterclockwise motion. Nothing in the sky has ever gone clockwise from that perspective.
Right. It all goes west to east. Yeah. Or east to west. Said that.
Yeah.
East to west.
Things only travel at faster and slower rates and lose position in the race, of the racetrack of the sky. They get surpassed in the position of other bodies, but nothing ever goes clockwise from that perspective. Everything continuously goes counterclockwise, but the planets change their rate of travel, which makes them lose position compared to the other celestial bodies.
Yeah, and I find it interesting, kind of tagging onto that, I find it interesting that in this modern day heliocentric story, there's this narrative going on about retrograde, and somehow they needed some heliocentric thing to explain retrograde. It's just so bizarre to me. It's not needed at all. Now you can explain retrograde if you want to make a heliocentric thing. You can do that. But like what you were saying, fundamental, exactly. Like all retrograde is just a changing of the speed of the luminary. So Mercury, for example, will be like the fixed stars are moving the fastest in their motion, 23 hours, 56 minutes. So something like Mercury is always moving slower than the fixed stars. That's why it progresses through the zodiac, because it's going a little bit slower than the fixed stars. When it goes retrograde, it simply picks up speed. It goes the same speed as the fixed stars. That's when it's called stationing. And then it goes a little faster than the fixed stars, which is retrograde. and then it slows down again, and it goes back into direct motion. So it's all it's doing. It's just very slightly changing its speed. You don't need any heliocentrics or orbits or any of that. It's literally just lights that are, like you said, slowly changing.
Okay, so if you got these lights that are going across the sky, why would they change direction briefly and then go back the other direction? What reason?
Not direction.
They do, because if they do change direction momentarily. They do.
No. They change position compared to the background state, fixed stars, but they never change direction. They only change.
Well, they appear to change direction from our perspective.
No, they don't. No. You're only talking about taking a photograph aimed in the same area of the sky once per night. It can give a sort of like stop motion animation of that, but nothing ever goes clockwise from the perspective of like laying your head down at the North Pole, looking up at the sky, things going around Polaris. Nothing ever goes clockwise. Everything always goes counterclockwise, the rotation. Just the planets change their speed at which they travel counterclockwise.
So when we produce the model, and like I said, I've seen the animations. Okay, when you actually produce the model, and you see from the perspective of the orbits of the planets, particularly on the outer planets, it seems to fit and it works. So why is it that works, and you're not prepared to accept accept something that works that way? Because it really does work. Once you look at it, it makes complete sense.
No, I'm willing to entertain any idea, but I also want to be grounded in an understanding of what's going on from a feet on the ground observational standpoint. And all that's going on is that there's the fixed stars that move at a constant rate, never change, constant velocity, always very consistent. And then there's 5 lights in the sky that change their speed of circuit around Polaris.
Yeah, it's sort of like it's sort of like I think about it. Like if you had 2 cars on a highway, and let's say one of them is the fixed stars and the other one is, let's say, Venus. So the fixed stars is going a little faster. It's going 60 miles an hour, and Venus is going 50 miles an hour. So they're going like that, and Venus is since it's going 10 miles an hour slower, it's always losing a little bit of pace on the fixed stars, and that's why it's moving through the zodiac. So it's actually moving through, Aries, Taurus, etc. It's moving in that direction. Now, when it starts to go retrograde, Venus will pick up speed and it'll start going the same speed as the fixed stars. Now they're both going 60 miles an hour. And then Venus will go a little faster. Now it's going 65 miles an hour. That's when it's in retrograde. And then Venus slows down. It goes 60 again, and then it goes back to going 50 miles an hour again. Obviously, those are just examples. I'm not saying it's actually moving 50. Those are just an example. So it's literally just changing its speed in relation to the fixed stars. Everything is still always going east to west. It's never actually moving backwards. It's never going west to east. It's just changing that like phasing position in relation to the fixed stars.
So you're going to stick the planets, including the stars, as just luminaries just moving across the sky, and for whatever reason they're moving in a retrograde motion.
Well, I'm just referring to what we observed. Like if you and I were standing on the ground, we could point up and say, "Look at that light! It's moving faster. It's going at a slightly faster rate than the fixed stars." Or look, it's going the same speed as the fixed stars, or it's going slower. I'm just going off that. Very basic observation.
I would be more inclined to say that none of them are changing their speeds, but the moving stars, the planets, they're actually just changing their altitude, not this. So they're all going the same speed, but because they come closer to the Earth, it looks like they're changing their speed.
So looking at the
that'd be like angular speed, which is undeniable. But there is a chance what you said is the truth. I don't know, but the angular visual speed is undeniable.
Okay, so right, let me just go back to when I did this at college, right? This is quite a long time ago. I was about 19. I'm 52 now, right? Okay, so they had an astronomy club, and they decided to put on one for once a week for beginners who want to learn about astronomy and stuff. And one of the things we did was we tracked Mars. Okay, so here's a really good example I've just posted in the live stream text. Okay, so what we did was we tracked it over a period of time, and this is what we observed. We observed this retrograde motion. All right, so looking at that diagram, so when we sort of when we logged it, I mean, like I said, the guy that was taking the class didn't mention anything about what would actually happen, but he knew it was going to happen because he wanted us to see for itself. So then we talked about why it would happen, why that actually occurs. So we asked the question, why is that happening? And then he drew a model, pretty much what I'm showing you there, and to me, that made sense. So would you say, am I wrong in that assumption? Is that wrong? Should I have not assumed that, or would that have not made sense to me? I don't, where's that? Where are you coming from on that? I mean, does that make sense to you? Could you explain that? Could you even consider that as a possibility?
Yeah, my response to that would be, like, if you take the sky that we see, sun, position, Venus, etc., the fixed stars, just as lights, as a field of lights, like a planetarium, and right. They move between the tropics and this and that. We can kind of just observe them in their declination and so on. If you take that sky clock and decide to say, hey, I want to change up the geometry a little bit. I want to put that sun in the center. I'm going to then put Mercury, then I'm going to put Venus, and then the Earth, etc. And I'm going to make these things balls, and I'm going to make this heliocentric model. You can reverse that. Like, there are certain geometries that overlap over each other, so you can do that. You can take the sky and kind of turn it into a heliocentric geometry system. And if you do that with the way the sky is, if you do that, you actually have to put Mercury first and then Venus, etc. And there's reasons for that, which I won't go into, but you actually have to put them in that order. If you do that, then retrograde motion, that one that you just posted, would be explained that way. And I personally don't have any conflicts with the heliocentric explanation of retrograde if it was a heliocentric system, because the geometries are compatible. So yes, this, in terms of if it were heliocentric, this general explanation like you posted here does at least align enough that there's no major conflicts with it in my thoughts. And I can understand why seeing it that way, if you decide to believe it's heliocentric.
Yeah, cheers.
So I can understand why it's perceived this way or explained this way, but just because it's explained this way, it doesn't necessarily mean it's what it is. But
right, okay, that's fair enough. I see where you're coming from, but to me, just to say that they're lights in the sky just moving in a particular pattern is kind of, to me, is too simple. If you know what I mean, it's easy to sort of like to say it that way. For me, that's kind of the way I see it. I don't know.
Given that we can look at Jupiter and see it rotate over the course of a night, it's not just a light in the sky.
Yeah, I mean that's the other thing. One of the things that, looking back on it now, that really convinces me, or at least two things that convinced me, that's one thing that we did, and also me observing the moon as well. We observed the moon over a few different nights, and we actually saw it transitioning, and we were looking at the shadows and the craters and the shadows and stuff like that, and actually moving. Then that actually kind of that for me solidifies that the moon's definitely a solid object. It wasn't a light in the sky, and that was another thing as well. Good thing. So, it's something that I physically did myself.
Does such a thing exist where you got that giant storm, the eye of Jupiter, the red dot? I forget what it's called exactly, right? Is there sort of a time lapse or animation or anything like that of something actually captured, like stop motion, of that red dot on Jupiter, like crossing from left to right?
Yes, there is. Yeah. Yeah, there is.
And it just kind of cycles around. I've never seen an animation like that.
There's a few on YouTube.
Yeah. So I think there's more to just animations. There's actual footage. Still was obviously put together that shows that.
It had to be a time lapse or a stop motion animation of some sort.
Of course. Yeah. It's not. Like I said, they're not animations. They're like you said. They're time lapse photographs taken together from probes. They're actually showing it rather than just animation.
Well, I'm more interested in the sort of like feet on the ground telescope observations rather than something relying on one of the space institutions.
Oh, see what you mean, like somebody, right? Okay, gotcha. I'm not sure.
You can do this yourself, champ. Yeah. You can do this yourself.
Well, champ, when Ruhit brings the champ out, he's getting the boxing gloves on. Well, the thing is, I mean, Ruhiv, what you said, and what I mean that still doesn't validate that it's a physical body. Like you were saying, that means it's not a light in the sky because you can see features. I mean, plasma fields of sonoluminescent cymatic frequencies can have all kinds of fields and pulsations to them. It doesn't mean that
Yeah, but not shadows though.
that they're physical. Well, they
But
can
not
have
shadows though.
Well, on the moon, you're talking.
Yeah.
Okay, so I don't think that they are shadows. I think I think the moon fluoresces its light in relation to the sun. The parts that are not fluorescing, which what you might call a shadow, are parts that are not fluorescing because of the way that the moon works. So,
okay, so that to me doesn't make any sense because we weren't just looking at one crater. We were looking at all various different craters. So it just so happens that they're all uniform.
well, for example, if you take a crystal that fluoresces in relation to ultraviolet light, if you angle it to where you have like a part of the crystal, there's a little mountain, let's say, on the crystal, or like a bump, and then behind the bump, the ultraviolet light is not, or the black light is not actually hitting that because it's over the hump. It won't fluoresce. Like that little area won't fluoresce. So it's not a shadow from light bouncing off of it. It's actually the fluorescence is not being activated because it doesn't have a direct line of sight to it.
Even though even crystal though is still passing certain light through anyway, isn't it? All over. It's just that some areas might not be according to your own perspective. But so therefore, if you're saying that, then the moon's has to be a crystal, and therefore it's a solid object.
Right.
If you're going to say it's crystal, then you haven't got any other explanation. Then that's what it's got to be, right?
I mean, I personally do. I think it's a celestial crystal, but I mean of plasma. But that's sort of a separate discussion. I'm just saying that how something could be perceived as a shadow, and I'm just explaining it in a different way, which is that it's actually part of the moon that's not fluorescing.
No, that doesn't make any sense to me. Sorry, I'm not convinced.
Well, it makes complete sense because you can recreate it with crystals and fluorescent crystals.
Yeah, but it's not the same effect though. If you look at the moon and you actually look at the shadows of the moon, it's not the same. It's not a shadow because the shadow is a very definitive thing. When you're looking through a crystal, it's not that definitive because it's not a shadow. You can tell that it's not a shadow.
Okay, so you've seen what I'm talking about with the black light and crystals to define that that's different than what we see on the moon.
I've seen similar things to that. Yeah.
Could I ask a question?
Sure.
Gio, are you saying basically that the moon is a thing and it's there and it has the texture, the surface, the craters and the mountains that it looks like, and those mountains and craters make shadows in the primary light, but instead of seeing reflected light, we're seeing fluorescent light?
Yeah, the moon. I don't think the moon's reflecting any light. It's entirely its own light source, and it fluoresces. It's a fluorescent.
I don't understand. Like, why is always the light lit up part of the moon pointing towards the sun? We know that the sun lights things up.
And it fluoresces in its position to the sun because there's a charge, like a battery charge component. The sun's energy is what charges the moon, not the sun's light. It's the sun's actual charge energy. And so it fluoresces and it does its phases in relation to the moon. Sort of like, like an Etch-a-Sketch where you kind of take the little magnet thing and it kind of attracts the magnetic particles and then you can draw with it. It's a little bit, I mean, it's not exactly like that, but in a way, it's sort of like in a way that the magnets, when you do the Etch-a-Sketch, it kind of pulls the little ink things to kind of create a drawing. In a similar way, the moon's light is fluorescing in relation to this position to the sun. So instead of reflecting light, it's just fluorescing its own light to the sun.
Go ahead.
Can the moon see the sun? Right? It's a simple question. Can the moon see the sun?
Yeah, they are.
Okay.
They're in the relation to each other. Yes.
Right. But given that we know we're on Earth and the sun lights up everything, I don't understand why it wouldn't light up the moon. Like, it's just such a simple conclusion. I don't understand why you've made it entirely more complicated.
Right.
The sun lights things up. The sun lights up the moon. The end.
Yeah, if that's your belief, that's your belief. That's fine. It's a philosophy about the
Cool.
sky. If you hold that philosophy about the sky, then you can have that. I don't think that's what's actually happening, but
So when you said, so where's this energy of this fluorescence actually coming from then? What is this energy? Where's it come? Where's that energy come from?
the ethereal quintessence of the higher layers of the ether.
Okay, put that in layman's terms.
The superfluid plasma field above us. I mean, in terms of what it's coming from or what it is.
Yeah, just the energy, because you said it was a fluorescent energy just a moment ago. So what is that fluorescent energy? Where is that energy coming from? What's creating that energy? Because you can't just magic energy out of thin air, right? So it's got to come from somewhere.
Yeah, I mean, obviously, I've never been up there physically, so it's not like I've taken a ladder up there and gotten samples or anything. So obviously, I'm just sharing my understanding of creation and how I think it works. But I mean, I think there's an entire toroidal magnetic field that surrounds the Earth and the waters above and plasma. So I think there's an actual field, and that field has charge in it. And that field has the luminaries are essentially like concentrated quintessence. Quintessence is basically like the material of the ether that the celestial objects are made of at very, very high octaves. It's part of the element of ether. And so it's actually the quintessence itself, but the sonoluminescence and the vibration and frequencies of that magnetic field concentrate in certain regions, which we would call the sun, the moon, stars. Is essentially concentrated light emissions based on like the sound wave frequency that's vibrating, which is the sonoluminescent component of it, is how I think it's working.
I'm not into kind of like this one-upmanship or anything like that, but you could just say I don't know. It's fine. I'm not going to hold it against you.
I'm not going to say I don't know because I don't not know. I'm going to tell you what I know, and then I'll share my thoughts.
You can be honest. If I don't know something, I'll say I don't know. There's a lot I don't know.
Right. So
that's fine. If you don't know where the energy comes from, just say I don't know.
I don't not know. So I wouldn't say that.
You don't not know. So you do know.
That's a double
negative. That's a double negative.
If you need to ridicule people because of you're insecure, I guess.
No. I'm not ridiculing. That's what I'm saying. I'm not here to get some one-upmanship from you. I'm not here to do that. I'm not going to do that to you. I'm not going to hold you against it. I shared
my thoughts, and you used a ridicule, saying, "Haha, you could just say you don't know," as if you're.
No. Honestly, I'm not doing that. I'm not ridiculing you at all. I'm not. It's not what I'm here to do. Honestly. Yeah, I mean, you could ask me a question. If I don't know, I'll say I don't know.
Okay, so why are you suggesting that I should have said I don't know? That's not my position.
Why not? I think it's just honest.
If you don't know, that could be honest for you. You're assuming something about me that isn't the case.
Okay, all right, okay, that's fine. Don't worry about it. It's okay. But like I said, I wasn't trying to ridicule you in any shape or form. I promise you. That's not what I'm here to do.
All right. Well, if I don't know
kind of discussion
else,
I had to have.
I'll say those words if that's what I want to say.
Okay. Cool. All right. Okay. Fair enough.
You were asking me, so I was sharing my thoughts.
Fair enough.
My understanding of how the moon emits its light and how the system is working.
No, the reason why I thought that, and the reason why I said it, and that's the only reason why I said it, is because you hesitate for a moment, and then you said, "Well, I haven't been up there to measure it," and it's almost as if you were just about to say, "I don't know." That's the only reason I brought it up. But like I said, if you want to say that, that's fine. That's okay. Like I said, I'm not here to ridicule you or kind of get any kind of one-upmanship from you or discredit you or anything like that. That's fine.
Well, the way I see it is it's like different layers and levels of consciousness. Like my physical body has not been at those high levels of the environment up there, like to get a sample of the moon. So on that level, if somebody said, "Prove to me what the moon is," that's when I would say I cannot do that in a physical, tangible form. I can't go up there and get a sample. And
yeah, I agree.
In that sense. And
yeah,
I
agree.
I don't think these government agencies can either. I think they're just fooling people and claiming that they're probing things. So I don't think they can either. I think the heavens are a mystery in that sense. However, for me, there's other layers of my consciousness that I am attuned with in terms of creation and how this realm was made and what it consists of, and sort of the meeting place between the physical and the spiritual and so on. So when I'm sharing those thoughts about the sonoluminescence and the quintessence and the ether and so on, that is more of a sort of non-tangible, if you want to put it that way, metaphysical, spiritual, creationary understanding of what is going on that level, rather than something I can physically, bring you samples of and, offer some tangible proof for.
Yeah, that's fair enough, because quite often I get that from flat earthers the other way around. So yeah, no, that's fair enough.
I mean, at the end of the day, the heavens are a mystery. I mean, if we want to use intuitive or psychic or metaphysical or spiritual ways of trying to know the beyond, I think that's a very interesting thing to undertake. But ultimately, I think that on another level, we are not able to go up there and get samples, and I don't think NASA is either. So it's sort of like, at the end of the day, it's all philosophies about the sky.
That's fine. I mean, that I'm obviously not going to disagree. That's another discussion, but we'll do that maybe for another day. But sure, no, I get it. Like, hello, listen. I mean, I've had some pretty nasty arguments with flat earthers and things like that. But one thing I've always said is that you can believe, or anybody can believe, whatever they want to believe. I have no issue with that, and I will actually defend people's democratic and human rights to actually believe whatever they want to believe. And that's absolutely fine. Don't have an issue with it. But we can all disagree. At the end of the day. Listen, yeah. I need to go to bed. It's like fucking 5:30 in the morning. Fuck. Hey, nice chatting with you all. I'm gonna go to bed. Have a good one.
All right, Matt. Yeah. Have
See ya. Bye.
That was fascinating.
I don't know why they make it more complicated than what it is. Like, water will find its horizontal equilibrium. The end. Ruhif. Don't make it more complicated than what it is.
I just posted one little picture of a crystal there. It shows how it's fluorescing, and it almost looks like a shadow on the back side, but it's just actually parts of it that are not fluorescing. It's not an actual shadow from the light.
Cool.
It's a shadow from the energizing light, right?
Well, I guess technically a shadow can be defined as like a dark area, but generally a shadow is usually, I mean, in the idea that the moon is reflecting the sun's light, it's the idea that there's something obstructing it.
So fluorescence is when an incident energy, a particle or a wave or whatever, hits a fluorescent material, and then it re-radiates that energy in a different, I guess it could be the same, but usually a different wavelength, right?
It can be that, yeah. I mean, some things just fluoresce without even any added, like some things just fluoresce on their own. Like in this case, you're actually adding black light to it, or to actually activate it. But in some cases, like bioluminescence, those things just fluoresce on their own. They just create light. Yeah, see, one of the definitions of shadow is shade or comparative darkness, as in an area. So even if it's like if the moon is fluorescing its own light and it's not fluorescing the parts that are dark, that would actually still fit technically the definition of a shadow, because it's like comparative darkness, versus another definition of shadow, which is something that is actually like something intercepting light that actually creates a shadow, like as we would commonly sort of, if you're standing outside and the sun's shining and then your body's in the way and it's creating a shadow on the ground.
Oh, maybe you mean luminescence, because fluorescence is the emission of light by a substance that has absorbed light or other electromagnetic radiation. It is a form of luminescence. So anything that's making light is luminescing, but fluorescence is that specific type or that specific situation when it's absorbing and re-emitting it. if that makes sense.
But if these,
Not always. It can also just be something that, like, one of the definitions of fluorescence is the property possessed by a substance capable of such emission. Yes, in some cases it can be reflecting a radiation given to it, but it also can just be, it just fluoresces on its own as well. I think it's both. Sorry, Bance, I didn't mean to interrupt you.
no, you're right. But these luminescent crystals, by nature, if they're emitting light, they could also too create shadows as well, couldn't they? By nature, if they are emitting light.
Yeah, like on something else, you mean?
Well, on itself, like whatever the moon is, if there were high points on the moon, whatever it is, it could create a shadow on itself too.
Yeah.
Like, just
Yeah,
just
exactly.
say, just say the moon was made up of these luminescence crystals, so it's got some sort of texture about it. Okay, and just say, excuse me, there was a crater there. All right, some sort of indentation. All right, well, that by nature, if it's been, if those crystals are being charged and then are illuminating, it would create shadows too, and which would be consistent because the way they are being charged would be consistent all the time. You know, it's not changing.
Yeah. I can see what you're saying.
Yeah.
The luminescence of the object actually creates its own shadows within the features of it.
Exactly. Yeah.
Yeah. It's interesting to think too. Ruhif was saying, I don't know if he's still in here because I'm not looking at the thing, but he was saying about how why does the moon reflect the sunlight? Because everything, the sun's beaming its light, so everything is, around the sun would be. I mean, it's interesting that, like, if you have a full moon, in my viewpoint, of course, the Earth, the sun and the moon being above a planar stationary Earth, a full moon, there's no light from the sun that's going to be reaching the moon because the moon is on the other side of the plane. It's too far away. It's nighttime, etc. You're not getting any sunlight. So in that case, that isn't happening. And so the moon would be just, in that sense, just fluorescing its own light and so on. But when the moon is like closer to the sun, in the crescent phases and so on, it is interesting. Like the sun may be lighting up the moon in that case. Like if it is like a celestial crystal and it does emit its own light, like, how when you see kind of like, you only see the crescent, that's the part that's fluorescing. But when you see the crescent, it's fluorescing, but it's close enough to the sun that you see it like out in daytime. You also can see, the rest of the moon, but it's not fluorescing.
Yeah.
So it's like maybe that actually is sunlight bouncing off of it or hitting it and kind of lighting up that other part of it, but it isn't actually the part of it that's fluorescing.
Mm-hmm. And it's strange sometimes when you see that effect during the day, where you see that crescent, and then you can see like the outer rim of the moon, and it almost looks like the unlit stuff is almost transparent. But you can see the slight outside edge, if you know what I mean. But it's like the stuff that isn't, you can almost see straight through it.
Yeah, it's like a semi-translucent celestial crystal that when it fluoresces, it seems more solid, and then when it's not fluorescing, it's like a semi-translucent crystal.
Gio, did I hear you sort of cast doubt on like whether a full moon is possible on a globe, heliocentric?
No.
Okay, you understand a full moon in heliocentric model? Yeah. No issues with a full moon on heliocentric model?
I just don't even know if it's worth my breath to respond to that.
No, no.
Well, I'm just checking. Like you seem to
Well,
cast doubt on
I
it.
mean, if you ask me what I know what a full moon is on a heliocentric, that's beyond obvious. But are there any conflicts in the general concept of a full moon in a heliocentric model? In my viewpoint, not particularly. No.
Okay, cool. That's all.
I mean,
No,
there are
Bandy
some
was saying something
there
about
are some issues and things, but it just in general, yeah, because more or less, it's all right.
okay. So Bandy was saying something about like being transparent or translucent or something.
I was saying the moon appears during the day to be almost transparent.
Yeah, you understand why, though, right?
You must have seen that.
Yeah, but do you understand why? Yes.
I've never actually looked into it, but sure there's a explanation for it. But
They use like
it's
a Rayleigh
blue
scattering.
sky.
Rayleigh
Yeah,
scattering.
exactly. It's basically the sky. The sky is in front of the moon.
Well, that's
only the lit up portion. That's not a very
thorough. That's not a very thorough.
Did you see what you said? The sky is in front of the moon. Duh.
Yes, the blue sky. The blue sky. The blue sky is in front of the moon, right? The fact that it's blue, that is what is in front of the moon.
Did you think that I thought the sky started after the moon?
Well, some people do think that.
What?
Some people think that you can see through the moon, whereas you're just not seeing the unlit portion of the moon because of the sky. The sky is lit up with Rayleigh scattering. It's in front of the moon.
Yeah.
But that doesn't really describe why you see the whole circle of it. It's not just a blue thing. You actually see the rest of the circle, and sometimes you can even see some of like the features that are sort of translucent. So it's not just
lit up portion.
So it doesn't really explain it.
The lit up portion or the unlit portion?
The okay, so if you have like a crescent moon in the day, let's say the crescent is fairly small. That part is obviously the crescent. We know that's lit up and so on. The rest of it, the rest of the circle, let's say, is not just blue. So it's not just Rayleigh scattering like the way you're describing. You actually can see the outline circle of it, and you can even see some of the features on it. And it also looks transparent, translucent in certain ways as well.
I've never seen anyone demonstrate that.
Like when stars can be seen through it in the day, for example.
Stars cannot be seen through the moon.
Yeah, they can.
No, they can't.
You know how many flags, like ancient flags that are still used now that show the star through the moon? All like in countries.
You're using a flag? You're using a flag as evidence of seeing stars through the moon?
Well, it's just such an ancient, well-known thing that it's ended up in the symbology of a lot of these flags for certain countries. That's
not evidence, Pierre. That's not evidence.
Star through the moon. I didn't say it was evidence. I said it's a symbolic reflection that it's been known for eons of time that stars can be seen through the moon.
I would love to see some evidence of stars through the moon. It doesn't exist.
Oh, there's tons of. You haven't seen those?
I've seen some blacked out pixels that are obviously not stars. Oh, sorry, whited out pixels.
Okay. I thought you've been in all this long enough to see that, but maybe you haven't seen it.
Yeah, you cannot see stars through the moon. You can see stars disappear behind the moon. That's easy. You'll see a star, you'll see a star, you'll see a star, and uh-oh, moon's covered it up. Bye-bye star.
So the answer is a buggered pixel.
Burnt out pixel, basically, yeah.
Okay.
In your astrophotography camera.
So then why do so many flags represent?
I don't know, don't care.
Okay.
Yeah.
On Earth being so, and when we look up at night, we see stars and the moon.
Here we go. Mute again.
We do.
We do.
Hey, Nate.
What's up, man?
You sound tired.
I am, Bears. You know, newborn problems, man.
Yeah.
Paternity leave isn't what it's cracked up to be, man. I'd rather
No?
be back at work, to be honest. Yeah.
Did you give
Really?
birth? Did you give birth yet?
Yeah.
We did Saturday, July
Yeah.
30th. Yeah.
Congrats.
Thanks a lot, you.
Mm.
Have you looked at the chart yet?
What chart?
On July 30th, the chart of your child.
I don't know how to read those charts, man. Her mom does that stuff. Like her mom already got her like a set of birthstones for her and all that weirdness. I don't really understand that stuff.
See if I'll pull it up with the bot. There it is, July 30th. I didn't put a time in or a place, but there's a bot on here that you can pull up charts.
Okay, I'm gonna save that and show that to my girlfriend. Maybe she'll be able to make sense of that.
Mercury moon opposite Saturn. A Mars Uranus conjunction square Saturn. So it's a T square. Uranus Mars with a T square with Saturn and Mercury and the moon.
Does that mean she's gonna be rich? Or
No, this wouldn't show that. This is showing the archetypal blueprint of that the entire lifetime.
okay.
It's the natal chart, the birth chart. So it's like the foundational archetypal dynamics that are present for the life.
Oh, I mean, what kind of information can I source from that? Like, what does that tell me about her? I mean, this stuff doesn't make sense to me, Gio. It's. I wish I understood what it is you were saying, but it's just I don't know. Maybe Bandsaw can translate. Bandsaw, could you explain this chart to me?
Well, I'm just
Not
tentative.
at all.
I'm
No.
just tentative to dive. I'm just tentative to dive into it. I actually have to step away in a minute. And I'm not. I mean, I'm
Okay.
not trying to like take the conversation into a whole nother realm because it's a whole thing. But I mean, essentially, each of the wandering stars, the planets, etc., they just represent a particular like archetypal dynamic of human life. So, for example, Mercury is connected to the mind. Everything connected to the mind. So, thinking, writing, talking, communicating. It's the logos. It's the communication.
So she's gonna talk a lot.
Well, no. So I'm just saying, like that's just Mercury in general.
Uh-huh.
So, for example, she has Mercury in conjoining with the Moon, so she'll have her Mercury, her mind, thinking, talking, etc. There's actually multiple things that are connected to her Mercury. It looks like her Moon, Saturn, Mars, and Uranus. So there's a multiple dynamics going on. But each of the luminaries represents a particular dynamic. So like Mercury is communication. Saturn is connected to discipline and multiple like time, like Chronos, time. But Saturn is actually a complex archetype. There's a lot of dynamics. So I'm not trying to go through every single one because it's a lot, there's a lot to say about it. But what I'm saying is that in general, each of the luminaries, or if you want to call them planets, has a particular archetypal component to it of human life. And then the way that the chart lines up essentially is each of those archetypes is then interrelated and connected in certain ways, like in that chart. So if they're close to each other or conjoining each other, then those two energies are combined. Like, for example, she has a Mars and Uranus. So Mars is generally connected to like being assertive, taking action, athleticism. It's kind of that it is the sort of the male archetype, even though both men and women have Mars. But it's all about, it could be connected to anger, aggression. I mean, these things are multi-leveled, and then Uranus is that principle of like liberation and breakthrough and, changing the status quo, breaking up the status quo, etc. So like a classic archetype of that combination of Mars and Uranus is like a freedom fighter. So the freedom is the Uranus, that's the liberation, freedom, etc. And then the Mars is the fighter part of it. So freedom fighter. Freedom fighter is a classic.
I don't want to
Mars Uranus combination.
It sounds like she's going to be difficult, Gio.
Well, you can't. I mean, for a brand new child, you can't, like, each one of these, like, an archetype has multiple ways of expressing itself, even though it's still within that archetypal field. So it doesn't mean she'll be a freedom fighter. That's just one possible expression of those. Sort of like chocolate cake. Like, there's a lot of different kinds of chocolate cake, but there's also a similarity to chocolate cake. And it can, so in this case, like, there's the elements of Mars and Uranus, but there's a multitude of ways that Mars and Uranus can come through. So, like, analyzing a chart of a child that's just been born in a way is limited, because you can't really know exactly how they're going to express these dynamics. They could express them in positive ways, negative ways, etc. So you can't really make, predictions in that sense unless you have some psychic ability. But you can see which archetypes she's born with and in what relationships that they're within. So, like, certain potentials, certain characteristic potentials, and knowing about it can be profoundly helpful to then navigate the life as well, to be aware of the dynamics and possible conflicts and so on.
Interesting. Yeah, I was hoping for a boy, man,
Oh.
But it is what it is.
Is it your first or second or?
Second. 2 girls now, man. Fucking cursed.
Give it a few months and start again.
Yeah, but her mama doesn't want any kids for a while, man. I think this one took a lot out of her.
Eh? Buy her flowers. She'll be all right.
Flowers fix everything.
Yeah. Pretty much.
Okay.
Out of the blue. Just out of the blue for nothing. It'll be all right. Yeah.
Yeah, I'll think about it.
Well, that's cool. I'm glad it all went smoothly.
Thank you, Jeff. Yeah.
I'm sure you're not going to give her any jabs and she'll be all.
Oh no, we gave her crazy jabs already. She's already got a hepatitis B jab, polio drops. So I think in 3 months' time, she's gonna go for an updated round of jabs. She's gonna be pretty jabbed up by the time she's 7 years old. Yeah. Just to make sure she's all good and healthy.
You think that's the way to do it?
Yeah, I mean, I'm jabbed up. Her mom was jabbed up, and we just fine, So I don't see why we shouldn't do it. Oh, you were vaccinated as a kid, weren't you, Gio?
Yeah.
Yeah, and I mean, you sound fine, healthy, I don't see what the worry is. I mean, it would be difficult to have her in public schooling if we didn't jab her up, right? I ain't trying to homeschool nobody.
What do you think about children that are not jabbed at all and they don't have any diseases? They don't have polio.
They are lucky, very lucky. And very rare as well, It's not like there are that many kids that,
Have you had allergies in your life?
Yeah, I had allergies as a kid, but I mean, they went away.
I think those are caused by the jabs.
You think so?
Oh yeah, definitely.
Interesting.
And they sell a lot of allergy medication. Also autoimmune diseases.
Interesting. But I mean, if they went away and all the allergies did was, make me fluey and give me hives now and then, but nothing fatal, like it's worth it, right?
Somebody was saying last night the idea that they're putting something in the jabs that makes you believe in a globe.
Yes, I remember that. Yes, like a little nanobot got injected into you. Yes.
Well, actually, I know this girl who didn't get any jabs at all when she was a child. She like went to Waldorf schools and the whole thing. And like when I told her about like flat Earth, she was like, "Yeah, that makes sense." Like she instantly didn't have resistance to it. I don't know. I mean, that's an interesting thought, though. Whether there is something in them that kind of, makes you go with the status quo, or like something like that. Like maybe not exactly like a globe gene per se, but something that kind of creates like more of a following the authority kind of component in the brain or something.
Oh, something that makes you like passive. Interesting, but
Yeah.
I don't know, man. People have believed the Earth was a globe before we had, vaccines and these sort of things. So, but it is an interesting idea that medicine makes you think Earth is a sphere. It makes you more susceptible to the idea of Earth being a sphere.
Or if they if they found certain genes that basically that humans express, when they like follow the herd mentality or something like that, like survival genes or something like that, then if they have found a way to kind of like either stop that gene or, in a way that would make people a little bit less willing to actually think for themselves and be free thinkers and have more of a tendency to, it's like shutting off that gene that would cause you to think outside the box or kind of, think differently than the rest of the tribe and somehow kind of create some kind of alteration in that sense that would have you like follow the herd in a way like a little bit more blindly, perhaps.
Just for clarity's sake, though, this isn't something you actually believe in. You just spitballing and hypothesizing, and you believe this is like there's like a 2% possibility of this actually being true, right?
Well, I brought it up because somebody had said that the other night, so I was bringing it up in that context. I guess that I haven't thought too deeply about like that part of it. I mean, what I was just saying right there is kind of the first time I've thought of that. If there is some kind of gene that sort of shuts down independent thinking in some way, so I wouldn't say I've come to a conclusion myself on it yet. I mean, I definitely think for sure that there's things in there that cause autoimmune diseases and plants cancer cells, which are encased in these like biofilms, and then the cancer doesn't develop until you're 50 years old, but it was actually implanted in the jabs you got when you were a child. Autoimmune diseases, immune system dysregulation, a lot of those factors I think are definitely happening. But it would make sense that there's something in there that changes a gene, because there is a tremendous, I mean, people talk about, the sheep that are all following, and I'm not trying to criticize any viewpoint. I'm not saying, oh, you're a sheep if you believe a globe. I'm not using that as some kind of a put down. I'm just saying that there does seem to be a tremendous amount of people that are sort of following. Now, whether that's just human nature or whether it does have something to do with that. It'd be interesting to do studies of people that didn't get jabs, and then, whether they're kind of more independent thinking and are open to new ideas, that either question or go against the mainstream narrative. Like that'd be an interesting study to do.
Maybe a bit of a topic change. Is that what it is to be an independent thinker? Just someone that has views that goes against the mainstream narrative? Generally. Is that what most people would define as an independent thinker?
Everyone should be an independent thinker.
I suppose so. 'Cause, I mean, the word independent, it's independent from what?
But what if, I have an idea that goes against the mainstream narrative, and I go down that rabbit hole. I try to verify or falsify my idea. I do observations, research, and whatnot. And at the end of the rabbit hole, I realize that my idea was wrong. I'm still an independent, free thinker, right? Or
Wait, say it again. Sorry, I kind of missed it.
like, let's say I have this idea that the moon emits a cold light, right? It's not reflecting the sun's light, and I do experiments and observations to try and verify and falsify that idea. And at the end of my journey, I realized that the idea I had was wrong, and that the popular mainstream narrative is right on this. I'm still a free thinker, right?
I suppose so. In that general definition, yeah.
Okay.
I mean, if you were willing to go outside of just what you were told and test something for yourself and validate it.
Okay. Yeah, because I've been told by a few people on your side of the argument that wouldn't make me a free thinker. That I would only be a free thinker if I stuck to my initial premise, And I did find that interesting, that's how they viewed, that's how they understood what a free thinker is.
Well, I guess in this context, I think of this as if you're willing to actually think on your own and consider any thought without just defaulting to what you've been told, just that in and of itself, like willing to be like, okay, I've been told X, Y, Z. I'm going to hold that in one possibility, could be true, but I'm going to actually think freely of that, independently of that. And if I still come to that conclusion, then great, I've just validated that that's the case. But having not having to be attached to what you were told, but having the ability to think for yourself or do your own tests and I mean, I think it's like weird in schools where they're like, oh yeah, like think for yourself, but then like you got to get all these answers right and think the way we want you to think. It's kind of think for yourself, but think this way when you take our test because you got to get all the answers the way we told you.
Oh, but you can get really good marks if you've put the right answer in the right box, though. Really good marks.
Yeah, and then you can get a great job that pays you money to also not think independently, because if you go outside of the box, you're not going to get the funding anymore.
That's right. Yeah, sacked.
It's like think freely within this cage. As free as you want, but it has to be within this cage.
But are we ready for a topic change? By any chance?
Sure. Since this topic clearly bores you, Benson.
Well, no. I'm getting sick of typing, actually, and seeing as Jesse is in the chat. I'd much rather talk about it than rather wear my thumbs out in text. So, hey, Jesse.
How's it going, Bandy? Is that what they
Yeah,
call it?
good. Yeah, mate. Yeah, much rather chat about it than type about it. So, yeah, tell me about your little observation that you did.
All right. Let me get a diagram that will show the setup from the top view, roughly. Basically, I had two flashlights, 48 inches above the water's surface. Okay, here's a picture incoming.
Your mic is kind of low, Jesse.
Yeah.
I'm not sure why. I don't know if you're far away from it or it just went
Sorry.
low. Oh, that's better.
I had the boom stuck up by my ear. I don't know why. I must have been eating earlier.
And now I've got to turn him down. Because I just turned him up.
I could put it up by my nose. Is that good?
Yeah, no, you're right.
Well, it almost seems like the default volume is a little high because I actually already had you at 80, but it was super quiet before. So.
So 4 foot above the water.
Yes.
Yep. Okay.
And here's a picture that shows the lake I'm at and the 3 points that are in pretty much a line, basically.
Okay. Yep.
And then you saw the side view that showed the 3 flashlights. There's the 2 flashlights in the telescope, right?
Yes. Yep.
So obviously the question is, how did the light from that further light pass underneath the middle light to reach the observer? If they're all the 3 points are all exactly 48 inches above the water.
Okay. Well, my question, like I said to you earlier in text, is like, why would you do an observation with flashlights and telescopes and stuff over water, and thinking that that's kind of definitive, seeing all sorts of crazy things happen over water with optics and light?
Well, why I chose this spot is because it was the only spot I could find where I had a common water level reference for all 3 points, and I had a line of sight over any significant distance. And so that's why I did it there. Do you have a reason that I shouldn't have, or a reason that somehow I guess look, I made assumptions. This is what I did. Where did I go wrong, I guess?
Well, I just think making the observation over water in the first place with light and optical devices, I don't think it's very accurate. Now,
So you
that's why I asked, like, an observation over a direct measurement. Like if you've got a lake that you've got access to that is fairly still at times, you could do measurements of that light, of that lake. Sorry, not the light, to confirm any change in its surface.
Any change in its surface compared to what?
Yes. Well, the Earth model says that it would be curvature, and water will, you know, when fairly stable and at rest, will have a horizontal equilibrium. So you could test those two things at a lake. So you could see if the surface of that water was horizontal and planar, or you could confirm for yourself if it was indeed actually curved, instead of solely relying on an optical measurement, because there will be anomalies.
So how would I measure for curvature or lack of it without using light? I mean, what's straighter than light that I could use as a reference?
Well, you'd make measurements, wouldn't you?
But how?
Well, you'd set up your little auto level, and you'd set up your stakes, and you'd go from one stake to another stake, and you would put reference points on them. You would correlate those reference points to each other to make sure that they all line. Very time consuming and labor intensive process to do it, but that would be by far be the best way to go about it. And over a mile, if you are fairly accurate, you should be able to quite easily be within the 8 inches of apparent drop you would get over that mile, even with any human error. You should be well within that, so you should be able to confirm it.
Sir?
Instead of like I said, just relying purely on an optical observation over a fair distance than what you did. I think there's too many anomalies to be taken into account of inaccuracy. This is my personal opinion on that.
So you do realize, of course, that differential leveling works the same on a globe as it would on a flat Earth, right?
Well, you do double rodding and stuff like that, which would take out all those anomalies as well.
Double rodding doesn't.
Massive.
Yeah, double rodding doesn't help any, because the point is you still have. I mean, it increases your accuracy, but it doesn't change the fact that differential leveling would work the same on a spherical Earth as it would a flat Earth. So we can't use that to measure the shape of the Earth.
Well, you can create a horizontal line quite easily, all right? It is not too difficult. Any surveyor can do it. Any surveyor can do it quite easily and quite confidently.
Okay,
So,
may I ask 2 questions?
yes.
Okay, so the first one is, do we agree that when you take an auto level and you shoot to your back sight 50 meters and your front sight 50 meters, that defines a horizontal plane, right?
100%. Yes.
Okay, good. Now let's say we move forward 100 meters. Now our old front sight is our back sight now. And we create another horizontal plane. If the Earth was a sphere and we've moved the auto level, will it have leveled to a slightly different angle that's out of parallel to the previously created plane? If the Earth is curved.
If the Earth is curved.
If the Earth is curved, will the horizontal plane at the second setup be out of parallel to the horizontal plane at the first setup?
100%.
Okay, so you can see that if the Earth was curved, doing differential leveling would create a whole bunch of connected horizontal planes that were all out of parallel with each other, and it would just curve around the Earth, and it would work just the same on a curved Earth as it did a flat Earth. Does that make sense?
Yeah, let me just pull up something here. Just give me 2 secs. Jess. Or Jessie, sorry, not Jess. Because I want to get it spot on for you.
You're just saying the horizontals and verticals would be the same. It's just that if the Earth was curving, it would curve independent of those horizontals and verticals.
I'm saying that when you moved forward your 100 meters and did your back sight and your foresight and formed a plane, a horizontal plane there, that horizontal plane would not be parallel to the first one, because you're on a different spot on the curved Earth and you had moved relative to the center of the curved Earth, and so level would not be, the plumb would not be parallel between the two places on a curved Earth.
On a curved Earth, every time you move your plumb, it would be different.
Right. And that would cause differential leveling to follow the curve of the Earth.
Yes, but then you're when you are doing your double rodding, your reference points wouldn't line up because your plums would be different every single time you move that auto level.
What does double rotting mean to you?
Right. Well, basically, you use your points as references to check that you are still on the same plane. That's what you're doing to maintain the same plane.
But I mean, so let's say.
Otherwise, if you didn't, right, maintain the same plane and check it behind you, and you were just working in front of you every time you move that order level and just continually moved forward, you wouldn't notice that you were off your plane. You would definitely make that curved line that you are referring to.
Okay, so let's say I'm doing a leveling run. I've got a back sight behind me, 50 meters behind me. I've got my foresight 50 meters ahead of me, but I haven't shot to it yet. And all of a sudden, the boss says, "Oh, double rod this one." What would I do?
Well, the exact process that I haven't done myself, right? I had a really good article on it, on how to go about it, but it seems, and I'm trying to find it for you right now.
Thank you.
So I will find it. I didn't mark it. I will find it. But I can definitely see what you say. I can definitely see what you say. If you weren't to check where you've come from and you were just working ahead of yourself, that you could potentially create that curved line, all right, and be unaware of it, okay? But if you check behind you to where you've come from, because you've moved your plumb, it wouldn't line up. You would be out.
You're looking for that double rotting, right?
Yeah. No, I got a really good article on it. And you would think, because I cleared my cache, so the highlighted sites aren't highlighted anymore. I'll get it though. Give me a minute. Keep on going though. Keep on going.
Well, anyway, I think double rotting is when you sight to two foresights, that like one kind of ahead and to the left and one ahead and to the right. And then when you move forward, you sight off the backs of those, and then you do two spots ahead, a little bit to the left and a little bit to the right. It basically kind of reduces your margin of error by increasing your number of readings. It's not actually sighting to your two previous back sights, like Spot On says.
Like Spot On, Seth. Who's Spot On?
Oh, he's some guy that told me about a way to do it, where he told me the same thing. He says you take your auto level and you go along post by post and you build out this straight flat line. And but he said you need to line up to your two previous back sights to make sure that you're not, whatever, I'm not sure.
There's actually a recording on this channel where I rang a geodetic surveyor and asked him all these questions about creating a horizontal line and how he would go about it. And his first answer was, well, he would use a GPS. Right, that was his first answer. How we go about it? He uses GPS surveying equipment because it's far quicker to do that. I went, okay then. So how would you go about it? the old-fashioned way. Well, apart from being very time-consuming, he said that one of the methods that he would use would be double rodding. And it's actually on this channel where I replayed the phone call that I had with this gentleman.
Do you have a link to that?
So the channel, the episode, I could not tell you. It was, you know what? And trying to find it would be hard, but there was a few people. It was actually quite funny because I rang a rifle range as well on the same day and played that recording. And I asked him, I'm trying to sight up my rifle and I want to allow for Coriolis. And how would I go about allowing for Coriolis? And their answer was ring NASA, which was quite amusing at the time. But it was at least 2 or 3 weeks ago. But let me see.
Well, that's all right.
I've still got the recording, actually.
You can also just drop it in my DM if you come across it in the next few days or weeks. I would enjoy listening to it.
Just
I've
real
actually
quick.
got
Real
sorry,
quick.
Joe.
Just a 2-second interjection because I'm not trying to derail what you guys are talking about, but I was just going to say it's interesting how much the globe earthers will talk about refraction, but then somehow, you know, they can get these long distance sights and detect a Coriolis difference in a target. It's bending this stuff all over the place.
I'll see if I can download the actual conversation for you, Jesse.
Okay.
And send it to you in a DM because I still do have the conversation.
Perfect.
Recorded, or the telephone call anyway. It was a pretty light-hearted conversation and whatnot, but but it was definitely, you know, I definitely asked him the questions, or the question was, can you establish me a perfectly horizontal straight line? He went, yeah, of course I can. That's what I do. That's what I do. Okay. And it was actually funny. It was actually funny though that when he said that he had to use his GPS surveying equipment, he said that he would to get that horizontal line, he would have to allow for the curvature of the Earth. Whereas, cool, just got your message there.
That's just so when you find it, you're like, now, who was that guy?
Yeah. Nah, I'll find it. I'll come across it, and I'll send it to you. Well, sorry, I've just got to work out how to download. Send it from my file on my phone.
Yeah, so
but I'll work it out for you anyway.
Yeah, super.
So it was actually the equipment that he used, the electronic equipment that he used. He had to allow for the curvature of the Earth, but the manual optical equipment that he used, he said basically he would just do this double rodding method. And that was just like totally someone out of the blue, someone that's 500 kilometers away from me.
Okay. Yeah. So, is it okay if we move on to where I was heading?
Yeah. Go back to your light over water. Yep.
Well, yeah. So, about using an auto level. Picture you were on a sphere and gravity was perpendicular to, or down was perpendicular, for whatever you want to call it. Down was perpendicular to the to the surface.
Down. It's always down. Yep.
Yeah, plumb is down. Plumb is perpendicular to the surface wherever you are on this hypothetical globe, sphere, whatever. And let's say you had your auto level set up, and this sphere is just smooth. There's no elevation change. It's just smooth, round sphere.
Yep.
And and you shoot
Fill
to
your
your
ball.
back sight, and
Mm-hmm.
it reads 1 meter on the rod.
Uh-huh.
And you shoot to your front sight, and it reads 1 meter on the rod.
Mm-hmm.
But due to the curvature of the sphere in this hypothetical, and this is not Earth dimensions, this is exaggerated for illustration,
Yeah.
picture that your auto level is actually 1 meter and a centimeter. It's actually 1 centimeter above 1 meter. But because you're in between the two rods, they both read 1 meter, right?
Mm-hmm. Mm-hmm.
So then what happens? You're like, okay, they're the same height. You go, you move forward 100 meters. Now you're 50 meters past your last peg.
Yeah.
You sight to it, and it reads 1 meter. You're like, okay. You flip around to your foresight, and you read it, and it reads 1 meter. So you're going to read 1 meter, 1 meter, 1 meter, 1 meter, but your instrument is actually 1 meter plus a centimeter. But you didn't know it because you were measuring differentially between those two pegs. So can you see how differential leveling would work the same on a globe as it would on a flat Earth, right?
I think differential leveling is a little bit different to the double rodding method.
Oh, is differential leveling not? Is that not? You don't use? Do you not use a auto level with differential leveling?
Yeah, you do, but it is done.
No, I described differential leveling. I just looked up a diagram on the Google, and the Google knows it all.
Apparently, yeah.
Yeah.
Yes. Well, then, I don't know. But anyway, let's move on. Let's move on. All right.
But you were saying that I should use a better way to establish a straight line, and I think I've just shown that using an auto level in short hops would not guarantee a straight line unless we already knew that the Earth was flat. But since that's what we're trying to measure, we can't assume that, right?
Well, if you were to, all right, let's just draw this out in our heads. Okay.
Okay.
All right. So you set up your auto level, okay, at point A, okay, and your height is 1 meter, thereabouts, and you shoot ahead, right, 100 odd meters, okay,
Okay.
and that's 1 meter too, all right, but you're saying that because of the curvature of the Earth, that is actually higher than 1 meter. Okay, that very first mark that you make from the first mark or the second mark, it's actually higher than 1 meter. Yeah. So then, okay, so you're at point A and you're 1 meter above the surface.
Okay.
Well, that's where your horizontal is going to be made from, 1 meter above the surface at that point, right? And you shoot ahead and you're 1 meter, okay, at that mark. So now it doesn't matter. Now it doesn't matter how high you are above the surface, right? You've made that first horizontal line from point A, okay? So it's a perfectly horizontal line from point A. Yes, we agree?
I'm not sure if I followed.
Well, from point A, where we have the auto level initially, okay? So we've set our plumb, okay, and we're shooting forward a horizontal line. So now it doesn't matter what the height above the surface is. That's our horizontal line that we are establishing. Would you agree?
It's horizontal in that it's level at the point of the auto level.
It's horizontal from point A at the auto level.
Yes.
You agree with that? Okay.
Yeah.
So now out into free space, straight out. That's our horizontal line that we are following. Okay. Now, from there, right, we now move our auto level, right, to point A or point B now. Okay. So now we've moved it
To point B.
to point B, right, and we set it up. Okay. And we get it plumb. Okay. And at point B, and we shoot back to point A. Right? Now
Okay.
we're shooting back to point A. Right? Because point A, the very first point, right, we have established our horizontal line.
Did it?
Okay.
I'm not sure I'm following. We
Okay.
we removed the auto level from point A, right?
Yeah.
And
Yeah.
we put a peg in at point B, right?
Yeah.
Okay, now
Now,
we've got the auto level at point B.
at point B. All right. So now the
Do we
two
have
marks between point A and B, right, are horizontal from point A.
Say that again?
You agree?
Let's say it again.
Okay, at point A, our starting point, okay, we set up our auto level, right? And we shoot our line out into free space towards point B. We make our mark on point B. So now the line between point A and point B is horizontal with reference into back to point A. It's a perfect horizontal line. You agree there, yes?
With reference to point A, yes.
Yes, with reference to point A. Now we move our auto level to point B, okay? And we set it up so our auto level is at the same height, okay? And we shoot back to point A.
The
And
same
we
height.
yeah,
So,
we shoot back to point A.
so how
Okay.
high is the auto level at point B?
It's at the mark that we've made.
Okay.
Okay, at the mark that we've made. Okay. Then we shoot back to point A. Now, on a globe, right, on a sphere, those lines can't marry up.
Correct.
Exactly. All right. So if they don't marry up, right, it's no longer going to be on that horizontal plane. So now we have to adjust on a globe for our third measurement. Okay, going to point C because we're no longer on the same plane.
Right.
Okay, then. So as soon as you've moved that auto level to point B, you've changed plumb.
Correct.
So if you are referencing back to point A, okay, they won't reference up. If you were doing that back foresight, they won't marry up.
Right.
At all.
And
They can't.
right, and that's why when you're doing a level run, you put the auto level equidistant between your pegs.
I'm talking about creating a horizontal line from point A. So that's your datum point. Point A is your datum point, your initial starting point. Right? So you want everything to be horizontal from point A. You're not starting at point B and going to point A and then to point C.
Okay,
You're not doing that.
So continue on.
You're starting at point A, right? And then you keep that horizontal line, straight line, going all the way through. And you can keep on doing that by keep on referencing back to your original datum point.
So, and this method would work on a curved Earth?
No, it wouldn't be a horizontal line on a curved Earth. Well, it could be. You could make a horizontal line on a curved earth, but then you would have to then adjust the tilt of your auto level, I suppose, by doing that. And you
Okay.
don't do that. You don't do that because your auto level is always set plumb, and because you set it plumb, it creates by default a horizontal line every single time because it creates plumb. That's how an auto level works. It creates plumb, and automatically it creates a horizontal line within itself.
Right, but I need a method for creating a straight line that does not depend on an assumption of Earth shape, right? I can't assume that the Earth is flat and then measure for it, and I can't assume that it's a globe and measure for it. I need some way to build out a straight line that would still be a straight line regardless of whether the Earth is flat or curved.
No, you want to create a straight line, and then once you have created that straight line, and that's what you want, right? Regardless of planar or curved, you want a straight line, and then from that straight line, you can then establish your reference point that you can measure from, right? So then from that horizontal line that you have created in free space along your marking pegs, then you can measure something, for argument's sake, like the surface of water, and you can reference it to that horizontal line. So regardless on a curved earth or planar, right, you would have a straight line. And then from that straight line, you can then determine planar or curved, because the water itself on your model will curve. Okay, and then you can go, oh, okay, then I've gone a mile out. It has deviated from this straight line by 8 odd inches. Very simple.
But how do
That's the method you'd want to use to establish that curvature.
But how do I get the straight line to begin with without assuming a shape for water?
No, you're not assuming any shape whatsoever. What you are doing is establishing a straight horizontal line.
Okay.
Once you have created a straight horizontal line, you can then determine, right, what the shape is underneath. So you can either establish the shape of the terrain underneath it, right, elevation changes, or you can establish water. You're going to establish, the shape of the so-called Earth, right, being curved, right. You can establish many a thing by having a reference point, a datum, which you can make all your measurements off that. That's how surveying is done. They have a reference point. They reference everything to. That's what you want. That's why they use datum points to reference from. Yeah. Can you not see how by establishing a horizontal straight line gives you all the reference that you need? Are you talking, Jesse, or have I cut out? You're lighting up and I can't hear you. Is it me?
No, I can hear you fine.
Okay, it must be Jesse. Jesse's lighting up, but I can't hear you, Jesse. You're lighting up, but I can't hear you.
Ha! There. How's that?
Oh, God damn, I can hear you now.
There's a mute.
Yeah,
there's a mute button on my headphones.
Yay!
Yeah. Okay.
yeah.
So
So can you see how establishing a straight line, all you need to do is establish that straight line, and that straight line, which would be horizontal, right, is the only reference that you need to establish anything. You
so
don't
let
need
me
anything else.
so let me ask you this. So let's say I use my auto level. I set up a back sight and a foresight, 2 pegs with my auto level. So now that gives me one segment of a straight line, but it's only 100 meters long, right? So then I move my auto level forward 100 meters, but now if the Earth is curved, the next segment of that line won't be straight with the first segment, right? If the Earth is curved, because the auto level will go perpendicular to plumb, and plumb will be at a different angle, and so level will be a different angle, and so if I just keep doing this, my 100-meter line segments they'll be forming a large chunky curve, right? Because it won't form a straight line on a curved Earth, right?
No, if you reference back, so if you set your auto level right at the height of your point B, okay, so now you're on the same plane, right? And then you can reference back to your point A.
How can I be on the same plane when I'm not on the same level, the same angle of level?
You can get the height of your auto level, right, at the same height of that horizontal line. Okay.
But the next sighting I do won't be the continuation of my previous line, right?
If you're at point B and you sight back to point A, right? If you are on a different horizontal plane, it won't line up. How can it line up? You're gonna have to tilt, aren't you?
You
If you
can't.
aren't on the
You can't tilt it. It's an auto level.
exactly.
So if the Earth is curved, I would be creating a curved line, which won't help me, right?
Mm,
Do you,
but you won't be. You can't tilt it. That's what they're designed to do. They're designed to create a horizontal.
so
They're not designed to create a curved line.
so is there any way to use an auto level on a spherical Earth to create a straight line?
You wouldn't be creating a straight line. It doesn't happen in reality. You only create horizontal lines with the tools.
Did you say I could not use an auto level to create a straight line on a globe?
Yeah, no.
Yeah, no?
Yeah, no. No, yes. No, you can't. Definitely, definitively not. You
Okay.
wouldn't.
Okay. So how then can I create a straight line in a way that would still be a straight line even if the Earth were a globe?
That'd take a lot more mucking around.
Well, do you have any ideas?
Well, you'd have to tilt things. And auto levels aren't designed to be tilted,
Right.
are they? They don't by definition. They establish plumb and they establish horizontal. That's what they do. They're not a tool to establish angles. No.
Well,
That you would have to use a theodolite for. But if
okay.
you're going to be using an auto level automatically by default creates plumb and horizontal. That's exactly what they do. Every single time you use any tool that references plumb, whether it's a pipe layer or an auto level, any of these tools, automatically by default they create plumb and horizontal. A bubble sextant does exactly the same thing. It creates plumb and horizontal by default. That's why we can use these tools with accuracy, right? Because this is what they do, right? They create plumb and horizontal lines.
Right. So, but what I'm basically, I used light as a single hop over the lake for 3 miles, and you're saying basically that's not a good way because there's a better way. And so that's what I'm asking is how would I do better than that?
I'd be measuring it. I wouldn't just be making an observation over over water with light. Personally, myself, I'll be taking a direct measurement or making a direct measurement.
Do you mean like with a theodolite?
With an auto level, I'd actually measure it myself.
Over what distance?
Okay. Oh, see, it's a fairly big undertaking to do, actually, to create a line. You would think it'd be fairly simple, but it's a fairly big undertaking. So to create a line, a straight line over a mile or two, I reckon they would take you the best part all day, if not 2 days, to do it with a high degree of accuracy. It's
But
very labor intensive.
but how would I even do it if I don't know whether the Earth is curved or flat?
I said well, I know how I would go about it. I've told you exactly how I would go about it with confidence
But
myself. Now that's how I would do it. Now, for $1,500, right? For $1,500, you don't have to worry about doing it. Right? You can employ that. Well, yeah, $1,000, $1,500. I don't know what it costs in your country. About $1,000 here to create a straight line. Right? Just get him to create a straight line next to some water. Boom, happy days. Job done. End of discussion. We should get, we should get maybe I don't know, 3 or 4 surveyors side by side doing it. Boom, all create a straight line for us. Have the great surveyor survey off, we could call it, and get them to do it.
how would they do
But,
it?
well, I would use an auto level myself.
But that
How they
assumes
how they would go about it, and what I'm told in this realm, how they would do it, from many of people that actually haven't done it, is what they say. But I've had a lot of practical experience with these things and created many a horizontal. My time to have to lay pipes and stuff. And I'm very confident because I have not had to go back to any of that work for any warranty work. My water has never backflowed on itself, funnily enough. Never had to worry about things like that because I've created my horizontal lines and set my gradients appropriately
of course
to my
what
horizontal lines.
what grade are you shooting for? Like a 1 in 50 or something?
Generally, it's about 4% thereabouts. Generally, about 4%.
Right. That's so much that Earth curve error wouldn't even come close to matching that.
Tell you why, you want to get it spot on, get drunk. You got a little bit of wiggle room in there, a little bit of tolerance, but you'd much rather be over than under. I can tell you that right now.
But anyway, I just illustrated how using an auto level would work the same on a flat Earth as it would a curved Earth. So,
I don't think so.
well, remember the illustration about if we were on a perfectly smooth spherical Earth and you had your auto level 1 meter and 1 centimeter high, and you were shooting to your pegs and they all measured exactly 1 meter high. And then you move to your next point and you look back, your peg is 1 meter high, the forward sight is 1 meter high. So you're literally going around this curve, but because the angle of down is changing at the same perpendicular rate as the surface of the sphere, your auto level still sees all those pegs as the same height, even though they're on a curve.
Can I just quickly say something?
Hey, Ralph, how you going?
All right, bruv. Yeah, good, man. Nice to talk to you always. Would the auto level change as you went towards the poles because the dip angle is going to change?
Is that for him or me?
For either of you.
I think it's fair. To what? Because the dip angle would change according to gravity.
Well, you've got I think the inclination map of the world. So when you stand at the magnetic equator, then it's horizontal. When you go towards the north, then it'll dip down, and when you go to the south, depending on which compass you use, it should dip down in the south if you're using the southern compass. The point being is that if we're using it alter level, and the magnetic dip changes towards the poles, then surely this alter level will never be level.
I'm not sure what the magnetic dip has to do with an auto level.
Because if you are holding a compass vertical, right, that would allow you to see what your dip angle is. So if that horizontal there changes to, as I'm walking towards the poles, then I'm never going to have a level.
Oh, no, I can't answer that question. I've never even heard that question.
Yeah.
There might be some confusion in there.
I think, technically speaking, according to the spherical model itself, because of the way gravity works, you could never establish a horizontal line at all, because gravity varies depending on where you are on the Earth. It's not consistent. It's not exactly to the center. So instead of being that curved horizontal, be a wavy, curvy horizontal line. Can't even believe I'm using the word horizontal with curved, actually. But anyway, you know what I mean. Because according to the globe model, if you were to create their curved horizontal line, it's in accordance with gravity. But because their gravity varies depending on where you are, it wouldn't be a perfect curved line. It would waver all over the place.
Yeah, but this trick here with a compass, when you make it vertical, so you've got the screen facing you from the side and not pointing upwards, you've got yourself a lever. And when you walk towards the north part of the needle starts moving down. So
really?
it's a yeah. And then if you use a southern compass in the southern hemisphere and you go south of the magnetic equator, then it'll dip towards the south. So there is an actual like gradual slope that eventually goes from horizontal to vertical. So that compass needle, when you hold in it vertical, if you know what I mean, that will align vertical. Whereas at the magnetic equator, it'll align horizontal. So there is I know what you're talking about, the gravitation between me and the person that's a mile away or whatever. I get that. This one here is actually measurable. And therefore, that's where we say our magnetic pole is. Now, I would say a compass. Anyway. So on the dip angle, I would say that my orientation with I was looking east to west or north to south, depending on where I was on the Earth. I don't think I was on a level unless I was at the magnetic equator.
Possibly, you might be right. I really don't know, to be honest with you.
So you're right about the magnetic poles and the dip angle of the magnetic field, but it's irrelevant for an auto level because an auto level does not use or depend on the Earth's magnetic field. So I don't see any relation.
Yeah, it just relies on on down. Yep, on downity.
This is the Earth's horizontal field, not its declination that we use by compass from left to right. So if everything that when you're moving towards the pole, if everything starts sloping towards down or dipping down, everything will dip down. Doesn't matter what you got. If you've got a pole and you're holding a pole in your arms and you're walking towards the pole, you'll find that the one side of that pole would be heavier. That's all I can say. Anyway, I'm sure it's so small that you wouldn't even fucking notice it.
Well, the force of down and the force of magnetism are two separate things, and they're at different angles. Yeah, I don't think it has anything to do with an auto level.
I guess it would depend on what the auto level's made out of. If it was made out of wood or plastic or anything that's not conductive, I would say, yeah, it's going to be a good thing. But if it's made out of metal or anything that is influenced by a magnetic field of the inclination, I would look that up.
Well, I've never seen anything about it in the spec sheets, but anyway, if you find something, bring it to us. So I guess here's the difficulty I'm having, Bandy.
Yeah, buddy. Yeah.
I use light over a long shot over a lake because that's the best thing I can muster.
Yeah.
All of the alternate suggestions for establishing a straight line that you've come up with all assume a flat Earth, and if the Earth were curved, then they would not make a straight line. And so, do you see my dilemma here?
Well, no, they don't assume a flat Earth. I don't think.
But using an auto level and expecting to get a straight line assumes that all plumbs are parallel, right?
Yeah, and if they weren't, you'd be able to see that, wouldn't you?
Hey, Bandy.
Hey, Terry, where have you been?
Oh, I've been around. I've just had things going on here, family stuff.
Oh, okay. Well, I hope all is good. All is good.
We've done a experiment with I'd say use two auto levels, or maybe the one, across the distance from point A to point B, and then went at point B back to point A, and he found an interesting result from this observation.
How long?
The distance.
Yeah.
Distance.
Is that like the reciprocal zenith?
4 kilometers, so 4,886 meters. So that's 4 kilometers.
Why the hell is he doing it over such a long distance, Terry?
Well, that's a good way to do things, isn't it? If you do them over the longest distance you can possibly do.
No, not if you want to be accurate. Not if you're trying to establish a.
Well, the longer the distance, the more discrepancy there is in the measurement.
No, the more
Well,
discrepancy.
instead of being 1 millimeter difference, there might be meters in difference.
No, then you're going to get more discrepancy with what you're looking through. You wouldn't get a surveyor on the face of the. If I said to a surveyor, all right, go out and do this job for me, but all you can do is use your tools 5 kilometers apart, he'd laugh at me. He'd want me to sign some sort of waiver so he wasn't responsible for the work that he did.
I read up that Robotham, when he done the Bedford level experiment, he went back and revisited the experiment, but he faced the opposite way, and then he found a discrepancy. He didn't account for something, but it was funny that it's written about that he's got 2 tests, and one was good and the other one was different because he changed his method. He was looking in the opposite direction.
So on a flat plane, I'll just post an image. If you're sighting an auto level from point A to point B, they should both line up to each other, shouldn't they? You should be able to see the crosshairs should line up to the other auto level, wouldn't they? Within a few millimeters, anyway.
Not 5 kilometers apart. Not a chance. Not a chance.
Well, why not?
No way. Because you're 5 kilometers apart. Come on, guys. Come on. That's a silly argument to say that I'm going to use one of these tools 5 kilometers apart. Come on.
And they're both level from one another?
Ain't going to work. Ain't going to work. Do it properly. Measure it properly. If you're going to go to the trouble of doing that, actually measure it properly. Create that horizontal line in free space. Do it.
Well, that line is in free space.
No, yeah, and you're creating a horizontal line, and you're viewing something that's 5 kilometers away. I just find it rather silly myself.
May I
But
ask a
that's just
question?
me. Yeah, of course, Jesse.
Oh, I thank you, sir, kindly.
Go, buddy.
So we agree that light over 100-meter distance is reasonably straight, right?
Light.
Well, that's how, when you sight through an auto level, you're using the path of light to establish that plane, right?
No.
Are you
Not at all.
sure?
100%. Why would you be using the path of light to establish anything?
Well, if the path of light isn't straight, then how come you can look through the telescope on an auto level and know whether the peg 100 meters away is above or below that plane?
Because you are looking through the auto level, telescope, theodolite, whatever you're looking through. What does light have to do with it?
Because if the path of light is not straight, you would have no idea how high or low the numbers you were seeing were on the rod, right? I mean, if the light was curving up and then down or all around, you might think you were looking at something, but it might not actually be in the direction you were looking.
But what path of light?
The light reflecting, you mean the path of what light?
Yeah, exactly.
So,
Light.
let's say you're looking through the telescope. You see the rod. You see this white background with the black numbers and the red numbers, right? The sunlight is hitting that rod and reflecting off of it. That light that you see then takes a straight line from that rod into the telescope, right?
Is it?
Well, I think so. Do you think otherwise?
Oh, not at all. Yeah, 100% I think otherwise. Yeah.
So what path do you think the light takes to leave the rod and enter the telescope? So that
I don't think it's taking any path, personally.
Well, let me put it this way. If you were looking through the telescope and I were to hold a silver dollar up, do you have silver dollars where you are? It's like
yeah, close enough. They're not silver.
But they're they're almost the diameter of the telescope, right?
Yep.
Okay. So let's say I go and I hold one of those up. If I get it in just the right spot, I will block your view of that rod, right?
Yeah.
Okay. So if I were to take that silver dollar and move it a meter at a time from one end to the other and find the perfect spot to block your view, that would follow a straight line, right? All the places that I would put the silver dollar to block your view of that rod, right?
Yeah. I'm following.
Could I block the view by placing the silver dollar any place other than directly between the telescope and the number on the rod that you're looking at?
Probably not. No.
So doesn't that suggest that the light that you're seeing is traveling in a straight line from the rod to the telescope?
Nope, not at all.
Because it's not traveling?
Yeah, well, no, you're presuming that light is traveling at all. number one, you are presuming that the sun hits that rod and now is bouncing out off that rod in little information packets through the air into the telescope and then into my eye. That's what you're presuming light does.
Well, what exactly light is, we don't have to understand or even agree on, but the point is it acts like a straight thing that can be blocked at any point with a silver dollar along a straight line, right?
No, you have blocked the image. You haven't blocked the light.
So the light goes through the coin, the silver dollar?
Or it's behind it, it's in front of it. Like, it's not in darkness, is it? But you haven't blocked the light at all. You have blocked the image, not the light.
So you're saying that the light is still getting into the telescope, but you just don't see the image?
Well, when you put the coin between the telescope or the theodolite or whatever viewing through, okay, and you're halfway, right, between yourself and that staff, your little silver dollar, right? Can you see the silver dollar?
Yeah, it might be out of focus.
Okay, might be out of focus. Yes, but you're still seeing it, aren't you?
Yes.
Okay.
If there's light shining on it.
Well, because it's illuminated, exactly.
Maybe we could simplify it. Instead of looking at a rod, let's say you're looking at a tiny little laser pointer, but it's so dim it doesn't hurt your eye, but you're looking at it and you see this bright red spot looking through the telescope. It's a nice pencil-thin beam all the way from the laser. All the way from the laser into the telescope. Okay. If a slight fog comes over, we'll see that laser beam light up, right?
Yep.
And if I place the silver dollar such as to block that beam, then you won't see the laser, right?
Not at all. No.
So am I blocking that light with the silver dollar when I do that?
100% you are. Yep.
Okay. So does that light from the laser to the objective of the telescope have a path?
100% it does. Yep.
Okay. Now let's say I defocus the laser, so instead of a beam, it's more spread out. Will the light that doesn't hit the objective lens of the auto level, will you see that light through the telescope? The light that doesn't hit, that's too spread out, it doesn't go into the objective. Will you see that light?
I presume you may see like a halo around that coin, so you'd probably be able to see something. Maybe, yeah. I don't know. I've never tested it, but I'm going to say you'll probably see some sort of halo-y effect around the coin.
Yeah, I haven't put the coin in yet. I've just spread the laser.
Oh, okay then. Yeah. Will you see the light? Yes. Yep. So,
will you be seeing only the light that enters the telescope lens, or will you be seeing light that never even hits the telescope lens?
I'm going to say, never done this now. I'm just trying to think about it, but I'm probably going to say that it'll look like the light is coming from a central point, okay, and fanning out. But I don't think it'll, because you'll only see a point, right? Because like if you're pointing that laser at the telescope, right, in a little beam, right, you're going to see like this little point of light. You're not going to see the line itself, but you'll just see this point. But then if you fan it out, that point now will probably look brighter in the center, all right, and then slowly, get dimmer and dimmer. The more you fan it out, but you're not going to see the path of it whatsoever. You'll just see the light, unless you're from a side-on angle.
Right.
Then you may see that kind of cone effect.
So let's say I step into the middle of the line and I hold that silver dollar such that it casts a shadow on the objective lens of the telescope, just the size of the objective lens, so that the lens is entirely shaded but the laser is shining all around. Will you
Yep.
see the laser then through the telescope? No light from the laser is entering the telescope. Will you see light from the laser then?
With this cone-shaped now laser you're talking about?
Yes.
Yeah, well, like I said, it may appear as though there's kind of a bit of a halo-y effect around the coin. Depends
But
on how wide it is.
but very, very faint compared to the original direct beam, right?
Yeah. I think you might have a dark spot in the middle, so you can't see the source, but it may look similar to the very first image, but you'll just see a dark spot in the middle. Won't be as bright in the middle, but yeah, you are definitely blocking some of the light getting into the laser. I'll agree with that. Yep.
Okay, so let's say we set up an auto level, we leave it in one spot, and we put a stake in every meter, and we pound it right in until it's just flush with the crosshairs, vertically flush with the crosshairs. Actually, it'd be easier to start at 100 meters. We start at 100 meters, we pound a stake in until it's just flush with the crosshairs, and then we move it, say 10 meters in, pound another stake in until it's just flush with the crosshairs, and another stake and another stake and another stake. And then we take a laser beam and we shine it across there. Would the height of those stakes be the same profile, the same elevation profile that a laser beam would have?
Yeah, if you got a decent enough laser.
Yeah, assuming so. Yeah.
Yeah. So if you do it over a shorter amount of distance, you probably could get a fair degree of accuracy. Yeah. But
Okay.
yeah, the further you go, the laser diverge. The further you go, we all know that. But over a short distance, yeah, things should line up. Yeah.
So if I did this for a 100-meter run, and then I put just like a telescope, never mind an auto level, just an adjustable telescope, I can aim it up, and I sight it along the tops of all those posts, they would appear all at the same height, right? Right, like a, okay.
Yeah, over a short distance, yeah, they will. Yeah.
So if I then had someone sighting through a telescope along those and had him start putting in more stakes, lining it up, would that continue the straight line, or would somehow after 100 meters would it veer off in some weird angle?
Well, you wouldn't want to be doing it over any length at all, because then you are going to get inaccuracies. But I'm still trying to get the correlation between we see like this light in straight lines. You still
faded up.
Married that up. Yeah, like you've been. Sorry, is that better? I'm still trying to get the connection between this light in straight lines thing and how we see.
So I guess my question is, if we agree that we can use optics to establish a straight line at 100 meters, then why not 200 meters? What changes at the 100-meter mark that somehow what changes at the 100-meter mark? Why is 200 meters or 400 meters or 800 meters, how is that different than 100 meters?
The conditions that you're looking through.
Describe those conditions to me.
Oh, they could be any sort of conditions. Just the basic atmospheric conditions itself. I know myself when I have used these auto levels over very short distances, okay, that depending on the conditions of the day, right, I can get high inaccuracies. And when I say high inaccuracies, I'm talking maybe anywhere from, a centimetre to to maybe 2.5 centimeters in the morning, and in the middle of the day when things have cleared up, I'm back to where I should be. So depending on the atmospheric conditions of the day, of morning, the afternoon, all these sorts of bits and bobs, they can affect what you are looking at, because what you are looking at in the medium it is in is affected.
So it would affect the first 100 meters too, then, just not as much.
Oh, yeah, but that's why you do things over a short distance. Like if you're using these tools to establish any sort of accuracy, you don't want to be using these tools over a length of 50 to 75 meters maximum. Right? Now, when you're talking about distances of 5 kilometers, that's just insane because of what the optics are and where you are viewing that object. And I don't think it's got anything to do with the light that's bouncing off that object into your eyeball at all. But it's where that object is and where that object, that atmospheric conditions around that object, right, what it does to it itself and also to what you are looking through.
So I guess what I'm hearing is that you don't think it's reliable, but you don't have an explainable, observable phenomena as to why it's not reliable.
The atmosphere itself is the phenomena.
And what does that do?
It changes what you are looking at. Does
it make things look higher or lower?
It makes things look exactly how they are, right? And anything over a distance, the closer something is accurate it is, the further away it gets from you, the more these atmospheric conditions affect what the image that you are looking at. That's why we get any sort of phenomena that we're looking at over a long distance, whether it's over land or over water. You see miraging and whatnot over land, but all of a sudden, the closer you get, they disappear. Right? Similar sorts of things over water too. You see these phenomena, but the closer that you get to what you are looking at, the image itself clears up and you can resolve it better because of what you are looking through. Everything is less distorted, less refracted, less mirrored, less whatever. But the closer you get and the more you reduce the effects of what you are looking through, the image is resolved clearer and more accurately.
Okay, so when I'm looking, when I have my telescope at 48 inches above the lake, that's like 1.1 or 1.22 meters.
Yep, 4 foot, yep.
And I've got the two flashlights spaced out exactly the same height above the water.
Yep.
What exactly is going on to cause the middle light, or the light in the middle of the distance, to appear 1.5 feet higher than the light at the far end?
Well, you've got all those atmospheric conditions. You're doing it over a body of water, which is going to have all sorts of water effects due to temperature, evaporation, all these sorts of things that are in the atmosphere directly above that water line itself. So you're in the worst possible medium itself to be making this observation. You're very close to the water where all these particulates are going to gather very, very quickly before they dissipate. more and more. So that's what you're doing. You are viewing through this this density layer that you've actually got no idea what it's doing. And if you talk to someone, say like Ruhif, right, this is the worst possible place, and he's on your side. Right, this is the worst possible place that you could be doing this observation, which is down close to the surface. Right, you want to get way above the surface to be doing all these things with any sort of accuracy whatsoever, because he'll refer back to his 772 terabytes of downloaded weather balloon data. Yes, this is true, because he'll invoke refraction and all these sort of bits and bobs when anything is close to the surface, right? And he is one of your big guns on the scene, one of your big guns, right? This is his subject through and through, and he will tell you with no doubt whatsoever that over the surface of close to the surface of anything is the worst possible place to be taking any observations. Shout out, Rui.
Okay, but what specifically would be happening to cause these two lights that are at the same height to appear at different heights? Or is it just a light thing that you don't understand how light works? That's an honest answer.
Well, do I understand how light works? No, I don't. And I don't think anyone knows how light works itself. Now, what we can do is we can reproduce light, okay, and we can channel light and we can direct light, okay. But what light does itself, no, I don't think there is a reasonable explanation at all. And if you want to consider, at all what light does through, just presuming, just presume, okay, that you're correct, okay, and light travels in straight lines, okay, and we'll go with that for a second, okay. So this light is traveling in a straight line, okay. So can you show me or demonstrate to me where refraction and all these sorts of calculations that are worked into things have been demonstrated and scientifically analyzed over a spherical or curved density gradient, right? Because you can show me a laser through a fish tank of sugar water, okay, where the laser light will bend down. We've all seen that common theme. I'm sure you've seen that one.
Yes.
Jesse, okay, and fine. Let's go with that. All right. Can you show me exactly the same thing done that is over a curved or spherical density gradient and what it does? Because what you have done there, you have demonstrated something of what light does and how you think light works, right, in a planar environment, right, not in a curved or a spherical environment. You have demonstrated what it does in a planar environment. So you are taking what you know about light in a planar environment and you are attributing that to a spherical and curved environment. Now, to me, light is going to do something far more dramatic in a curved or spherical gradient, because the way the light hits all those different particulates, and because it is in a spherical curved density gradient, the angle at which that light hits those different particulates is going to also to react and act differently of those different particulates, which changes the angle to the next particulate and the next one, so forth and so on, and having a much more dramatic effect one way or the other. And I haven't seen that demonstrated at all with any sort of clarity at all. Everything that is shown, everything that is demonstrated is done over a planar or horizontal gradient.
Well, we don't. I mean, that's what we're disagreeing about, is whether this world is planar or curved. So if you're wrong about it being flat or planar, then what we observe is over a spherical gradient. So I'm not sure what we're to draw from all that. But I do have another question.
Okay.
Do you still have that diagram showing the two flashlights in the telescope and the observer?
Hold on, let me scroll.
I posted it not too long ago.
Yeah, no, I got it now. Yep, I've scrolled back up. Yep, I found it. Yep.
Okay, so
yeah, got it.
The apparent position of the more distant light is about a foot and a half below the middle light, the light in the middle of the run. Doesn't it stand to reason that if somebody were to be standing at that middle light and hold, say, a large silver dollar, maybe like a sand dollar or something, down a foot and a half below the middle flashlight there, that he would block the view of the distant flashlight, right?
That he would block it?
Yeah.
Oh. In my head, with a hypothetical experiment, if that a person with a silver dollar would block the flashlight number one. Are you saying?
Is number one on the end? I don't even remember.
Yes. Yeah, number one's on the end. So you're saying that the silver dollar will block the one on the end, but not the middle one.
Right. See where it says red transparent filter?
Yep.
Imagine you hung up a hat there. That's right where the flashlight one appears to the observer. So doesn't it stand to reason that if the light appears there, that putting a hat right there would block the view of flashlight one?
Oh. Look, you know what? For the sake of moving the conversation, I'll agree with you.
Okay. So, but the hat is not even between the observer and flashlight one. So how is it possible to block light that's by placing something that's not even in the path that light is following? It's not even between the source and the observer.
Well, how is it possible? Did you say?
Yes.
I said I would put it down to the atmospheric conditions of how we see things and where we see things.
So let's say flashlight one was actually a laser beam instead, a nice pencil laser beam, and it appeared. We agree it would still appear at the same place that flashlight one appears for the observer, right? If it was in the same position as flashlight one.
Yeah. How have you established that these flashlights in the telescope are all on the same plane?
I did it at a lake, and I used a 4-foot ruler and measured each one above the water surface level when I put them in. All the tripods were all standing in the water.
Oh, okay then. A shallow lake.
Well, it was right at the edge.
Oh, okay then. Okay. Yep.
Yeah. Did you see that Google Maps picture of the kind of the long, skinny lake?
Oh, yeah, a while ago. Hold on, let me. Too much. I'll find it.
I got it.
Oh, you got it? Yeah, post it again.
Yeah, it's uploading. My internet's slow.
Cool, Magoo.
Yeah, so you can see there was a point that stuck out a boat launch shore, and then
Yep.
and then on the right there was easy access. You can't see it, but there's a trail right down to there. And so
Yep.
I was able to get to the shore in those
Okay.
3 points in a line.
Yep. Okay. Yeah. Yeah. That yeah. Look, I just don't want to keep on just saying being a naysayer, Jesse, to be quite honest with you. But my answer is going to remain consistent, that it is the atmospheric conditions that you are looking through.
That's fair enough.
Right.
And I just
And
want to understand those atmospheric conditions.
well, yes, and I don't think that it is reasonable to be looking at anything over long distances with any sort of accuracy, especially when we are trying to measure them. Okay, we can only get approximations, because if we could do it with any sort of accuracy, if we could, right, we would do it all the time, right? We would save ourselves a lot of time and a lot of money, right, if we could do things over long distances. This
Right.
is why the professionals, right, do things over short distances. When it comes to any sort of construction whatsoever, they do things over short distances because they have to be accurate, right? So if they could do it with any sort of accuracy, right, that is reliable. Now you're talking over a distance of 3 miles, right? And you're wondering why we have these indiscrepancies of whatever it was, the difference in height, and you're putting it down to that light travels in straight lines. We've seen sort of stuff, but the professionals themselves know, Jesse, that these things that they do have to be done over very, very short distances, and they always have to refer back to their original datum points that they establish. So they always establish a datum point, a reference point that they always reference to, and they are always checking. That's why they get paid big bucks to do these things, right? Because things have to be spot on. They don't take it lightly whatsoever, and that's why I just find it funny that in this realm itself, that Terry came in before. We looked at something that was 5 kilometers away, and it was 2 foot in difference, but on a flat Earth it should be exactly the same. I just find these are just ludicrous statements to make. Get a professional out there, right, to do the same thing over 5 kilometers and get him to sign off on it. Not a chance in the world will they sign off on it, Jesse, because they know it is not accurate, right? But you get him to do the same observation over 50 meters or even 100 meters, right? And he's probably pushing it at 100 meters, right, to sign off it with a degree of accuracy. Okay, he'd sign off it. But when you start talking a mile, 2, 3 miles, not a chance in hell will they sign off on the job if that's all they can do.
Of course, they're trying to get millimeter, sub-millimeter accuracies. I don't need that for this because I've got a discrepancy of 1.5 feet, which is massively more than the errors of my instruments, even at that distance.
Yeah. But don't you think also too that the error that you are going to get also too is going to accumulate exponentially over the longer distance that you look through? It's going to accumulate. So if you've got a little bit of error between here and there, the more error it's just going to multiply, right? And exponentially just get worse and worse and worse and worse. And trying to equate a mathematical equation what this error may be over any sort of distance, you can't do it. You can't mathematically do it. in reality. If you could mathematically do it in reality, right, with any sort of accuracy, they would do it every single day of the week. But they can't mathematically do it because it is inaccurate. And they know this. It is inaccurate.
So would you say basically that the light from flashlight 1 is curving like the light in the fish tank with the sugar, but like a smile instead of a frown, and it's curving down, going through where the red filter is shown, and then back up to the observer, and that's why it's arriving at an angle that makes it look lower?
Well, I think there have been demonstrations that things and do refract up instead of down, depending on the temperature and all these other bits and bobs that go into it. So, these observations over long distances, I think there is evidence for both a smile and a frown, depending on temperature and environment, these sorts of things, altitude and whatnot. All these things kind of have to come into it.
So basically you're saying that what must have happened was that, because I was getting the discrepancy between the apparent height of the two lights was equal to about 8 inches per mile squared. So you're saying basically I was getting refraction that was lowering them by the 8 inches per mile squared rate. Is that it?
No, I'm not making an argument that it's conveniently the same as this 8 inches per mile square at all. Was it done when did you do it? Was it like first thing in the morning, late at night? Like, what was the temperature? Just out of curiosity.
Oh, I don't know what the temperature was. Probably 60s.
So what's that in degrees?
Oh,
In
like
centigrade?
20 or something? I don't know.
Okay, so a reasonable day. I think. Look, there are better people in this realm that know the ins and outs of this sort of refracted effects of stuff with temperatures and whatnot. But yeah.
So would it be safe to say then that all the apparent missing height that matches the globe model could be just caused by the bending of light at the rate of 8 inches per mile squared?
I'm not going to say that it is convenient that at all. Right? I'm not going to say that at all. I'm just going to keep on saying that I think it is a inaccurate observation myself, Jesse.
Okay.
And and I'm not gonna put up a rigorous fight one way or the other.
Right.
Okay.
So would it also be reasonable to say that if light can bend at the rate that I observed in here, that it could also be bending the other direction at the same or greater rates and could allow people to shine lasers 20 miles over the water?
Look, how light works in exactly what sort of conditions and all that sort of stuff. I don't think these things personally are a strong evidence one way or the other because of the refractive qualities that we can demonstrate with light.
That's fair enough.
Yeah, like I said, to me, a far more rigorous way to do it is a direct measurement. Okay, and I'm confident with the things that I have done over my life and the tools that I have used, whether it's these things of theodolites or pipe layers and stuff like that, they marry up to what I know that works. Okay. Now you can. It is, to me, it is convenient, right? That these margins of error on a globe are that small that you can't measure them. You know, whether or not, you know, for argument's sake, whether, you know, it's, if you're talking the curvature of Earth and gravity, all right. So
I put a pic in the chat for you.
oh, have you? Okay. What's it? Oh, okay. This curvature of Earth, with when we're talking about water, okay. To me, you know, I've never seen it, and I've never seen it measured. Now, I've worked on some rather large projects where it hasn't, to me, it hasn't been taken into consideration. But you know, with the comment that you made, like this refraction is equal to the 8 inches per mile squared, you know, type of thing, and this is why, we might say. It's like these measurements, these numbers are either way too big or way too small to measure. And generally, when we're talking about the curvature, they're way too small, especially when it comes to water. Like you can't measure it in a cup or fish tank or swimming. You know, these sorts of things, you can't see it because numbers, as you would agree, Jesse, like they're way too small, right?
Right, for equipment that I can afford, yes.
Well, for the equipment that anyone can, anyone, period. You know, is there equipment out there that can measure the curvature of the water over, say, an Olympic-sized swimming pool? You know, well, where have they done it? NASA conveniently pops in. How you going?
But you know, nobody's done this because nobody has thought about it. I think. I mean, who would waste? I don't know. It doesn't seem necessary to be done for anybody who's got this equipment. I mean, this is expensive stuff.
Right. The people that can afford it don't doubt the globe is the issue. But so do you see, Bandy, the difficulty here is it is very convenient that the curve, if it's there, is too small for the ordinary man to measure at 100 meters, and that's where you put the cutoff for using optics to measure geometry. Would you consider 1,000 meters plausible? Because my theodolite is rated for over 1,000 meters.
Yeah, your field light, your torch, you're talking about.
No, I own a total station actually, a Nikon total station, and it's rated for greater than 1,000 meters.
Yeah.
So, would you consider it a valid measurement if I use that at 1,000 meters in a single hop to measure?
I would ask you, like, have you run? Right.
You cut out.
Am I back?
Yep.
Okay. Cool. Like, do yourself a favor, Jesse. Do yourself a favor, right? And yeah, you got to do is you got to have a conversation with some of these professionals, right? And not talking about, you know, this realm that we're in, okay? And have an honest discussion with them and ask them what sort of distances that they would use these tools over with what sort of accuracy, right? And if you wanted them to do an accurate job, okay.
Could I respond to that?
Yeah.
So I have talked to some of them, and I have read a lot of other stuff. It is true that when they're surveying a plot for a Walmart, they use short hops. Okay, I'm not disputing that.
Yeah.
But
Yeah.
if you look in the in the countrywide survey maps, where they actually, the triangulation maps where they surveyed whole countries, you can literally see numerous long shots, 10 miles, 20 miles, 50
Yeah.
miles, because
Yeah.
because they were going from a mountain peak to a mountain peak, and
Yeah.
it wasn't practical to get down in between there. So
Mm-hmm.
um,
Yep.
when you have to do a long distance shot, you do a long distance shot, and it works, and that's what they're made for. And that's why mine is specifically rated for greater than, I think it said it could do 1,200 meters with a triple reflector, and that's, not only can it read the angles, but it can also read the distance at 1,200 meters. So it's fully designed to be usable at 1,200 meters or greater.
Why did you buy yourself a total station? Are you in the what's your field of expertise?
Oh, I'm a mechanic.
Okay, so why did you go buy yourself a total station?
Well, it started out as a bad habit. First, I got a theodolite and off of eBay cheap and fixed it up, and
Yeah.
then that was so much fun. I got another and fixed it up, and then pretty soon I started looking at total stations, and I think I paid $230 for it or something, because the battery was dead and there was no charger with it. So I fixed the battery and made a charger. And
Nice.
anyway,
Yeah.
sometimes I go back and look, and that same model's like $800. I'd never pay that for it, but anyway.
Yeah.
So
It's an interesting hobby to have for a mechanic. So did you get into it because of the debate?
Yeah.
Yeah, fair enough.
Yeah, well, December of 2018, a real life friend of mine says, "Hey, NASA's fake and the Earth is flat, and you've been lied to." And and I didn't yell at him. I didn't call him names. I says, "Well," he says, "check into it." And I says, "Okay, I'll check into it." So I started testing the claims that both sides were making.
Yeah, fair enough too. So it seems like you've a bit of time and a bit of money into this debate. Like you've taken a real interest in, and good on you for doing that. So then why don't you then like take it to the next step, Jesse? Like because look, I'm not gonna. I've got no intention whatsoever to prove anything to you. Like I'll have a chat with you type of thing, but I'm not out here to prove anything to you, mate. You've got to go do these things for yourself. So why not go out and establish a horizontal line with the tools that you've invested in, and use them for what they're supposed to be used for. Well, they're not designed really to be looking at flashlights over lakes. In all fairness, like they are designed as surveying tools. So why not take a day or a weekend and go, what, let's go out and do it, because to me it'd be far more definitive for you if you were to go out and actually do that for yourself. Considering what you've done already, you're buying them, you're fixing them up, you are, and good on you for going out and actually doing that observation. Like I don't poo-poo the observation at all. At least you've gone out and done something. But why not use the tools for what they're actually been designed, mate, and go and establish those lines and take some measurements and go, okay, then let's go do it.
But
that I would, if you were to go out and actually do that, right, I would put far more weight on something like that if you were to go out and do it.
But the method you're giving for establishing a straight line depends on the Earth being not curved.
Well, okay. Well, then what you do is okay, if you're not happy with what I would say, I would say once again, ring up a surveyor, which you may or may not have done, and say, look, I want to establish a straight line. I've got my total station, I've got my auto level. I want to go out and establish a perfectly straight line. Tell me how to go about it.
I've talked to them, and I already know how they would do it, but you wouldn't let me do it that way. Here's what they do. They say, well, okay, will survey based on the spherical vertical datum, and will add a vertical offset at each distance to counter the curve of the Earth. That's what they would do. At least that's what they say they would do.
So they would do. So they would do a calculation rather than a measurement.
Right. They would offset. They would give you. They would make an elevation profile, which was increasing in elevation at the rate needed to form a straight line on a sphere. In fact, have you heard of LIGO?
Oh, yep.
Have you seen the as-built drawings? You do big projects, right?
I've done big projects, but it's mainly been mainly with dam building.
Oh, okay.
Yeah.
Let me see if I can. Oh, here we go.
I know a little bit about LIGO and how they took the well, they had to take the curvature of Earth into consideration to make those arms perfectly straight.
I posted a picture for you, but it's just going to look like a line. So I took one of the. I got all 10 pages of one of the arms of one of the Legos, and I stitched them together so that you can look at the entire arm as one wide picture. So you have to. It's like really skinny because it was 10 pages side by side. So you click it to make it bigger, and then you scroll right to left. And you can see their elevation profile is a curve of 8 inches per mile squared. And yet they say it's straight because they wanted it straight for this laser beam inside this vacuum. And so this is what a surveyor is going to do if you hire him to make you a straight line. He's going to say, well, it'll be level. He'll say, well, where do you want it level? It'll be level in one spot if you want.
Yep.
And then it's going to, on an elevation profile, it's going to curve up, but it will be a straight line. That's what, if I hire a surveyor to come out and do it, that's what he's going to do, right?
Yep. If I hire a surveyor and I say I want a horizontal line, right, and he's your starting point, bang, yep, and then he's going to work from that, and then the elevation, or the topography underneath that line is going to vary 100%. Yeah.
But the as-builts for LIGO, did you get that picture? LIGO
Yeah,
staged.
that little skinny one. It's pretty hard to see even with open original. Hold on, I'll open original. It'll make it easier. Blow it up better.
Yeah, you have to. It's like
yeah. I basically know. I know what.
Right. So, may I use that technique? May I produce a straight line using a curved elevation profile, just like LIGO did, and then compare that to the lake?
Well, aren't you? Well, see, like you're now presuming a curved elevation, aren't you?
Exactly, and that's what a professional that's what a professional licensed surveyor would do if I hired him to make me a straight line.
Well, the surveyor that I spoke to, it did say that he would have to take into consideration the curvature of Earth when he was using his GPS setup. Okay, so he did say that, but nothing about having to do calculations or anything like that was mentioned when he had to use his auto level. Like he only had to calculate things using his GPS.
Well,
and yeah, you use your GPS, right? And yes, they work, Jesse. 100% they work. Right? I'm not going to disagree that they don't work at all. No one is going to deny that they work. but now you're doing calculations. But with an auto level, I don't have to do any calculation myself. I just work on plumb.
How about this? Could I establish a straight line using the elevation profile right from LIGO's as-built plans?
Would you?
Yeah, would that be acceptable to you?
Well, how would you do it? Because LIGO is built at where LIGO is built. Unless you're building your line straight at LIGO, nothing would marry up, would it? You're in a different.
Well, but on their
area.
profile that I linked for you, they have it shown relative to 63 feet.
Mm-hmm.
Or is it 60? Yeah, 63 feet. In the middle, it's 63 feet. At the ends, it's 64 point something.
Mm-hmm.
So I could just subtract 60 from that. I could start my straight line at 3 feet above the lake, and then I just use this distance and elevation profile and make my stakes following this elevation profile so that at the end they would be 4.12 feet above the lake, for example, and that would form this straight line that they used they would form a section of this straight line that they used in LIGO, right?
Mm-hmm.
And then that would show that the lake dropped off from this straight line that they used at LIGO.
I don't know, personally, myself. I'm pretty confident that I could create a horizontal without having to calculate anything. I'm pretty confident that I could do that.
But could you create a straight line even without knowing whether the Earth was curved or flat?
Well, like I said, I'm fairly confident that I could do it. Now, I'm pretty confident that I could do it my way, Jesse. All right, how I would go about it, and you and others think that my line is going to be curved. Okay, so I'd be willing to make a wager on that. I'd wager something, all right, and we can work side by side, Jesse, right? Side by side, like a meter apart, and you can use your method and I'll method, right, and then we can get someone to check it. And I'm pretty confident that my method would be spot on within a fairly high degree of accuracy.
Compared to a professional surveyor?
Yeah. Yep. Yep.
So you think
I'll just use an auto level. I won't use a GPS.
So what about the surveyors that surveyed LIGO?
What about them?
They didn't come up with that curved profile plan with auto levels.
Probably not. Did they use auto levels? No, they didn't. What did they use? They used GPS.
That or total stations.
Yeah, they probably would have used both. Gathering, but they probably would have used GPS.
Yeah, I think they just use that nowadays.
Yeah. Only because it's quicker, and they are fairly accurate when you set your datum point, because you're working from a datum point and an initial starting reference point, and you'd work from that. So as long as you've got that reference point, you can work from that, right? And that's where your signal would go back to, right? Always referencing that point. So that's what you'll be working off.
Well, work on. Do do you sketch at all? Could you sketch me a diagram of how you would produce a straight line that would work on both a flat Earth and a globe without knowing which you were working on?
Oh, I just just go about it my way, and then you go about it your way, and I'll be spot on.
But
I'm
see,
fairly confident with that.
but if I go about it by my way, mine will be different than yours, and mainstream surveying will agree with my way because I would just be doing it the way mainstream surveyors do it. So
Okay.
who's going to be the judge? Who's going to say who's right?
Well, we'd have to get someone to adjudicate, wouldn't we, Jesse?
Well,
At the end of the day.
well, there's I know a few surveyors, but does it have to be somebody I don't know? Do you know any surveyors?
I did. And yeah, I could call on one that I have worked with, definitely, or I could call on one that I don't know, too. But if we were going to do this side by side, we'd just ring one up and get him to come down and check it. Doesn't have to be one we know or one that we don't know. We just ring up a professional and say, "Hey, we've made these lines. Come and check them." You go, "Cool. I need the money." That's what will happen. He'll be happy to do it.
Yeah, for a charge.
Yeah, exactly. Of course, nothing's for free. Nothing's for free.
So, would someone like Larry or Kozlowski, are those guys not? Would you be okay with those guys?
Oh, come into the yeah, sure. Come, bring them all over. We'll have a barbecue. We'll have a wowver time. Yeah, bring them over.
No, I mean, would you be okay with them being the judge of who had truly established a straight line?
Yeah, well, yeah. Let's establish our straight. Get them to check it. Yeah, sure. But we've got to make those straight lines first, don't we? We're going to make them first, all right? Because at the moment we're just in thought experiment land. We like neither of us have done it, right, at all. Okay, so we're just thinking about doing it. So we've got to get from thinking about doing it to actually doing it.
Okay.
Right?
Well, since I'm not made of money and you probably don't want to spend what you have, how about we both write up a short description of how we would make a straight line, and then we can pass the two descriptions around to as many licensed surveyors as we can find, and they can tell us which one would be the true straight line.
So I've got to do homework, right? And I've got to write up a description of how I would go about it, and then email that to a surveyor and say, "Hey, will this make us?"
Right. Yeah.
Oh, that's an interesting.
And then I would do the same thing. I would write up how I would do it, and we'd send them both to each surveyor, and then they could say which one would be closer.
Gee whiz. Homework, Jesse. Man, you create me so much work, you do. uh, all right. You know what? I will consider it. All right. I'll actually consider it.
Perfect. Thank you. And
I will actually. I won't poo-poo it. I'll actually consider it.
And we could even make it easier if you can find the procedure you prefer in a surveying lessons book. Then you could just clip that out and use that as your method if that's the method you wanted to use.
Oh, so I can cheat. I can copy and paste. That makes it even easier.
Yeah, if it's the method, I don't think the method that you have in mind, if it really works the way you think it does, I don't think it will be in a surveying book. But if you can find a method that you think will do what you want in a surveying book, then that would save you from having to type it up. You could just...
Oh yeah, anything that would save me typing. Hate typing. As you can tell in text, I absolutely hate it. So yeah, if I can copy and paste something, happy days. Means I've got to read something though, Jesse. So now you're going to make me read. Like,
Oh.
God almighty, buddy.
Is your method different than standard differential leveling?
You know what? I'll
Let me get you a picture of differential leveling.
If I agree with whatever method I would copy and paste, I'll be happy to copy and paste it and put it in and be confident with it. Okay.
I'm trying to paste something here for you.
Oh, are you? You got to get better internet, mate. Flap your wings or something. My phone will.
There you go.
Go faster.
There. Do you see a little differential leveling diagram?
Your diagrams are so small. Even
You know,
when you open them up.
That's not even mine. That's I just pulled it off the web. But
oh, okay. Yeah.
So this is a standard method, and so if that's your method that you would use, then you don't have to even type anything up.
Yeah. You know what? Give me. Like I said, I'll think about. I'll think about it. I'll hunt around. I'll find something, and I'll send it to you as well as that recording.
Oh, perfect.
I do have to work because I actually made the phone call, but recorded it on. I recorded it on another phone because I didn't know how to record a phone call on the phone that I was actually using. So I used an old phone to record it, but it doesn't have the option of sharing the files.
Oh, right.
Yeah. So like trying to email it to myself or whatever to download it. So I may have to re-record it on my other phone, and hopefully because the quality was a bit crappy the first time around. You know what I mean? Because it was just the phone.
Yeah.
Kind of held up.
What are you guys talking about?
A phone call that I made to a geodetic surveyor that I recorded.
I found a bigger picture for you.
Oh man, bigger is better, they say. They generally say it's the way you use it, but the bigger is better.
Don't surveyors work on flat planes? Euclidean geometry?
Well, except when they're using GPS, apparently, Godric.
Right, but GPS it can ports to a globe, i.e., the conspiracy. So
Yeah. When they
of curve or flat.
Yeah, when they use GPS, they have to take into consideration in the calculations the curvature.
Yeah, but how do you know it's curving? GPS doesn't prove it's curving.
No, but when they use the GPS, right, they have to account for it so they can make a perfectly straight horizontal line. This was the conversation that I had with the surveyor. Because I asked him, can he establish me a perfectly straight horizontal line in free space? And how would he go about it? And his first answer was that he would use his GPS. And then he said he would have to account for the curvature of the Earth, right? Because I made the phone call in such a way that it wasn't in relation to this debate. I didn't want to let him know it was in relation to to a globe Earth, flat Earth debate. So I was just talking about basic surveying techniques with him, and the first method that he spoke about was using the GPS, and that he would have to take into consideration the curvature of the Earth to make that perfectly straight line, which was all fine and good. But when he was using his auto level, the curvature of the Earth didn't seem to come into consideration at all. It was a different technique, which I found interesting.
Don't
what
you
if
think though, just
GPS
the
was
fact that he was
actually?
don't you think
Hey,
just the fact that he was a surveyor, he might be aware of the discussion though?
well, you were there for the phone call, Dave, weren't you? That I replayed.
Yeah,
You
I
were there.
heard.
Yeah.
I mean, just because he's a surveyor, he might pay attention to anything that has to do with that, or just you never know. I mean, if he's you
No,
wouldn't think that he's actually if you don't think the Earth curves, you don't think he's actually taking the Earth curvature into account, right?
no. Well, I don't think the guy fairly innocent of it. So I don't want to read anything more into the conversation than what it actually was.
Is it me or you guys roboted?
Especially when they treat 600 nautical miles as flat.
Hey
It's
guys.
hard to imagine they would have to do any kind of curvature account.
Yeah.
Hey, I gotta take off. It is past midnight in my time zone, and so I gotta get to bed. But thank you so much. It was a pleasure, Bandy.
Oh, it was a blast, Jesse. We'll talk again, mate.
All right,
sure.
thank you, sir.
All right, catch you.
Yeah, the debunked videos. I think I sent it to Jesse last time he was bringing up LIGO. Or these contention with the LIGO claims is that they used GPS for the accuracy of the straightness or something like that, with the posts being high. I mean, they say that they poured the concrete to account for the curvature, but there's actually posts that are placed with the GPS being used. I don't know what that means necessarily, but there's a couple of videos that have to do with making that straight line in LIGO either valid or invalid.
Oh, okay. That's interesting. Have
What
you
was
got
the
that video?
challenge? Yeah, I'll post it. I'll post it for you.
Yeah, thanks, mate.
What was the challenge for you guys? You guys were going to make a bet about something?
Establishing a straight line. How would you go about it?
And you guys are challenging each other to come up with the best method, or?
Well, he just wants to know how he would go about it. And I just said, well, I'm quite confident with the way I would go about it would create a nice horizontal straight line.
What's your method again? Sorry, I missed the conversation.
Wow, I just use it. To get pretty much. Yeah, pretty much that. Okay. Oh no, that was Geo posting that. Yeah, pretty much a force the line type of thing, Dave. Yeah. But and then he wants me to write it up, and the method that I would use, and we get someone like Jesse Kalowski or Larry to be the adjudicator of what method would be best.
I wouldn't trust what Jesse Kozlowski advised.
Well, it's kind of like, yeah, let's write up a method and get someone in this realm to be the judge of the methods.
It does seem like there should be structures that have straight lines long enough to tell, right? It just seems like that. I mean, there's obviously that lots of structures should account for curvature that don't. So,
and then he brought in LIGO again, and saying that they had to account for curvature and whatnot, and yeah, if they've used a GPS system, they may very well have, but they are still referencing an initial datum point that they're working off.
I think I took a screenshot from one of the videos that I'll find for you, and it said that GPS is not an accurate way to form a straight line.
Oh, okay.
I know Kosho doesn't want to hear that. What's up, Kosho?
Here we go.
Got Whitewater. Lots of people in here. Look at this whole house, and nobody else is talking.
No, it's been Jesse and I for the last hour or so. Bounce.
Yeah, let's see if I can find where I posted it. So I won't have to just search it out again. I think I sent them directly to Jesse.
Oh, okay.
Like this, but
interesting.
Yeah, here we go. Here's one of them.
All these people and no one talking.
Yeah, wake up, everybody. Yeah, it's from Mobius Maximus.
Okay. The straightest thing in the universe. There we go. Damn.
You gotta go with the lies and lie with the goes.
Yeah.
There we go.
Yeah.
You know, that's what they were thinking when they made that too. They're like, this will prove straight line as well. This will prove we had to account for curvature. We got a little extra on our budget that way.
You know, it took a long time for them to get that budget.
Here we go. What are you doing, Coach?
You don't want to know what I'm doing.
Probably not. No, probably.
Big bag of cocaine.
You see that? I recreated tides on Earth.
Oh, did you? Interesting.
Ah, a little salt water and electromagnetism.
How did Earth become red?
I know. Tides on Earth.
Using the moon.
Did you see that thing quite some time ago when the illustrious Neil deGrasse said that Earth rotates within a bubble of water? Did you guys ever see that?
I've seen him say that, but I've known that for a long time, yeah.
So the Earth rotates in a bubble of water.
So to get this straight, the tides are ever changing. So throughout the month, you know, the position of the tides are going to be, you know, rotating, you know, and changing this and that. But however, our experience of the tides and our tide schedule is based on our rotation through that bubble. Yeah.
The Earth is or it isn't rotating in a bubble of water.
Well, I wouldn't necessarily call it a bubble of water.
Well,
But
you
yeah,
may not. but
It's rotating. It's rotating in what is the ocean? Yeah.
Well, how?
What do you mean how?
Well, how? How is the Earth rotating within a bubble of water?
Because when he says bubble of water, what he's really saying is he wants you to conceptualize, because the idea of the bubble he's talking about is just the shape that the ocean is making at any given moment based on the tidal forces acting on the water. So it's going to have a different shape, and that shape is going to stay fixed. It's not going to stay fixed, but it's going to be more influenced by those gravitational forces. The Earth's going to rotate into that shape. It's not necessarily that the water itself is moving. It's just that that shape, which is keeping form, is staying fixed, and the Earth's rotating in it.
That is an explanation in your belief of what he is saying. But he could as well be saying, from a standpoint of flat Earth, that the bubble of water is the whole universe, the electromagnetic bubble.
Okay. Well, I bet you $100 million he did not mean that, and that he did mean what I just
said. Betting has a great meaning. Yeah.
Well, I'm just saying what you just said, though. What is that? He of course didn't mean that.
You said of course he didn't mean that?
Of course he did not mean that.
Okay.
You can't bet $100 million. You don't have it. You only have 29 million stashed in gold.
Whatever I can't pay you, I'll work off as your servant.
Oh my God!
Why don't you do a bet that you can take, Kosher, like a gentleman's bet, handshake?
I can't take that one.
What?
Anyways, that's what he meant, though. Almost like if you see the thing I'm sharing on my screen, I'm showing the moon orbiting the Earth without the sun, so it's a little bit simplified version. But this is what the tides are doing in a given month, and then on top of that, every day the Earth is rotating in that, this shape of the oceans.
Oh, it's painful.
It's painful. If I can recreate this by simply using the same mechanics that were said that it is occurring, and it recreates the thing that we see in real life, how is it painful?
You've got Earth rotating in a bubble of water. Or a bubble of water rotating around the Earth. Either or, right? There's a bubble in a bubble.
The bubble's not a real bubble. It's for God's sake. It's a concept. It's a conception. Supposed to conceptualize this bubble as the form that the ocean is taking, which is going to be separate than because it's a liquid, so it's going to be somewhat fixed. The reason why it's not completely fixed is because as the Earth rotates in it, the undulations and shit like that will influence that shape as well.
Hey. Impressive.
Bada bing, bada boom. You want to know what's really impressive? That's nothing, dude. This is nothing. What's impressive is I calculated the distance to the moon this morning, or the sun.
No way!
And I got 93 million miles.
You did not. Get out of town.
Absolutely.
How did you do that, Kosho? How did you calculate the distance to the sun? How did you go about that?
You got a bad cough, man.
Yeah, I do actually.
I'm sorry to hear that.
Well, how did you calculate the?
I used Aristarchus's method and
No
measured.
way.
Yeah, I used timeanddate.com find the exact moment of the quarter moon phase, which will be in about 4 hours. 3 hours and 40 minutes. And then I found the position of the subsolar and sublunar point at that moment, and then measured the angle between them, and took the tangent of it.
Get out of town!
Yeah.
Get out of town!
That's it.
That is insane.
And doing that, I got 93 million miles.
Oh my!
Oh, I'm sorry.
Exactly.
Yeah, you have to multiply that number by the distance of the moon at that moment.
Oh, okay.
But yeah, if I do that, I get 93 million miles.
Okay. Did you establish the distance to the moon?
I used timedate.com, but I'd done that prior. So.
Okay. Okay. Cool. Fair enough.
Just for simplicity.
Simplicity. Interesting.
Yeah.
Interesting.
I rarely get impressed with myself, but I was.
Oh, it is impressive that you got 93 million miles, which just happens to marry up. I can't fault it at all.
Thinking like the Jesuits.
Oh, like it's all over. Kosho's done it.
No chance of error.
Aristarchus wasn't a Jesuit, though. I don't know where that's coming from.
I don't know. Have you seen his eyes? They kind of look rather Jesuit to me.
Okay.
Well, he's got beady little eyes. They're like fairly close together.
What are you talking about, Aristarchus's eyes?
Yeah, look at them. They're close together.
In God's name.
Yeah, have a look at him. He's got beady eyes.
Where am I supposed to see Aristarchus?
Like, would you buy a used car off that guy? Look at his eyes.
What are you talking about? When have you ever seen Aristarchus's eyes?
Have you never seen a photo of Aristarchus or a picture?
No.
Really? Why not?
Because he lived 2,500 years ago.
You've never seen a picture or a painting of him?
No.
No?
No.
There's no picture or painting of Aristarchus.
I've seen pictures of him that people drew long after he was alive. I don't think that they're accurate.
Long after he was alive, but no picture when he was alive.
Jesus Christ. You're missing all the points, man.
All the points. All the points.
There's nothing to do with Aristarchus and what he looks like.
Of course it does. So you've seen no picture of him, no portrait, no painting, no charcoal sketch or anything from when he was alive. You've only seen pictures of well after he was dead.
I think Bansor is questioning the validity of Aristarchus.
Well, you give everybody so much more credit than their due was. But let's take it. Let's pretend.
But Kosho, I feel if you give them enough rope, they eventually hang themselves.
Really? I don't know. I just said check out his eye. You know, Kosho was the one that said, but how? But how? I never mentioned the validity of any pictures of his eyes.
He does kind of have
that's why I said I think that's what you're doing. Because I can't see any other reason to bring up pictures of Aristarchus but for that.
No, I just mentioned these beady little eyes in which you buy a used car off him. And then Kosho Kosho was the one that then brought into the equation. Well, there's no pictures of him. Maybe he didn't exist because no one took a, no one took a photo or
was
drew
just
a picture of him. Like,
so yours was just a throwaway comment.
pretty
Was
much.
it had nothing to do with anything.
No, nothing at all.
Okay, well, that's sorted out, Kosho. We can ignore it now.
Yeah, but now Kosho has questioned his existence, right? By
See,
going,
enough rope.
yeah, see, Kosho was the one that did it, not me. Was
Enough rope, Kosho. Enough rope.
Yeah.
Yeah, well, it's too late now because I already.
Kosho already hung himself.
No, I have
By
the evidence.
going, you know what? There's no pictures of him, or paintings, charcoal sketches, anything.
I found them. Who's that?
I don't know. I've never actually seen a depicted picture of him. Anyway, I was just making a throwaway comment.
Well, there he is. Okay, and there's his fucking idea. Okay.
Yeah, well, when was this done, Kosho? How many years after he died?
The statue?
There we go. Yeah.
It was made while he was alive.
You said there was nothing done of him when he was alive, right? Everything was done of him after he was dead. And now all of a sudden, you bring up a statue and you go, you know what, now I think about it, this was done when he was alive. You've got to get your story straight.
This was also done while he was alive.
Really? Where does it say that?
Jesus Christ.
Kosho, come on. Your earth in a water bubble is way more convincing than that.
The point is, I measured the distance to the sun today, okay? I got it correct.
The point is that you have questioned Aristarchus' existence.
Oh my God.
Right?
Actually,
I don't think he did.
And now you're trying to backpedal from it.
I don't think Kosho did that, Bansaw. I think you put in a throwaway comment that got harped on for too long, and then I asked you a few choice questions, gave you enough rope, and you've hung yourself.
I haven't hung myself at all.
Yes, you have.
No.
Yes, you have.
Not
Yes,
at
you
all.
have. Yes, you have, because you threw that in there to pull away from the facts of what Kosho has done. That's what your throwaway comment was designed to do, and you were being sneaky. And I caught you out.
So
you hung yourself.
I'm never sneaky at all.
Yes, you are.
Right. I just purely refer to him being a used car salesman. Right. At first.
Here we go. Here you go doing it again.
What
Hey, Coach, remember the thing you did? How many people was involved in the project you put together? Was it 50 odd people?
23 people.
23. You had 23.
Yeah, well, and so did Slice Arcane, coincidentally.
I thought you had more. Okay.
No.
How many different countries were they in? And what was the split with northern and southern hemispheres? Do you remember?
I can look it up, but it's probably 10. It was probably like 8 in the south and 13, 15 in the north. And it was like 10 or 12 different countries. More than that, maybe.
Well, you had a bigger data sample than Sly did for the southern hemisphere. I think you only had 2 in the southern hemisphere.
Yeah.
That's good.
I got people on every continent.
Did you do it once?
Nice. No, I wasn't involved, unfortunately.
Chepa.
Oh, wait,
sorry, Kosho.
Chepa was our boy in the Outback.
WA.
Chepa.
That's right.
He's in northwestern WA, isn't he? Or midwest WA?
Yeah, Perth. Yeah.
Oh, he's in Perth. I thought he was a bit north and a bit west of
North
Perth.
of that.
East. I thought he was north and east of Perth.
No, we just call it Perth.
Why not?
Close enough.
But yeah, it was pretty good. I mean,
you had South Africa. You had South Africa, Sorry, you had Africa and South America covered as well, yeah?
South Africa, that's right, and 2 or 3 people, or yeah, 2 people in South America. Let me see.
Did you have any anti-globists involved?
Yeah. But I tried to
Nice.
get a bunch of them. Shepard was one of them. I think the person in South Africa was one of them. We had at least 8. We had a handful of flat earthers. The whole point at first was to try to get people on both sides so they could be unbiased.
What I liked about Sly's one, and I'm not taking away from yours, is that he took the measurements and then made calculations, and he put it in a graphic which really sort of, gelled it all together visually.
I didn't do that, okay?
No, of course you didn't.
I just said I'm not taking anything away from yours.
Yeah, he is. He is Kosho.
Except the fact that you didn't do it.
Yeah, that's right. I'm not taking anything away from it, but you didn't do this, Kosho.
Okay, well, what I did do is I made predictions before I made any measurements. The predictions were what set mine apart from his in Eratosthenes, because my predictions were based on a flat model and a spherical model.
Oh, that's good. Because
Yeah.
what he did is assumed no model.
I didn't assume,
and he let the measurements speak for themselves.
Then you think I see Kosho.
Mine was a test. His was a measurement to
No,
measure the radius.
Yours was good. Yours was good in other ways. I mean, you came with the same result.
No,
you just had slightly different ways of getting there.
No, the whole point of what he did was to measure the radius. I wasn't trying to measure the radius. I was using the fact that the Earth has the size radius that it has for the globe predictions, and I was using the fact that it's a flat plane and a close and local sun for the flat predictions. And all I was doing was going to see if the measurements matched either of the predictions.
Right. I got the impression that, excuse me, I got the impression that he wasn't so much measuring anything, but he was trying to determine if the surface of the Earth was flat or spherical, and if the sun was close and local or far away. Now he didn't say the distance to the sun, but he did say it had to be very far away.
Yeah, I didn't say the distance for mine either. I just said parallel light for mine.
Yeah,
mine was the spherical model, 3959 radius, and parallel sunlight, and the flat model was just flat and stationary, close and local sun.
So
and both your projects were done about 5 years apart from each other, give or take.
About 1 year.
He did his in 2017, I thought. Did you do yours in 18?
Yes.
Oh, I thought you did yours in 21 or something. Okay, my apologies.
I did it in September 2018.
Apparently, Was and Kosho, you two guys are sounding way too smug at the moment, right?
Who? Who's saying that?
Well, names will go unnamed. Nate Caloric.
All right.
You got, yeah.
Is this another attempt at a throwaway comment?
No. His words. His words was, you are sounding way too smug. Right? They're not my words, right? These are his words quoted, right, in context. And so what about the faint young sun paradox? All right. So I think he's trying to pull you guys into line.
Where are you reading this?
In text.
Which text? I'm not familiar with the texts in this server.
Livestream 1 is the main text. Oh.
Oh, right. Is that
Yeah,
caloric?
Yeah, caloric. Yeah. Over
Oh,
in the
yeah.
other.
Okay, I got it now.
Yeah.
Faint young
Oh, look
young
at him!
sun paradox.
Look at him! He deleted the smug comment. I can't believe he deleted it.
Well, you're a mod, mate. Go bring it back.
Actually, I don't know if you can.
I'm not sure, actually. I'm just
Yeah,
going to send you on a wild goose chase, but
Yeah,
I went and
no.
spilt the beans just now.
Yeah, no, I spilt the beans. You are definitely sounding smart. But about this faint young sun paradox, like, what do you think about that?
What is it exactly?
Wow. Would you like to know, Was? Because I know
I'm
nothing about
asking.
it. Okay, well, the faint young...
Can you summarize what this Wikipedia is all about?
Yes, the faint young sun paradox or faint young sun problem describes the apparent contradiction between observations of liquid water in the Earth's history and the astrophysical expectation that the sun's output would only be 70% as intense during that epoch as it is during the modern epoch. The paradox is this. With the young sun's output only 70% of its current output, early Earth would be expected to be completely frozen. But early Earth seems to have had liquid water and supported life. Apparently, that's the paradox.
Sorry, mate. There's someone talking over you, Bensel. I think it's
You're
Godric.
hot micing. Hold on, you're hot micing Godric. Hold on. Yeah, did you hear that, Was?
I missed that last couple of sentences, I think.
The paradox is this. With the young sun's output at only 70% of its current output, early Earth would be expected to be completely frozen. But early Earth seems to have had liquid water and supported life. So the paradox is that Earth was frozen, it seems. Godric. Where are you, Godric?
When they're referring to the young sun, how many years ago are they talking about? Like, are they going with the current estimated values that we have now? Was it a few billion years old? Yeah, 4.3 billion years old or something.
Look,
That's the Earth anyway. I think the sun's older.
You know, someone that is far more versed in this topic, who has brought this topic up to combat yours and Kosho's smugness, is not here to give his understanding of it.
Damn you, caloric.
Yes, first time I've ever heard of it myself, but he does come to the party with interesting information. The issue was raised by Carl Sagan. Isn't Carl fellas that he refers to all the time? Carl Sagan? Can't believe that you wouldn't trust me, Was. That's a bit harsh.
Didn't you see the lol? Didn't you see me type eek lol?
Yeah, I did.
This is why I don't trust you, because you only half said what I. You weren't reporting everything properly. You bloody cherry picker.
Cherry. Well, hey, look, come on. It's convenient. It's convenient to cherry pick. Come on, Was.
Of course. Of course.
Don't judge me.
Don't judge you. You put it out there.
So how's it been going over in the other world that you live in? over there in the other channels?
It's been a bit. Oh, on the other channel. I thought you were talking about Melbourne.
Yeah.
Oh yeah, it's gets a bit crazy at times, but you know,
a few
it's
few
an open
meltdowns.
platform.
A few meltdowns.
Um,
Have you managed to get Merle out and about yet?
not yet. I caught up with Rich last Monday. Or the Monday just gone.
Yeah.
It was really short notice, about 24 hours. He said, "Oh, I got the day off."
Yeah.
You're coming down soon, aren't you? Is that still on?
Oh, it looks that way. Yes. Yeah. At the end of August, it
Well,
looks
you
that
got
way. Yeah.
well, you got my phone number. Send me a text message when you're close, and we'll work something out.
For sure, 100%. Yeah.
No, Merle's wasn't able to make. I think he was working that day, and the other time we invited him out, he couldn't make it that day either.
Oh, okay. Shame. I think he needs to get out and about.
Oh, he's out and about now. He's been working a few days a week for the last few weeks. Maybe
What's he doing now?
Maybe a couple of months now. He's working for a I think they hire out cars and detail cars.
Oh, okay. Yeah.
Yeah, so he's helping with the detailing and moving cars around. Gets in with the panel beaters occasionally, those sorts of things. Bit of a
good. Yep. Yeah.
He's a bit of a everywhere guy, you know, a dog's body as you call him.
Jack of all trades, fills in here. Good on him.
And skilled at none. Yeah.
Yeah. Oh well, at least he's out doing something at the end of the day. You know, gets him away from the mic.
No, but he's come to the absolute conclusion, and he won't be shaken. He's working on some drone footage where he's flown. His friend in New Zealand has lifted the drone up, taken off, and he's raised a certain amount of meters up in the air above the guy controlling the drone, and then brought the camera down and shown that the Earth doesn't move underneath. So that's his latest definite proof that the Earth is not moving.
Okay, so then with the explanation of the globe Earth model,
there's no explanation in his mind. That's all been shut down. That's all been shut down by the observation. There's no explanation for it, as far as he's concerned.
Yeah, but if you're comparing model to model type of thing,
that's right.
The globe Earth model accounts for all that.
That's right, but yeah, well, most people would realise this, but that doesn't make sense for him, because you know, if the drone's no longer attached to the Earth, you should see the Earth moving. I guess is the conclusion that he's come to with his 100% definite proof that the Earth doesn't move.
Look, even though I may disagree with it, but you know, you can't. You know, the model accounts for it at the end of the day. You know, it's like when the other day we were talking about planes.
Maybe you need to let him know that, because everyone that's not a globe denier that has told him that, he's just shut down to that explanation.
No, well, look, it doesn't matter really at the end of the day.
Look, that's the thing. In the end, it doesn't matter what you say.
Well, we were talking about planes the other day, and the notion that a plane has to dip its nose down, and the pilot has to account for every 8 inches per mile square, they have to constantly dip their nose down, which, you know, how planes fly and maintain their altitude, the globe model accounts for it, right? Because, you know, a plane is working on thrust and you know, its angle and all that sort of stuff, and it flies in a density gradient, and as long as that speed and those angles are consistent, the plane will maintain that altitude. right? Now
So
the globe. Go on.
I was just going to say, with a lot of things considered, would you say then that evidence for the Earth not being a globe would have to be something that would never work on a globe?
Well, basically, yeah, you can't have if the model says that the density gradient around the Earth is going to be the same on a plane of Earth because of gravity, okay, and that's how it works. That's the explanation, whether or not we agree or disagree, but that's the explanation for it. So then to then say that a pilot, right, would have to manually dip the nose down around the horizon, I don't agree with at all. Because the model dictates that the plane is going to stay in that density gradient as long as the pitch and the speed of the plane is consistent. It's going to stay exactly in that density gradient. So the explanation is there already.
Correct. So what do you disagree with about the globe to make you think it's not a globe? Because you don't think it's a globe, right?
No,
Is
I
it just water for you?
It's for me, mate. Yeah, that's
Because
me.
water is explained. Water is explained on the globe, just like the aeroplane is, and just like the drone is.
Yeah. Okay. Cool. Cool like water. Yeah, it's explained, but the experience. I'm just going from my personal experience and what
Well,
I've
so
done.
is
And
Merle.
yes,
To
I
be
know.
fair, so is Merle with the drone.
Well,
I don't know if you were talking, but you stopped. I can't hear you.
yeah, no, sorry. I just had to. I got a random spam phone call from Australia.
Yeah, I got. They must have your number straight after mine, mate, because I got one of those not more than a couple of minutes ago.
Like any time that on my mobile phone, when the number rings and it says Australia, you know it's a scammer. Sorry, what I missed that last bit that you said about.
I'm just saying, to be fair, Merle's come to his own conclusion with his own experience with the drone, as you have with your experience with water.
Yeah. Look. He can have his independent thoughts from me. I've got no problem with that whatsoever.
But I'm just drawing a comparison of the logic you are using for water when you reject Merle's, because your reason for using water as evidence is your experience with it, and I'm just using that experience with thing you said and apply that to what Merle's saying with the drone.
Yep.
I'm just trying to point out the inconsistency with your logic.
Okay, and tools that I have used as well. So it's not just water; it's also tools that I've used as well. To me, it doesn't quite marry up, right?
Yeah, I don't know, man. You don't. It doesn't sound right to me.
What doesn't sound right?
Well, that you would use that as a reason to believe it's not spherical.
Well, I would use it because because I've used them, and I think I understand how they work, and when
as Merle has with the drone,
and when lines have been established, and target points have been established from a particular line, or from a particular datum point, and a horizontal line has been set from a particular datum point A, okay, and then I have then used an independent tool, right, that establishes a different plumb all the way along that line, and they marry up and I hit my target, that plumb isn't moving. It is consistent with the very first plumb.
and you're saying that can't be explained on a sphere.
Well, No, not if those plums are diverging. No.
All right.
Because on your sphere, your plums diverge. Yes.
They would, given enough length, I guess, to make a fair measurement.
No, not enough length. They diverge 1 millimeter apart.
At what distance?
At 1 millimeter apart, they diverge.
Right. How much diversion?
Well, not very much at all. Obviously, they
Is
don't.
There a working tool to measure that though?
Not 1 millimeter apart. No, not at
Right.
all. But then, right, when you are establishing a different plum along a long length.
I meant
a long run.
When I said length, I meant the length of the plum. Yeah, how far it drops. So if they were 1 millimeter, 1 millimeter apart, and those lines were 700 kilometers high, you might find something measurable, maybe 1,000 kilometers high.
Yeah, exactly right. Okay, but if you are establishing a new plum, okay, so you are laying pipes, right?
Hey, Bansor, sorry to cut you off. I'm going to go have to prepare dinner for the kids very soon.
We'll talk soon, man. We'll talk soon. We'll continue this later.
If you want to finish that last point, I'll take it on board before I go.
No, I was just going to say that if you are establishing a horizontal, right, from your initial datum point, so it's a straight line going out into space, right, and from that line you are taking all your measurements from, okay, and you are laying pipes. Now, there's a particular tool that you use called a laser pipe layer, right, and every time you move it along the pipeline, it establishes a different plumb, right? So you can continue a perfectly straight line. So you get your grade of your pipes, because you want your pipes set at whatever. So you set your grade of pipes to say 4%, right?
Sorry to cut you off again. Is that different to a dumpy with the staff?
Yes.
Okay.
Yeah. It's a little tool that's like a little round cylinder that actually sits on the pipe itself, and it projects a laser beam out in front of it. Okay, and it sets plums. So every time, all you have to do is set the grade of it, and once you've set the grade of it, you put it on your first pipe. You get that first pipe like spot on, right? And
What's it
then from
called?
that, it's called a laser pipe layer or a laser pipe measurer. There's many different names for them. They're basically like a little cylinder. They have 4 little feet on them that straddle the pipe, and you sit it on the pipe, and it shoots a laser out in front of it, and you use that laser, okay, to establish the line of your pipe, which is a perfectly straight line. So every time you move it, okay, so from pipe 1, and then you lay six pipes,
Gotcha.
right?
Is that it? What I posted is?
Yeah. So that's a version of it. That is a version.
Right, yeah. Gotcha.
But you don't have to recalibrate it. Once you've set in your grade and all that sort of stuff, the beauty thing about it is you can pick it up from that pipe and you can move it to another pipe, and then it re-establishes its plumb and then continues that straight line, because you want those pipes to be in a perfectly straight line. Okay, and this is how they work. So you use those initially.
Okay. I do have to go. That sounds like I've got to look into it a bit more, because something sounds a bit off there.
Okay, you can
that method, but yeah, I've got to look into it.
Yep. Happy days. All right, boss.
Thanks for the
later,
chat.
buddy.
See you later.
All right, mate. Catch you later.
I don't think you convinced him, Manny.
Oh, okay. Was, are you in here?
I left.
Someone told me was over here.
Yeah, he went to cook dinner, Mel.
Oh, okay.
Can't talk right now, mate. Just got to do
No
dead
worries.
duties.
Yeah.
Back a bit later.
You're right. Yeah, the drone thing's got their attention.
You had some revelation, Mel. What's happened, mate?
Oh, I've proved the Earth stationary.
Have you?
Yeah.
Mate, that's something.
It is, isn't it?
Is anybody listening to you?
Definitely.
Where did you do this?
We've done it. I didn't do it on my own either, so we've done it with a drone.
Yeah.
It's stationary drone flyer looking down in a fixed position, drone in manual hover mode, not GPS, filming the controller. The drone doesn't deviate 1 second left to right, uninterrupted for 10 minutes, fixed. Earth's not moving, drone flyer's not moving. drone itself isn't moving. There's a 3-body problem solved too. We knew what they were going to say, what they're going to come at it with, which is conservation of momentum, Coriolis effect.
The lockstep atmosphere nonsense.
Yep. And then so the challenge to them is to do the same experiment and prove it is moving.
Yeah.
Which they can't do.
Of course.
So they're fucked. So it's exciting. You know, a domino's definitely fallen. And yeah.
How would you go, Merle, about performing the same experiment to show that it is moving? What would be the method in doing that?
That's up to them.
Well, okay then. If you're doing an experiment, right? Isn't it the whole idea of doing an experiment to see if you can falsify your own experiment?
No, that's more mumbo jumbo from them.
Well, that's basic science, isn't it?
No, because it's a practical demonstration.
See, I've had this same problem, Bandy. I got into beef with what's that? Earth is Life, whatever his name, B-Ball, whatever his name is, or Earth is Life.
Oh yeah, B-Ball, yep.
I think it was him. It was back in Brandon's server about the lockstep atmosphere. I said it's impossible. I work with rotating fluids all the time. Can't happen. Blah 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 blah.
Yep.
Oh yeah, but it can if you've got a frictionless container. Because they're saying, it doesn't work. It doesn't work here on Earth because the walls of the container prevent the liquid from ever getting up to the speed of the propeller. And I said, well, where are you going to get a frictionless container from?
Exactly.
And then I get called. I get called intellectually dishonest. Like, are you for real? You can't show me a frictionless, but out of space apparently is a frictionless container, or gravity is a frictionless container. Like the nonsense. It's the same thing Mel's going to come up against. Like they can't demonstrate anything in the real world to counter what we can show in the real world. But evidently we're the ones with the problem.
Yeah, no, this is what you come up with all the time, and I just had the conversation. With Jesse before, and a little bit with Woz, we were talking about, because we had a discussion a couple of days ago, Fe, in regards to planes flying, okay, and a plane or a pilot having to dip that nose down 8 inches per mile squared, right? Which to me, to quite frank, is a poor argument, right? Because
I agree.
because in their model with the density gradients and all, it accounts for it, right? Because that's how planes work. So I personally think the whole plane flying thing is a poor argument. So, but
Can you see the sunset at the moment, Bandy? Can you see the sunset?
No, it's kind of, yes. Why?
I can look directly at the sunlight. It's obviously being hazed by something, and it's just this magnificent big yellow ball on the horizon. It's beautiful. But anyway, sorry to interrupt, mate.
Yeah. So to me, that one is a poor. Okay, hold on. Good, Rick. I'll unmute you, buddy. But like how do you go about falsifying anything?
Thank you guys. Sorry about that.
Yeah, you're right, Godric. You're right, buddy. But this is where to me practical kind of things come into account, and how do you go about, I suppose, falsifying them. What you want to go about, and I think personally direct measurements are the best. myself, you know.
Yeah.
But I've been told FE every time I direct measurement, I haven't created any straight lines in my, not one horizontal straight line. It's just like, well, go figure, right?
But I was just going to say, like, maybe there's a point where you got to stop listening to them and just call out their bullshit and that they're clutching at straws. And they have been for nearly 8 years now. And just sort of call it that there's zero possibility that the Earth's a globe. And I've been putting it on them real hard lately. Like, I'll be like, I know you know Jem, you know, I know you know Queen, I know you know M. Scott Veach.
Yeah.
You wouldn't have been out. Kosho knows. They all know. No one I know that's looked into heliocentrism as an adult has ended up on a ball. Not one person I know, and I know a wide range of people all around the world. So it's hotting up, guys. Like, it's fucked. Truly, well and truly fucked. All they have now is rhetoric and excuses. They're a shambles.
They just hand
Absolute
wave away anything that you and Merle and me and whoever can physically demonstrate to our next door neighbour or Donald Trump. You know, we can show stuff in our backyard with simple equipment, but they are totally convinced by rhetoric that is unfalsifiable, unprovable, undemonstrable. That is what cements their worldview. It makes no rational sense whatsoever.
It's quite funny, FE. Like, any time I speak to quote unquote normal people in the world, and the best way I do it is, you know, with a glass of beer or a bottle of water or whatever, and at first you ask a couple of, sometimes maybe a couple of qualifying questions, I suppose, like, what do you think about JFK or the moon landing? You just try and feel them out a little bit that way. And generally, if they, something a bit sus there, or 9/11, all these sorts of things. Now, a lot of people, it's surprising, like how many people out there in regards to just say the moon landing aren't quite convinced about it. Like, there's quite a lot out there that have asked questions about it. So as soon as you can see if someone's going to be open to someone by kind of feeling them out a little bit, that's when I'll raise my beer and tilt the glass to one side or another, or, bottle of water, and you'll tilt it to one side or another. And, what about the level of this?
Imagine if you went up to the bar and you just, someone's standing there at the bar and they go, "G'day, mate," or, how's it going? "Oh, not too bad. How's your day going?" "All right." "What are you up to?" "Oh, this and that." "Oh, heard anything new lately?" It's like, well, as a matter of fact, I have. "Oh, what's that?" "The Earth's not a globe, mate."
Yeah.
That's going to stop the record, isn't it?
Yeah, we went out a couple of weekends ago, and there was a group of people behind us, and wife and I went out to a nice little Thai restaurant, and anyway, they were all on their bloody mobile phones and none talking to one another and whatnot. Anyway, we were talking amongst ourselves, and my wife got up and she went to the toilet, and I'm just sitting there and I'm just looking at these people, just thinking, gee, what a sad life you've got, actually. And anyway, I sort of caught one of their eyes, and they looked at me, and I said, "Do you think we went to the moon?" And he goes, "Oh, no, I actually looked into that. I'm not too sure." Right. Anyway, I was drinking water that night because I was driving. I had my glass of water, and I just turned around and I said, "What do you notice about this?" Right. I tilted it at one side and tilted it to another side, and he's kind of looking at it. Right. Okay, just look at the surface of the water. He goes, "Oh, like it seems fairly level." And I go, exactly right." And then my wife walked back, and I said, "Think about that, the surface of water level, right? And think about where you are, right? Dams, lakes, fish tanks, everything. The surface of all that is all nice and level. And but yet, on the other hand, now you have to come to terms with it wrapping around a ball. How do you do that?" And I just smiled, turned around. My wife just turned to me, going, "You didn't, did you?" I go, "Yeah, babe, I didn't." She goes, "You are incorrigible. We can't go anywhere." I go, "Babe, it's what you got to do, sweetheart. You got to do. You got to wake them up."
Yeah.
I should have recorded it, but I do it all the time. Actually, I
Well,
find it enjoyable. Just placing
yeah. I mean,
seeds.
it's a service, though. I mean, it's going to take people a bit. Like, of course, there'll be an initial shock, but I mean, even Lemonbird says it. He'll go straight out too. Like, it's just cope now.
Yeah.
Like, that's how
Yeah,
he
yeah,
puts it. Like, it's
yeah.
just an unwillingness to deal with it, and
Yeah.
that's why I've got respect for the true ones that, like yourself, you know, FE here. Like, we've just been out here years. Just like, you just got honest about it. You faced up to it. Takes some balls to do that. It
Yeah.
really does. It's not easy to take.
The
Like, there's different levels of lies, right? Like, the moon landing or Santa's one thing.
Yeah. But then so often, Merle, the argument goes over into the stars, right? That's
Yeah.
where they like to take it so often, like over your head, and parallax of this and blue and red shift of that, and retrograde of something else and whatnot, and that's just to muddy the waters. Get back down here on Earth, fellas.
Exactly.
Get down here
Exactly.
on Earth. Like there was a fellow in earlier, and he was talking about an experiment that he did, right, with two flashlights, and they were both 1.5 mile apart, so 3 mile in distance, and he was looking over a lake through a telescope, right?
Mhm.
And said, "Why didn't those lights line up?" And I go, "Well, why wouldn't they?" I go, "Well, why would they line up?" "Well, we're on a flat plane. Why wouldn't they light up?" And I go, "Well, why would you do, I said, why would you do any observation or any measurement over water?" And he goes, "Well, that's what all you guys say all the time." I go, "No, that's what the professionals say, mate." I said, "You won't get a surveyor to survey anything over water over 3 miles." I go, "That's absolutely ludicrous." I said, "If you want a surveyor to do anything with any accuracy, they're shooting over very short distances. They're not shooting over any length whatsoever if they want to be accurate." And I said, "It's just silly to do that and imply anything." "Well, we see the light in a straight line." I go, "What light that's in a straight line?" "Well, the light that if I hold up my staff, right, the light is bouncing off that staff into the theodolite auto level in a straight line." I go, "Is it?" I said, "Can you demonstrate that the light is bouncing off that staff a kilometre or a mile away and travelling in a straight line?" Is my number 1 point, right? My number 2 point is that you actually think that in reality that light bounces off something, right, travels through the atmosphere in little packets of information into my eyeball. That's actually how you think that we see. I said, "That's absolutely ridiculous to even think that." "Well, you don't think that?" I go, "No, I don't think that." He goes, "Well, how do we see then?" I see, "We see the object where it is. That information isn't traveling through the atmosphere like a hologram, getting warped and tortured and constricted all the way through the atmosphere before it gets to us. That's not how we see it all." I said, "I don't agree with that." "Well, you need to look into it a little bit more," was kind of bird. And I go, "Well, maybe you do." "Well, all the professionals will say, all the experts will say that that's how we see the light traveling through the air." I go, "They can say what they want and they can think what they want, but I'm entitled to think how I want too."
Yeah, I mean, Dawn Treader said this to me quite a few times. What has he said? He goes, you're like an atheist who's found out that the religion or the ideas about that aren't real, and you're annoyed about that, but you go and hassle Christians for what they believe in, comparing it to flat earther, hassling the baller for believing in what they believe.
Really?
So that's what I'm starting to realize, that a lot of the ballers, they have this belief, which is heliocentrism, and then when you sort of push it a little bit, and then they sort of start to realize that they've never actually seen a planet like the Earth with their own eyes, like not one of them have. And the only place they've seen it is on a desk or on a TV or a computer screen, which it's a multimedia image.
Yeah.
And when it starts to sink in, they're faced with that moment. It's like, well, I'm either going to keep on with this belief that I have, that I think I have evidence for, which is my way of verifying it, and then it sort of makes it true. I've gone through it with many of them, and I used to be one of those people, and I had to address that in myself. Like, I had that cognitive dissonance as well, like at first, and it was such a shock. But there's a point where you just realize. So I feel with some of them, like once you realize that they hold this belief, that doesn't make it true. And if you sort of want to keep going with it, there's a point where you have to be honest with yourself.
Mm-hmm.
And that's what I'm starting to realize. Like, I think honesty, you don't have to go to the shops. You don't have to go under the water into outer space to get it. You've already got it. You just need to employ it, empower yourself. And when you're honest, it's like a warm knife going through butter. And if butter's the lies, the hot knife just goes straight through. There's no resistance. There's nothing the butter can do against the hot knife. It's powerless. And that's where people need to get to. Because honesty wins. It will always be more powerful.
Mm-hmm.
And once people, because if everybody was honest and realized this, which I've heard different people say, if it went mainstream and but it's still kind of underground. Like, I think it's exciting because we actually know this huge secret.
Yeah, well, I'm kind of at the stage now when it comes to the actual debate itself. I'm actually, I'm a little bit bored of it, if I must say.
Yeah, that's understandable.
But I like it, because here, especially too, when you hear all the different ideas. We had a fellow over here about a week ago, and talking about the sun and the moon, being reflections and whatnot. And it was good to hear about it, and listening to. Obviously, I had some questions and some logical questions that I put to him that I didn't agree with his hypothesis of these things being a reflection, because I could see flaws in what he was saying. But it's still cool to think about these things, and go, okay, then how can explain to me exactly what you're seeing, what you're envisaging, and let's try and set it out practically. And he kind of did that, and heard him out, and we discussed it for about an hour or whatnot. It was actually really, really cool. And he could see, I think where the idea had some holes in it. He was still running with it, but it was still, it was still cool just to nut it out, not like hand wave dismiss it, but like, okay, then cool. I personally think the idea is crazy, right?
Yeah.
But hey,
Yeah.
let's have a conversation about it, right? You know what
Yeah.
I mean? Like
Yeah, I know what you're saying.
instead of talking about, instead of chasing your tail around in circles all the time,
Yeah.
like talking about the different things, the wacky things, sometimes just to see, because out of that wacky idea, you may get one little Easter egg that you can apply to something else. You know what I mean?
Yeah.
And
Yeah, I know what you're saying.
slowly just build up that basket, because I don't, you don't, individually have the ability to do anything on a large scale. Show us your map, show us this, show us your model type of thing. Well, we're only very limited in what we can do at the end of the day, and you really can only think about things. But if you're satisfied where you are, right, let everyone let everyone else get into the heated debate. So I'm not really too interested in that anymore. Occasionally I
Yeah.
get involved with it, but that's why I'm here and not in other places, because I just don't find it enjoyable really anymore. Just doing a puffer valve all the time. But occasionally I do go other places and do a puffer valve.
Yeah.
just to have a
Yeah.
bit of a release, so to speak. But yeah, having places where you could just talk about these things, and having people not poo-pooing over the ideas, it's good.
Yeah, I mean, it's funny because Lewis Hackett, he never
Oh yeah,
gets,
Louis. Yeah, Louis.
well, he never gets in my DMs, right? But this morning he had 2 videos for me, like in my DMs,
Okay, yeah.
and I sent him one too that I made especially for him and Dawn back in the day, but I watched it at anyway, I watched it, and just at the end there was something there with that guy Flatty Flatface. I don't know if you know who that is.
I know the name. I know the name.
Yeah. And he was on Dell's, and he just says, "Oh, you got to have some decorum," kind of like you were saying, like, because otherwise we're just as bad as them. That's what Flatty McFuckface said.
Yeah.
And Dell just said, I don't know why I always bang on about this bloke, but sometimes he just has that uncanny ability just to encapsulate something. Anyway, he goes, "Nah, you don't have to rip the pish out of the person, but you can rip the pish out the claim."
Oh yeah, definitely. He's calmed down a little bit. I've tuned in with a couple of his last streams. He seemed to have calmed down a little bit, Mel.
Yeah, I mean, I think some. I mean, I've had chats with him about this, but it's like, I think sometimes when he sparks up a stream, he's got things on his mind anyway. But as you know, so like, say he'll start it, and then you'll see the chat start up, and then people start rolling in, and then the next thing, there's 300 people there. Unless they're I don't know if they do something to the numbers, but they might. But anyway, there's people there, and all of a sudden he's got like this gathering and this audience, and And I think, like, because I've said it to him a couple of times, I go, can you feel it when everyone's sort of like waiting for you to sort of say something? Like, they kind of, it's almost like some people need to hear it.
You know,
You know?
you notice how the Globers are jumping in because you're not bashing the globe enough. If you start debunking the globe, if you debunk the globe and state their demented claims, maybe they're all quiet. But.
Well,
So
I just all I was trying to get through there, just because I was, just because there's a point there, like it's almost like because Bandy will call it like blowing a puffer valve, like there's kind of like this build up sometimes, knowing this,
yeah,
like when you know it and it clicks, there's no turning back. So it's like the penny drops, but so it's like there's a responsibility that goes with that. And I know that he said to me a couple of times, he used to sort of check showing anger or showing that grit, if you will, that determination to really dig in and take it on and sort of show no fear in the face of this intimidating heliocentric model, right?
Yeah.
But I think that's what as we get older and mature and it kind of evens out and it's sort of settled in, you can be easy about it sometimes. I think initially he had a lot of residual, like a lot of us did. It was like venom and disgust and everything that goes with it, like just this like.
Well,
fuck.
yeah, because Kosho admitted a couple days ago that he wanted to kill 3 billion people because they're useless. So, like, they are our enemies. These people are our enemies.
I don't think I've ever said that in my life.
Oh, you said that. That's
Nice
why.
try.
That's why.
I think what you heard me say was 3 billion people were useless. Is what I said.
Earth Awakenings 458 was deleted because that's the stream you said it on.
Yeah, I didn't say that. I actually corrected the dumb people who misheard, because I specifically did not say somebody asked how would you deal with the 300 billion people who are useless, and I said I don't have a solution. There's no solution for that.
You said
I would not
you would get rid of 3 billion useless people, useless eaters, and Godric was saying, "What makes you not useless?"
Yes,
and you
Godric
said,
was
"I'm
the
very
person.
useless."
Yeah. He was the one who was continually asking me, even after I said, I'm not going to kill 3 billion. I would not kill 3 billion people. I'm not saying that they need to go. I'm saying that they're useless. And I was talking about in the eyes of the elite.
You did. No. You said there's 3 billion useless people who are anti-vax, anti your agenda, and you would get rid of them.
Jesus Christ. That doesn't even make sense.
And that is the atheist Marxist agenda that we fight against. So when you say, be nice to these guys, yeah, you can be nice sometimes, but in reality, you guys are the enemies. You want us dead.
Yeah.
So Merle, with your little experiment that you've done, have you done it, Merle? Your little drone experiment?
It's not a little drone experiment, but
You didn't mean that to be
yeah, no, but they're just doing that too. Like some of them will go, they'll be like, "What? You used a drone?" And then they all laugh and do that kind of shit.
So
yeah,
with the experiment that you've done, and you've done it for 10 minutes, and you've filmed multiple different angles and all that sort of stuff, and shown what you've shown, and you go bang, here it is. So now it's your attitude now, which I've got no problems with that, with this being your attitude, is like, okay, then now you guys do it, and now you show me that it is spinning underneath the drone. Like, it's not up to me to it's not up to me to falsify it. Like, I've done this, right?
Yeah.
So and I'm happy with this. I don't really care what your globe model says about what it should or should not do. I've done this, and you tell me that our model says this. Well, now I've done this. I don't care what your model says. If your model says this, you go out and do it yourself, and you show me.
Yeah, that's the stand.
And look, you know what, Mel? I've got no problems with that whatsoever. Right?
Good
Like
on
I
you,
said,
mate.
like what I said before. Like how would you go about to it, sort of thing,
Yeah.
and you kind of go, well, you know, I don't really kind of care about it, and I've got no problems with that stance whatsoever.
Yeah, because I had Slacker,
Yeah.
NASA Shield. I had them all. Rocket Science. You know, I had them all going,
Yeah,
having a go.
no, exactly, and it's like, well, okay, then you guys go out and create a horror next to a body of water and show that it drops 8 inches per mile squared. Go and do it.
Yeah.
You say it does.
Well,
go and do it, right?
well,
And then,
yeah,
and,
because
and then I was
Oh,
just going
sorry.
to say, because
Yeah.
their attitude with me is, well, basically, you were just a small, stupid time plumber that did everything over a small
Yeah,
scale,
fuck
so you don't
that.
know what you talk. Like you
It's
say, you don't
such
really
an
know what you're
insult,
talking
mate.
about. Like,
Yeah.
well, look, it is what it is, right? And you know
Yeah.
what? You know what,
Rude,
Mel?
though.
Their model dictates, right, that the deviations are so minute that I can't measure it over a short distance. Okay, then, fine. That's what your model says on paper.
Yep.
Go show it in reality. Go
Yep.
show it in reality. All
Yeah.
right.
I
That's
mean,
what I say.
well, what the message to is going to be is to people like, say, Dawn, Brian Mabbott, Mark Taylor. There's a lot of people who have drones.
Yeah.
This is what's exciting about it.
Yeah.
So anyone on Earth with a drone can verify this if they give a shit to.
Yep. Yeah.
You know?
Yeah. Dawn
And
should
if
be all over
everybody,
it.
say if
Dawn.
like 100
Yeah.
people did it and we all got the same result,
Mm-hmm.
I mean, it's going to be embarrassing really quickly.
So, and like, I don't know if you were here before, Merle, but you know, the conversation came up about planes flying, right?
Right.
And you know, there's been a common theme in the flat Earth debate that, you know, a pilot physically has to drop its nose 8 inches per mile, you know, squared type of thing to fly around the globe. But you know, the globe model also dictates that the density gradient is going to be exactly the same, whether it's spherical or globular or planar, right? And the planes fly the way the planes fly. They fly in a density gradient itself due to thrust and pitch of the plane. To go and falsify that, like, I don't know how you do it. And, you know, some say like you just use a gyroscope. Well, then it comes back that the gyroscope, you know, works because of gravity and all these type of bits and pieces too. Well, okay, then set up something that, you know, shows that it is doing this. Like, you tell us these things mathematically on paper. It says this. I'm not going to disagree with what the model says, Merle. Well, that's what the model says, right? I'm not going to disagree with it. Now take it into reality. Prove it. Prove what your words say on paper and your numbers say on paper. Go and prove it. Right?
Yeah.
Yeah,
Don't
Ben
just say it.
the argument says that the planes have to continually reorientate itself to stay with the sphere. On a flat, they don't have to orientate at all. They just fly flat.
No.
But if it's sphere, they have to reorientate to stay with that elevation.
Yeah, well, I personally disagree with the argument, Godric, because if the plane maintains its altitude due to thrust and pitch, and it does it in a density layer, right, and as long as that density layer is consistent, okay, the globe model says that it will be consistent around the globe, right? So as long as the pitch and the thrust is the same, the speed is the same, it is going to stay in that density gradient. You can't argue with that. You can't argue with that.
Don't you see that's not a correct argument? Because to do that, to keep altitude, if a sphere flying around a sphere, you would have to continually orientate your plane. We don't see that. We don't see any reorientation. We don't see any dipping. We don't see any tail going up. We don't see any anything that indicates that you're changing your orientation.
No,
What
the
I mean by
plane would
that
it would automatically do it itself.
okay, show us that it's doing it then.
Well, you can demonstrate how a plane flies. I'm sure you're flown, Godric, and when you're flying along, all of a sudden you'll hit a different density gradient, and all of a sudden the plane will dramatically drop or it will dramatically rise. Turbulence is what they call it. And you hit turbulence when that density gradient changes. So that can be demonstrated practically that the plane, if it is maintaining a constant pitch and a constant thrust, when that density gradient changes, also too, the altitude of the plane changes.
Yeah, Ben. So, but that happens in a flat plane. What you want to do, the Globers want to do is show that it's reorientating downward. I'll give you two examples. Take a ruler and just slide it over a spinning globe model.
Yeah.
Okay? If you don't reorientate that ruler downwards, continually just keep to a sphere shape, you're gonna fly right off into space. Correct?
If you were flying in a straight line. I would agree. I would agree, Godric. If you were flying in a straight line, and if the atmosphere or the density gradient was consistent, right? There was no difference in it, right? I would agree 100% that plane would fly off into outer space. But because the density gradient isn't consistent, it is layered. Like that's why clouds settle where they do, right? At a certain altitude, they settle where that density gradient.
Explain why you have to insert density gradient. How does that help? How does that help the argument at all? What's your point in inserting the density gradient?
That's how planes fly and maintain altitude, because when they're in a certain pressure zone, a certain density, that's how a plane maintains its altitude.
But that's not the argument, because that would happen on the flat plane, would it not?
Yeah, 100% it would. Yes.
Okay, so you want to see the difference. You want to show that there's difference between flat and round.
That's
flat and
point,
that we're trying to do.
It's the same. It's the same. It's the same. Model says that the density gradient is going to be consistent around a sphere. So the density gradient is also going to be consistent. So the way aerodynamics work, Godric, is through the pitch of the plane and through thrust. Right?
Wonderful. You want to show there's a difference between flat and round. You're not showing that.
What do you mean?
I think what you're saying is you can't tell. Is that what you're saying? You can't tell?
You wouldn't be able to tell. No, you wouldn't be able to tell.
So it goes back to it's curving, but you can't tell. It's spinning, but you can't feel
He's
it.
saying that it's a bad argument
but you
because
can't
it's
measure
insane,
it. This is the problem, right?
Dude, he's already saying that. That's what Bandsaw is saying. That's why he doesn't like that argument. It's because
you're saying you can't tell. Well,
it worked from both.
I did some. I don't know if you heard me, but I did some math on this, real basic stuff.
Yeah.
And I think you would be able to tell. Did you hear my numbers when I worked the numbers?
Oh, look, I think I've heard the numbers. Maybe not, but I've heard other numbers when planes fly.
Let me just do it for the room, okay? Let me do it. Just give me a minute, okay?
Yep.
Something like this. Go something like this, okay? 550 miles an hour. Divide that by 60 for the minute, right? You get out. The plane. The commercial plane's going to cover 10.1 miles. Say 10 miles every minute. Okay, at 550 miles an hour. Now, here's the thing: at 10 miles, guess what? There should be curvature. Okay, and if your plane is going to reorientate, let's say every minute. I'm not saying it has to do that, but if your plane reorientates every minute, then you have to account for a 10 miles dip according to the globe Earth calculator, to the dip calculator. And that amount, if you put, now there's no zero height, it's just physical curve at this point. If you put 10 miles over the global calculator, you're going to get something like 45 feet of dip, okay?
Yeah.
Now, 45 feet. So here's the thing. What you're saying is correct. There's the plane's going up, down, left, and right, but has to go down, more down 45 feet every minute on the minute. And if it didn't do that, it would go higher in altitude and fly towards off into space. But we don't see it. We don't see it dipping down. We can't. I agree. We can't tell, but we should be able to tell if it was dipping down 45 feet every minute on the minute. We should be able to notice that change, but we don't.
But if the plane flies in that density gradient due to the speed and the pitch of the plane, and it will maintain that altitude due to those things, right? Why would it have to? It just flies in that density gradient. That's what it does. That's what a
Well, let me
plane
ask you.
does.
There's two ideas. Either the plane flies by itself with a density gradient, or the pilot has to push the throttle forward and pull it back to go up and down. So which is it?
Well, the pilot pulls his little joystick up and down when he's going up and down, right? But then once he maintains an altitude that he wants to stay in, he can set the autopilot at a particular pitch and a particular speed, and it will maintain that altitude, right?
It's a similar thing to you put your car in cruise control. Put your car at 50 miles an hour.
Yeah,
cruise
exactly.
Control. Okay. However, we're talking about height now because physically you have to bend around the curve. The plane has to do that physically.
Okay.
If it doesn't do that, it's going to lose altitude, go up higher. Correct? Just like your ruler, you have to reorientate down around the globe. Let's say you go from North Pole to South Pole.
Okay.
If you didn't reorientate your tail up and your nose down, just follow that logical conclusion. You'd be upside down and flying backwards by the time you got to the South Pole, correct?
Do you think planes, when they get up to a certain altitude, fly perfectly horizontal?
Yes, because it's flat.
No, they don't. No,
I
plane itself isn't orientated horizontal. They are pitched slightly up. That's what they do.
The nose is like 3 degrees up, correct?
Yeah, exactly right. Right, because if it was horizontal, right, it would fall out of the sky. Okay.
The nose is pitched 3% up, but that doesn't account for being flat around.
No, what it accounts for, it is flying in that density gradient, right, with that pitch, the way it is pitched, with its speed and acceleration all married up, so it stays in that density gradient.
Yeah, you're talking about aerodynamics, right?
Do you understand what I'm saying, Mel?
Yeah, that's why I'm asking you. Talking about aerodynamics.
Aerodynamics, yeah.
Well, I think you can tell. You don't think you can tell? I mean, we're gonna have to disagree on that.
Yeah, no. Yeah, look, I'm happy to disagree. I just don't think a pilot has to physically, according to the globe model, I don't think a pilot has to physically steer the plane around a globe. According to
if the pilot doesn't do it, then the autopilot's doing it.
No, well, the plane does it itself because of aerodynamics. That's the way aerodynamics works.
Well, we're gonna have to disagree on that. I don't think a plane could do anything by itself. I think it has to be programmed to do certain things. And
well, yeah, you program it. Yeah,
it lifts up when the density gradient becomes more dense. Is that what you're saying? It lifts up, and then when the density gradient is lighter, it tucks down. Is that what you're saying? I don't think that happens automatically. Is there like a computer that does that senses pressure and goes up and down because of the pressure? Is that what you're saying?
No, I'm not saying that at all. I'm saying what the pilot does. The pilot takes off, right, and it gets to an altitude, right? It's cruising altitude where the density gradient is consistent all the way along it, right?
Let's say that's at 50,000 feet.
Yeah, whatever it is, at 30,000 feet, right? We're talking, talking 747s, this sort of stuff, right?
How is it going to stay at 30,000 feet without the control, without the controls making it go up and down? How is it going to do that?
Through its pitch and its speed. That's how it stays there.
So you put the pitch and your speed, and you put that on cruise control.
Yep.
And there's a problem now. How does it bend down?
It follows the density gradient.
That was what we asked earlier. I said, how does it follow density gradient? Does it have a density sensor? Does this make sense? How does it follow the density gradient?
The density gradient around the sphere is consistent, so it follows that.
You keep saying that.
Can we
kind of know to stay in a consistent density gradient? How does it know how to do that? Are you saying it has a density pressure sensor? Because why? Because if you physically take a model, let's say a globe, physically take a plane, let's say it's a toy plane, that plane would have to continually bend downwards when they're going from North Pole to South Pole, for example. Continually bend downwards. I don't know if you get that. You're saying it follows density gradient. The density gradient bends downwards, and once you go from A to B, you're bending downwards to stay with the sphere. Do you get that? The plane is reorientating.
Just say yes, Andy, please.
Yep.
Doesn't even matter in the big scheme of things.
Otherwise, you would end up in Bangkok flying upside down and backwards, and we know that never happens. Just take the model and put it on top of your globe, and then take that airplane and then fly it around from the North Pole to the South Pole, and you'll see you're continually bending that plane, reorientating. That's why I say if we orientate every minute, you'd have to account for 45 feet of dip. Now, you can orientate every, less or more, but you would have to somehow, I think you'd see it, you'd have to account for it. And no, a plane cannot fly through a density gradient without anybody affecting it. It wouldn't do that by itself. This is what doesn't make sense, because that would work on a flat plane, but on a sphere, you would have to bend down. Yes, the density is the same, but you have to physically bend down because it's not flat. Remember, they're claiming it's a ball. That's why. They didn't claim it's a ball, then no worries. You can say pitch, you can say thrust, but now it's a ball now. You have to get around the ball. If you continue from A to Z, you end up right back where you started. How do you get right back where you started without tilting the plane?
Okay. Yep.
How do you make a circle without spinning around?
We're just, I hear what you're saying, Godric, but we're just going to have to agree to disagree, because we're just kind of going round and round in circles.
Fair enough.
Yeah, but cool.
We'll stop for now. We can do another topic.
Yeah. We'll go with another one.
Well, if it's all right, I just wanted to hear what was his thoughts on the drone and.
They don't matter, Mel. My thoughts on what you were doing. They don't really matter. I mean, you're set. You're set, right? That this is it for you. This is absolute, undeniable proof that it doesn't move. You won't. You won't entertain any other explanation. It's done, right?
Yeah, I think that domino's fallen. I'm comfortable with that.
That's what I'm saying. So there's really no point me giving my point on it, is there? You're just gonna tell me I'm dumb. I'm a globe zealot. Those sorts of things. Well, not dumb. Okay, you won't say I'm dumb, but you're just going to say I've shut down, or things along those lines, at least.
Meryl, do you have a drone experiment to show us?
Well, because this is, I've been involved in this a long time. It feels like a long time anyway, Godric. And sometimes it feels like, it's dragging. It's like talk about eking it out. You know what I mean? So I just felt, well, I got to do something about this because this is doing my head in. And I talked to somebody I know who's got a drone, and I trust them. And so what kind of my vision is to get it on Oakley's
get it on Dells, get it on every platform, and drop it like a bomb.
So one of these experienced
Wait,
globe
one second,
drone.
Vernon.
Yeah.
Did you have anybody confirm your? I mean, I understand the timing. I get that, but have you had anybody confirm what you're showing, because you want to get different perspectives, right? Before you shoot your load, right?
I want to get people thinking. I want to get people talking. I want to get people out there trying to debunk it. I want the whole bit, and then that'll get everyone involved, and then pennies will start dropping really quickly.
You want to do that before you drop it, though, right?
Well, I'm road testing.
Or are you 100% convinced that you don't need anybody to advise? You want anybody to give you a perspective before you drop it? Is that what you're saying?
Well, that's kind of why I'm road testing it too, because I know what's going to be sort of like the refutation, and then I was encouraging people like Slacker to do it also, not to call them like a zealot, not to put anyone down.
You're road testing this drone. You're road testing it. Did you say this drone thing?
Yeah, I'm road testing the reaction.
Right, and what? Oh, you're just road testing it for the reactions, not for what it actually, not for what it's actually doing. I got you. All right.
So so you basically get conservation of momentum, the Coriolis effect. Then, like a lot of the ballers jump to the stars, they'll jump to drones moving on train videos. It's bizarre.
So one of these more experienced globe drone pilots, Merle, say like Dawn, right? Because he's got some crazy footage of his, right? So he's very experienced, right? So so I would think that this would be something that he could sink his teeth into and show how you can demonstrate the Earth moving underneath a drone. Because look, at the end of the day, someone like Dawn has got way more experience than say you or me combined. Well, at the end of the day,
100%.
So this should
I
be
actually
very
encouraged
easy.
him to. I actually encouraged him to do it, Bandy.
Yeah.
He flat out refused, and we've fallen out over it.
Oh, again. Oh, it's just your second fallout. Oh, damn.
Yeah. And he's just trolling me in gems now. He's just calling me a liar and
all the
rest of it. Yeah, he's like, it's cool. Like I kind of expected, because we've gone privately, like we've gone at each other, like we'll be cool, right? And then it'll come up, and then you feel like each other start to simmer. And then not too long, one of us is on the boil, and it's all over. You know, it's either him or me that gets triggered. So,
like I said, I'm happy with you showing Mel, and you know, they say that that's what we expect on the globe. Well, I don't know. Can you show us practically how the Earth is rotating? What do you have to do to a drone controller to show the Earth moving underneath it? Like, can it be done? Can it actually be done?
Right.
And if it can't be done, what then?
Well,
do we say the Earth's not? Do we say the Earth's not moving, or do we say that this is not a good way to show the Earth's not moving?
Well, what's the reason for? Yeah, why is it not a good way to verify it?
Because it's, I don't know actually.
Yeah.
There might be a few reasons, but why would a drone show the Earth to be moving?
Well, if it's moving, it should be detectable.
No, well, you're skipping past what Bansor said then.
I'm not trying to. That's why I want people's thoughts on this, because you know,
Bansor's
it's
giving
sort
you
of
some.
okay.
Bancel's just giving you some thoughts on it. It's pretty much what the globe would say would happen.
Yeah, but you got to know, like, just to be real with you, I couldn't give a fuck what the globe says at this stage.
Right.
How would they?
That's what I'm saying, mate. This is what.
I'm not talking to you.
No, I know.
I'm
I
talking to
get what
you
you're
as
saying.
a man. I give
it.
a fuck
Get it.
what you've got to say, but
I get it.
when it
I get
comes
it.
to this
You don't-
so-called heliocentric model, like, whatever.
So
Merlin,
how do you reckon?
I'm sorry,
Go,
quick. Is your argument
go, Patrick.
that the Earth would spin under the drone? Is that your argument?
What's that? Sorry.
The argument that the Earth would spin under the drone at some point, and it would be detectable.
Well, if the Earth is, moving in any way, shape, or form, that would be detectable. That's what everyone's got to realize.
If the Earth was spinning under the drone, why don't you see it?
That's the argument.
Well, why don't you see it? Like, if the Earth is in fact a globe, why don't you see it? You tell me.
So, I've got a couple of questions in regards to this experiment, Merle. All right, now you hovered it above the Earth, X height. All right, and it was okay. So, how did you know, right, that drone didn't move, say, 1 millimeter to the left or one? You know what I mean? How did you know?
Yeah. We film the see. There's two views, so you basically got the FPV view,
right?
And the drone he's got it's not the best drone in the world or anything, but it's a pretty good one. And so basically, you can change the orientation of the lens. So when you've got it, like, say, above you, you can turn the lens down, so you can basically just look straight down at yourself.
Okay.
Right.
So
and then
No, sorry, you explaining the rest of it to Ben, so I'll wait.
And it's, so then we've got the controller, and on the controller you can see the orientation of. It's got a compass on it. It's got the orientation of the drone, so, like, kind of, if it's level or if it's and any, so it doesn't move left to right. And there's you can put it in a hover mode, which is GPS sort of compatible, if you will, and so it's sort of like autopilot, but you can also do it manually.
Okay. So
it's accounted for all of that.
So you've already done this experiment, yeah?
Yeah, like it's
yeah,
and it's like 10 minutes uninterrupted.
Okay. So would you be prepared to do it? So would you be prepared to do it, like, say, having a laser hanging from it, and it pinpoints a spot on the ground, like X marks the spot, and that laser stays on that spot, and you do that for 10 minutes. You know what I mean? Saying like this hasn't moved at all.
Yeah,
So,
like, whatever. To be honest, like, whatever. If it's got to be done again or a third time, I'm totally cool with that.
Yeah.
And that's why this is great, and I appreciate it.
Yeah.
And whatever people need to get to that definitive place where they're like, whatever you can throw at it, whatever you can say, you just get to a point where it's like, I can't break that. Sorry. Like, if it can hold up to the scrutiny and whatever you can throw at it, like, let's go, like, bring it, let's do it.
So when you've taken this over to the other servers and road tested the idea, how have they suggested you go about to disprove what you're doing? What ideas come back to show that it is actually rotating underneath the
using
drone?
a drone only, Bansal?
Well, yeah, like, they're trying to false.
No, if you could.
What do you have? What procedures do you have to put in place to actually make sure
I don't know, man. It sounds like trying to use.
Oh, you're breaking up. Is it just me or?
Yeah, you cut out.
You cut.
My
You cut
headphones.
out.
Am I back? Am I back?
Yeah,
Yeah,
you're back.
yeah.
Yeah.
back
Okay.
now.
So
Yeah.
my USB plug played up, pulled out.
Okay.
I was saying it kind of sounds like trying to use a watermelon to drive a 9-inch nail in. You know, first you're using a hammer for the nail, and now you're saying, now prove a watermelon can push that nail in.
Okay. Well,
that's kind of my analogy in a way.
Look, we know what the model says, and this is what we would expect on them.
Exactly.
Sort of
That's my
stuff.
point. Yeah,
So,
that's exactly my
yeah.
point with my analogy.
Yeah. So.
Who gives a fuck what the model says?
No, I'm not. Hey, no.
Well, if you take your drone up, and it shows that the Earth is not moving.
Yeah.
What's your conclusion?
Good chance it isn't.
Right, but if you take the drone up and it's moving with the Earth, what's your conclusion?
Yeah. How can you prove that?
Well, what's your conclusion though? What's your conclusion? I'm not asking you to prove it. I'm just saying if that was the case, what's your conclusion?
Well, this actually started from a boards of Canada.
Just quickly, what would your conclusion be if you took it up on a sphere that was moving and it was moving with the sphere?
Well, that's what I'm saying. Like this sort of started with a boards of Canada.
Okay.
No, this started with a boards. I'm going to get it through. Like the boards of Canada video is drone footage, and what I started to notice was it's filming like above cities and like say farmland, so you can see horses running across, and you see the horses running across the fields. You see cars moving.
Yeah, but you don't see the roads moving, and you don't see the fields
so you
moving.
can see things moving across the surface.
Yeah, but not the roads.
You'd never see move.
I've heard
the
this, mate.
roads or the farms.
Yeah, that's what I just said.
None of that moves. So how do you explain that was?
You know,
well, that's
so
exactly what
movement
I
can be
explained.
detected.
That's what I just
Movement
explained.
can be detected, mate. Like 100%.
But not if you're moving with it. You got to look at another
So
method.
how can you
to
see the
detect it.
horses move and the cars move then?
Because they're not moving with it.
What do you mean?
Well, they're not. The drone's not moving with them to show them not moving. If the drone was pinned above the horse or the cars, it would look like the roads or the fields are moving, right? And those two are the horse and the car was stationary. You know that, man.
Like that.
Well, haven't you?
I haven't seen anything like that. No.
But you know how that works.
I don't think that video exists.
You know how it works, though, right?
You know what I find irony in the argument that we can't detect the Earth rotating under something that isn't attached to the Earth, being a drone, but something that is attached to the Earth in relation to a pendulum, then we can detect the Earth's movement. But we can only detect it if something is actually attached to the thing that's moving.
That makes sense.
Forecast pendulum spins under the
that
Earth
kind of makes sense.
Forecast pendulum, right? That's drift, right? So that's detected.
I think it sounds like someone's digging their heels in.
You got to see the irony in it. You got to see the irony in it a little bit. Come on.
What's that?
I said you got to see the irony in it a little bit.
If I close my eyes and shut my mind down, I guess I could.
Come on, you are hardcore.
Whoa, you're saying that you can't tell a drone, but you can tell forecast pendulum.
Put it this way. You bring little ones and twos, but you don't bring the whole number system. You know what I mean? You don't bring it all. You're just bringing these one observations, but then you might bring this other observation, and if you you start putting all of these observations together, they don't quite add up. They don't quite explain what's going on because there's always a few black swans, if I could use the term, to blow you apart. But these observations work together on a sphere. I mean, I don't understand you guys sometimes.
Well, at least we bring ones and twos. All you bring are zeros and ones in binary code. At least we got the twos.
Oh,
Binary. That binary code comes from measurements. The calculations come from measurements.
I have a question for Woes. You claim that the Earth spins under the Foucault pendulum.
Guys,
Earth can spin under a drone.
What was that, Godric? Did Godric say so?
The globe claim is that the Earth spins under the Foucault pendulum, but the Earth does not spin under a drone. Is that what you're saying?
What? When did I say that?
So,
of course,
okay, you don't believe that the Earth spins under the Foucault.
Of course, the Earth is spinning under the drone. It's just that the drone's spinning with it.
Because that's what I said to the slacker bloke. I said, okay, do exactly what I did, exactly, and show it rotate. And then it was like, all of a sudden, all those like drones on the train with the train moving and all that stuff. And then I put him on the spot and was like, okay, you show me different.
Look, there's physics. There's physics there. There's physics there to explain it. I don't understand the physics well enough to articulate it. And you guys are arguing against it, so I figure you guys don't understand the physics well enough to articulate what the physics is that they say is there to explain it. Do you know?
Can you explain the Foucault, Woes?
Do you know it or not?
Do I know the Foucault?
I just answered that question for you, Godric. You didn't need to actually ask it.
What was the question? I wasn't answering. Sorry, I didn't hear you.
Bloody hell. Basically, I don't understand the physics well enough to articulate it. Why the Foucault pendulum?
You don't need to know the physics to know that it must. There's a reaction, right? There's something happening, right? They can tell that the Earth is spinning with the Foucault, right?
It's to do with the angular momentum, I believe. But like I say, you're going to ask me for an answer that I can't articulate because I don't know it that well. And because I don't know it that well, I'm not going to go and say they're wrong until I fully understand what they're saying. Because there's so many people saying it works this way, and there's so many applications other than the Foucault pendulum that that physics gets applied to, and it works. So who am I to go against it without fully understanding it to say it's wrong? And who are you, in fact? Who is anyone?
We're just regular guys.
Doesn't fully understand it. Who is anyone that doesn't fully understand it?
The power of heliocentrism.
I think I'm being fair and reasonable, and I'm not trying to dig heels in or be this, that, or the other heliocentric, whatever. I'm just trying to be a reasonable human being.
Let me explain how you made a little bit of an error, okay? You just
go
said
ahead.
there's all these experiments that prove the physics prove it's not just a Foucault.
I didn't say that.
You kind of ran away from that. All you need to do is find one or maybe two, at least one that you can show us, and we can all kind of maybe agree on it.
I didn't run away from it. I didn't run away from it. What are you talking about? Do you know what you asked me?
If I asked you about a question, and then your answer is,
what was your question?
All these other sciencey stuff that works out, so it must be true. That's what you're saying. Is that not right?
Not really.
But can you show us one that we can all watch here in this room?
No, I can't, mate. No, I can't. I can't show you one.
Okay, so you're like a layman. You're not a sciencey guy.
Did you not hear what I said?
Yeah, you said that, and I'm okay. I'm okay with that. That's honest answer.
I'm saying I don't understand physics well enough to go against it, and I don't think other people should either. But if they want to, that's their prerogative. I don't think that's a reasonable approach to this argument. But that's my 2 cents.
Okay, but let me respond. You don't understand physics, that's fine, and neither do I. But listen, you're saying that you don't understand physics. However, all these other things work out. You just kind of blanket the whole, let's just throw a blanket on it. All
I'm
these
not
things
throwing
work
a
out.
blanket on it, mate.
Must
You
be true.
guys, you are the guys that seem to be throwing blankets over everything.
Well, you might not want to go. You might not want to say all these other experiments work out perfectly to prove a globe, but you can't really explain one.
Godric, I feel that you're not really listening or hearing what my point is, and I've tried to articulate it in a few different ways. It's not getting through, so
okay.
we'll just have to agree that we'll just have to agree that you don't understand me.
Okay.
Thank
Next
you.
question.
Yeah, I mean, I know this is going to be hard for some people. I know that, and I've a lot of thought into it, and whether, because sometimes it gets to the point like where you kind of you feel the weight of it, and it's like, well, should I just walk away and just leave it? Because for some reason I think it's too much for some people. Why that is I think
I
it's
agree
more
with
to
you,
do
Mel.
with psychology, not necessarily physics. I think it's this is where we've been told we are, and then if you take that away from people, I think that's going to be, like I said, too much for some people. So I know that it's a delicate situation, and I want you to know that I sort of.
Hey,
that's
mate,
what I'm getting at.
I'm not sure how much of that you're trying to apply to me, but don't think I'm delicate.
I'm not directing it.
Don't think I'm delicate, mate.
Yeah, no, I'm not directing it directly at you. I'm more like, say, people like say that the young, and like, and that's why I admire Joby. I know he trolls and stuff, but he is young.
Yeah, he's making.
And
yeah.
he's
I heard you say this
adjusted.
before.
So it's sort of proof that people can adjust. So that's the faith. Like, I have faith in humanity that it'll just deal with it.
Yep.
I
agree with you on that one. I have faith in humanity that we will progress and we will go forwards, and we will have better technology because of people that will investigate things and come up with conclusions, working conclusions.
Exactly. And that's the human
work
way,
together.
right? That's what we do. That's
pretty much why we're here, where we are now, and what we've got.
Yeah, and I want you to know, Hunt, like, just mate to mate. Like, I'm not against you, Woz. I'm not here to put you down or mock you or any of that stuff.
That's fine. Hey, let me say,
because I'm just
Let me say, you can if you want, because I do that to you occasionally.
Well,
but
I
just for a laugh.
that because it's. But with you, you never go right in for the jugular.
You did at me once.
Yeah, but you know why.
No, not because. No, more recently than that. You had a go at me for when I was on that presentation bullshit that Bev was doing, telling me I had cognitive dissonance, and that even Becky saw it.
Yeah, well, that's what Bev said.
Bev gave you that summary, of course.
Yeah, that's what Bev said.
Why didn't you come to me for a balanced summary, mate? Why did you just go with what he said? You know me better than that.
Because I only had one side of the story.
That's what I just said. Why didn't you come to me for a balanced summary?
Well, I guess it's just the more it goes along, like, I don't care if anyone's listening. I consider you and Curved, homies. So it's cool. Like, we can talk. It's all good, mate.
Yeah,
it's all good.
I'm not having a go at you. I'm just curious as to why you didn't come to me. If you know me, you just said what you've said. So I would have thought you'd come to me saying, "Hey, Bev said this about you. What's your side of it?"
Yeah. No,
But
I've got
you
to. I've got
didn't.
to be more.
But you
Well, I've got to
didn't.
be.
But you
Well,
didn't.
you know
Instead,
what
you
it
went
is.
into a public
You know.
VC and tell everyone that I had cognitive dissonance, and that Bev told you that. That's
Well, I
what you
guess
did.
too. Yeah, I know, but it's the fucking
Mero,
nature of these
Mero, I think you gotta
stupid.
apologize, bro. Gotta apologize and move on.
No, it's fine.
Well,
It's fine. I've cleared the air.
yeah.
You know,
I mean, it's the nature of these forums sometimes, Godric. Not so much here, but in gems, like some ridiculous shit gets said to me sometimes, and you know, I've flipped out a couple of times, but it sort of gets made out that I've flipped out with anything.
I get it.
You know what
Yeah,
I'm
I get it.
saying?
I was giving you a bit of a push that time too, because your drone thing just didn't make sense to me.
Yeah. I mean, I'm getting a better handle on it now. I think I won't go to. I'll just put the full stop on it. Like I had a lot of like just with mum. I'll be really like that was really traumatic for me.
Yeah.
So sometimes there was
Yeah, I
more
get that.
going on, and just now, and knowing that she's safe, and I've seen some photos of her.
Mel, can I give you a tip,
you know,
mate? Can I give you a tip? If you're going to go online when you've got that sort of stuff happening in your real life, best not to come into the rooms that are going to make it worse. You know what I mean?
Yeah.
I mean, unless you're looking for a vent, unless you're looking for a specific type of vent. I mean, if you're going to do that,
sometimes I was just at my wit's end, and
yeah, but
I would come in there and.
Dude, if you're going to do that, it's on you though.
Yeah, I know.
Right,
I mean, I was already there. You know what I'm saying, and it just didn't take much to tip me over the over the edge.
You were there because you were feeling that.
Yeah, and
you wanted to get tipped over the edge.
I think there was an aspect. I mean, I am one of those people. Like it's in my name now. Like I am definitely. I do look at my life sometimes like an art experiment. I must say.
Just
and
looking
I am
a little bit
testing
deeper,
it
mate.
all out.
Yeah.
You know, I don't give a like. There is one side of me too that like I got to be real again. Like I just don't give a fuck anymore. It's like you guys. It's on the internet. People can think what they
I'm seeing that
want.
a lot, mate. I'm seeing that a lot. That I don't give a fuck attitude. Anymore. I'm seeing that a lot.
Yeah, and people will look for a weakness.
Yeah, I mean, I've
if
cared
they
for a
know,
really long time, like what other people think of me.
And if
You
they
know,
know,
and I've pandered to it.
And if they know that they can trigger you and get a reaction, which they can laugh at, right? Well, personally, I think it says more about them than it does you personally. But still, people are going to do it, and then then that gets used against you in the future. Which I know with you, it's just water ducks back. It's like whatever it is, what it is. I don't really care. But people in these realms, that's what they try. That's what they try and do, and they revel in it too, Mel. But you're aware of that.
I guess what all this has taught me is there's a point too where you've got to just forgive. Like not so much like I think there's a difference between being immature and you're just given the keys to a V8. You've seen it, right? And they're excited to start revving the fucking engine. What boost? Let's go, right? All that male energy, young male energy. So I don't have that get out of jail card now at my age, and then there's another point to it where it's sort of like the irrational. But I long ago when all this started, I realized that there was an aspect to this where you got to accept or take responsibility for this yourself, basically. So I've said it to Jem too. Like him and Voight called me out last night, and we were talking about the laws of motion and stuff. And as soon as I saw, okay, there's an error there on my part, I instantly just conceded to both of them, put my hand up, said, yep, concede on that point. You know what I mean? It's easy. So I'd rather now be the adult, adjust quickly, show that I can be versatile, work with people, not be difficult, I can adjust, all that. That's what needs to come in. And at the end of the day, like, I'd rather than us all being against each other and fucking debating for another 10 years, I'd rather us work together, if I'm being completely on the level. And I think, like we just said to Woz, everything's going to be all right. I think it's all going to come out in the wash. I do have faith in all the species, all of us. We'll be right.
You got to
just lost sight of that for a while.
You just got to find peace within your own life. Well,
yeah,
and not worry about anyone to find that happy place for yourself.
Yeah.
It really doesn't matter what I think, what Woz thinks, what anyone thinks, as long as you're happy.
Yeah.
Bugger everyone else. at the end of the day, it's really quite that simple. Like, it's not any more difficult.
Well, not really, because some people require public approval to be happy.
Really?
Some people,
some
people do. Some people do.
That's on them, though. That's on
exactly.
them.
Exactly. But you say whatever makes you happy. Don't worry about what other people think. But what other people think actually makes other people happy.
Yes, but
it's not a blanket thing.
No, but if their way of being happy is by having public approval, right? That's still the way they're thinking about things and how they're going to place. So then they have to get that public approval. So it is on them, right? Still.
Yeah, go on. It's all right.
No, I'm finished.
That's cool. I think it's.
I'm finished.
The thing I like about us three is we've known each other years, a long time, and I just want you both to know anyway that
I love you, Mill.
Yeah, we've been on a massive fucking. What a massive fucking adventure this has been. I never expected anything like this, guys. So it's turned my world fucking upside down for sure. But I'm sort of getting back on my feet now. It feels all right. I've got a job. You
got to stop, Mel. You got to make Bansal cry now. He's going to tear up.
Well, even my boss today he started opening up to me, and so things are shifting a bit. No, I wouldn't dare.
Did you globe gouge him?
Headbutt, but no, I just can't bring myself to talk about that yet. I don't know if ever, but we'll see. I'll sort of see how open-minded he is.
Keep it off the table so you can continue to get paid.
Yeah, I've seen it. Just sort of the door slam shut, if you know what I'm saying.
Tell your boss that the cut and polisher only works on a planar surface, not a spherical surface.
Yeah.
So
it's just a delicate one. Yeah.
So Bansal, what's a good video to watch to see how these pipe laser tools work? With
good video.
You got a plumb bob inside of them. Yeah. Is that what's going on?
I've never seen a video ever. Was.
Oh, YouTube's a big place.
Well, then look on YouTube.
I am, but I'm just asking you as an expert, which one's a good one?
Oh, like I said, I have never seen Was.
I'm tasking you with a mission.
Oh God, I don't know. Bloody hell! Are you looking at it now?
Yeah.
Okay, then choose the first one. It's probably a good one.
Yeah, the titles don't sound good.
What are they?
Hang on, let me just change my search parameter.
Okay. God, you can do that.
Yeah, you just type different words into Google.
Oh, do you? Laser.
That's your search parameter.
Pipe. Hold on. I'm going into YouTube now.
What's a good brand? Is it Leica or Lysa? How do you pronounce that?
There's a few different ones. I had what was one that I had? It was a German name. Oh,
Black and Decker.
Black and Decker. Yeah. Geucher or something like that. It was bloody German anyway. So the fact that it was German, it was going to be. Here we go. The Leica. 13 years ago. It actually looks very similar to the one that I use. Let's see. It's
These have got a plumb bob inside of them. Is that what you said before?
Basically, they work on plumb. Yep, that's how they work. Yep, boom. Okay, he's putting his inside it. So they work both inside and outside the pipe. Boom.
I'm going to have to get this in my head a bit more. I'm not familiar with this tool at all.
Okay. Yeah.
I've had a little bit of experience. When I say a little bit, probably about 45 minutes to an hour's worth of experience with a dumpy level and a staff.
Okay. Would you do a garage at home or something?
No. We were checking the concreters' work after they poured the block for two townhouses side by side.
Okay.
They ended up being about 50 mil out in one spot, which was a bit of a shock.
Oh, really?
Yeah, they also
mil?
And they also blew the forming out and ended up using about an extra 2 meters of concrete or something like that. I think this is a few years ago.
Yeah.
Yeah, did a shit job.
So they're pretty straightforward, but like I said, they work on plumb anyway.
So you set that up at your beginning.
Yeah.
Just say you got a run that you have to do.
Yeah.
You set it up at your beginning, then you go X amount of meters down your run.
Yep.
And you establish plumb there again.
Yeah. So you can
and you continue doing that.
Yeah, basically you'll lay X amount of pipes. I don't know, anywhere, I don't know, between half a dozen and 8 thereabouts. And depending on what you're doing, you're always backfilling these days too because of OH&S. You don't want to open trenches and stuff. So you're always moving this. It once again reestablishes plumb. Okay, and the same.
And what exactly is your contention with the shape of the earth and this laying pipes and using this tool?
Well, what's my contention is,
well,
my contention is that if we have established our datum, okay, being a horizontal straight line at point A, okay, and that's where
you start, right? That's where you start your run.
That's where we've started from, okay?
Right, yeah.
And if you've got a riser that's already set in place, right, at the end of your run, okay, that you have to hit a particular point at, right? So, and you've only got a little bit of wiggle room, okay, because they have to be at a certain height and a certain place in the riser, okay, because the hole's already there, okay. So,
right, and you've got to have fall, yeah.
And in that run. Yeah. Oh, exactly, exactly right. But everything is set off your original datum point that you work from. So you're going from point A to point B, and you've got to set this, and you can confidently start at point A, but keep on re-establishing that plumb all the way along that line, and still hit your point at the end of that run. Okay, even though you've moved your plumb line all the way along it.
Right.
So if it was dipping down, right, like you say, I wouldn't hit me target. I'd be low, and then I'd have to raise that pipe at the end to get into the hole.
But then how are you? I'm not getting something here. How are you getting your fall? Because there's going to be other attributes at play here, right? In that length of pipe, in that length of pipe.
Other attributes such as,
well, sure, you have to get the pipe on target to hit the riser in the right spot, but you also have to have some fall on it, so it would have to drop anyway.
Yeah, that's your grade that you set with the tool. So it's set at, say, a 4% grade. Okay. So that has established it straight away off the bat.
Right. So as you run this pipe along, how many? I mean, the other thing too you have to consider is the length of the run, right? Because you're going to have fuck all curvature if it's a short run.
The longest.
What's the longest run you're talking about here?
The longest run I've done is point A to point B is about 850 meters thereabouts. That'd be about the longest I've done.
Okay.
Generally, they're a lot shorter than that, granted, but the longest I've done is about 850 meters, which over that distance you would say 4 inches thereabouts. I should have been lower.
So you're saying you should have been 4 inches lower to your target?
Yeah. Yep.
And you're definitely not compensating the hole or the ditch, right? How are you measuring your grade?
Well, you're following a straight line. Okay, that's what that laser pipe leveler does. It establishes a straight line that's on a grade already, on that 4% grade. So
right, and you drop your pipe according to where that line is.
You follow that straight line, exactly right. So it.
Okay.
Yeah, so it fires a straight line out in front, right, which is
the laser pointer shooting out a laser.
Yep.
At the target.
The laser itself.
Where you want it to go.
Exactly right. Exactly, and that because that tool establishes plumb and horizontal, right? So it establishes that itself, right? When you put it on the pipe, right? It plumbs itself up, okay, and it gets its horizontal from plumb. Then you set your grade to it. I say of 4%. Once you've set that grade at whatever grade it is, say 4%, then you can pick that up and move it from one pipe to the other, or first pipe to the sixth pipe, or however many pipes you do. You can pick it up. It will re-establish plumb and still continue that straight line on that 4% grade. So from the very start all the way to the very end, it's a perfectly straight line, or close enough to perfect.
850 meters, yeah.
Is the longest I've done. Yes, is the longest I've done.
And how did you come to the conclusion there'll be about 4 inches drop?
Well, well, I'm working out over a mile. There should be 8 inches thereabouts. So I just halved it. What's a mile in meters? About 1.5 kilometers thereabouts.
Oh, I'm not sure.
Yeah.
So it fucks me up when you do miles and kilometers together.
Yeah. So I think it's about 1.5.
It's
Close
it's
enough.
1.3 kilometers to a mile.
Well, there you go. So so I was probably being a little bit generous. Probably should have been more than 4 inches. Probably should have been 5.5. But I underestimated it a little bit there. But anyway,
And does it work that way though? I'm not sure.
Oh, whatever it is, it's close enough to 4 inches anyway. But you know, your side will say it's that insignificant you wouldn't even notice and all that sort of stuff. And it doesn't really like phase me one way or the other. I think the only way to go out and do it definitively is by going out physically and measuring something definitively, getting it done.
I don't know, man. It just doesn't sound right.
Okay, fair enough.
I missed it. Did the bandsaw do an experiment? What doesn't sound right?
Oh no, this is just back in the day when I'm working. Before this argument, it was even a thing. Really?
Did you debunk the globe before?
Well, I think I've got, with either pipe laying or digging dams and stuff. I've been involved in a pretty big dam too. So.
Yeah.
Yeah. About a kilometre square. Oh yeah. About a kilometre square, a kilometre by a kilometre by a kilometre, thereabouts. And the water didn't run over the edges when she was.
When she was, and you cut out.
And I said the water didn't run over the edges.
Cut out again. At the same spot.
And I said the water didn't run over the edges when she was full. But
Right.
you would say that we wouldn't expect that on the globe.
Well, if you leveled it out, yeah.
So yeah. So we're back to square one. But yeah, one day we might get a group of us and we might actually go out and measure it. Maybe. I'm not going to hold my breath though, but maybe we might.
Yeah, your pipe thing, just going back on your pipe thing, I don't know, I think I've got a gut feeling it should be somewhere around 2 inches of drop over that distance.
Why?
And, something about when you have the length, you don't actually have the drop. It's more than half. I can't remember it exactly in enough detail to articulate it to you.
I haven't heard that, and even so, you may be right. I'm not going to argue it one way or the other.
I've just got a vague recollection of that being explained a long time ago.
Yeah, maybe.
I've heard the
wrong.
say that the hidden height is not actually the hidden height, that we have it wrong.
I think it's because
so when you move your laser along, isn't that just moving along the curve anyway?
Yes.
Well, that's what you would say.
You're following that, but
so you're actually gonna come back and say that
you're going to say it's a circular argument, aren't you?
Exactly. That's all you're going to say. You're going to say that ain't a straight line. It's actually a straight curved line. And here we are back at point A.
So using water, then to go back, using water to establish the Earth is indeed not a sphere. Isn't a good way of doing it.
Well, I think actually using water is an excellent way, and you could actually do an experiment that could conclusively show it one way or the other.
Well, what about could you use enough water to cover a distance of, say, Sydney to Santiago?
as in an ocean.
Mm.
Well, you could do it on a much smaller scale than, couldn't you?
No.
You couldn't.
No. It's not
use an
about doing it
ocean.
at a small scale.
The oceans constantly move. So I thought you would need a large body of water at rest.
Yeah, that's what I'm saying.
You could conclusively do it very easily using water on a very small scale. Conclusively do it.
How small?
Over 1.5 to 2 miles. Conclusively do it. And you don't even have to. And you don't even have to worry about doing it next to a body of water.
Well, I think there's a few people planning to do that over in the UK.
What are they doing?
The Bedford experiment thing. I believe it's Rumpus and a team of people setting up sites and sighting along a stretch of water. You don't reckon that's good?
No. You wanna measure. I think that's absolutely rubbish. At the end of the day,
I think they're doing some sort of measurement. I don't know the detail, so I don't want to speak ill of it.
Why wouldn't you measure it conclusively?
What method?
Well, you would establish a horizontal line from point A, 1 mile going in to the left and 1 mile going to the right. Okay? So you can do this a number of ways. You can do it yourself. Well, you could use whatever method everyone would agree to. Okay? So
it's failed.
Exactly right. There we go.
From the start, mate.
Well,
it's not going to go anywhere.
Well, hey, I've put something out there, and people can either run, they can just hand wave dismiss it. I don't really care one way or the other.
You just did that with Rumpus's thing that I was vaguely explained.
He's not measuring anything, and I've heard Rumpus about it. He's not actually measuring anything. He's putting up a few targets and looking bloody theodolite type of thing. Measure it conclusively, right?
Kind of like what Jaren did. I get the impression it's kind of like the thing that Jaren did in that video when he had the peepholes and the light.
Yeah, no. This is nothing like the peepholes whatsoever. And
sure?
you can conclusively.
Sounds like a public toilet, mate.
Well, maybe. Establish your horizontal right, and take your marks, right, and you can then conclusively prove it one way or the other. So you've got your mark 1 mile to the left and then 1 mile to the right. So you've got, I don't know, 20 odd markers to the left and 20 odd markers to the right. Then you have yourself a water level, okay, a simple water level, but you don't do a slice barcane kind of water level, right?
Don't tell me you do a Bev water level.
No. You've got to spend a bit of coin, all right? And to get a 2-inch diameter flexible hose that's about 1 kilometre long, all right, it's about $7.5 thereabouts. All right, about $7.5. So it's not cheap, but anyway, it is what it is. And then, from the centre point, you've got your horizontal line, and you can take that water level, and you could move it 50 metres to the left and 50 metres to the right of it, right? And that water level will marry up exactly to that horizontal line. Okay, then you can keep on doing it a further 50 metres to the left, a further 50 metres to the right. Okay, all the way along for that kilometre. Now, that water level will marry up exactly on that horizontal line. Okay, exactly. Won't deviate. Okay. Now we have both proved, right, both globe and planar surface in one with the one experiment. Right, bang, we proved both of them. Then what you do is you get the water level and you leave it at your starting point, and you only move it to the left all the way along. And the further that you move that water level, that line, right, it will start to drop below that line. Thus, that can only happen on one model. Simple as that.
I don't know. It just sounds like when it just sounds to me that you got to sight along the full length instead of doing sections. Because doing sections to me, it sounds like you're following a vector. You're like, I don't know, vector's the right word even. You could be following a curve.
You can get a surveyor to create a perfectly level and horizontal line from datum point A. They can do it. They can do it quite easily. Right? They've done it. Eh? You guys want to shout out LIGO all the time. So we know that these people can create perfectly straight lines in free space. So you get them to do it in free space again, and then away you go.
Well, aren't the just going on LIGO? Aren't the mirrors in LIGO that reflect a laser have to be adjusted slightly for the curvature?
I don't know. That is what
I think they do.
That's what they say, right? That is what they say. I don't know. I don't know. I don't know if they've got a little computer program that automatically adjusts the mirror in those things to get them to shoot down the middle of that pipe. I know how I would do it, right?
I mean, if you're gonna start calling out massive lies, we may as well just call out massive lies and say everyone's lying until you've done it yourself.
Oh no, I'm just if you're talking about the mirror sort of stuff, the easiest way to get that mirror reflecting down the center of the target would be to set it plumb, all right, and then if it doesn't quite exactly shoot down the center of that pipe for whatever reason, then you have your micro adjustments on it so it sets down the center. Now then, to assert now
how they do that.
To assert now that it's because of the curvature of the Earth, well, that's a pretty big assertion. All right, that's a pretty big leap. Well, I just think it's a big leap myself, right? It's a good debating point, right? Oh, they did this because of the curvature of the Earth, right? But I know myself that if I was doing it, yeah, you'd do it, and then you'd have your little micro adjustments on it, and you'd micro adjust it so it would be shooting straight down the center.
Right.
So
it did that for me. Sorry.
Go, Mel. Go. Jump in.
For me, that's where Soundly has done a service, because from that particular angle that he gets that bridge, it shows that, like, let's just put it out there, that potentially over a level, just hypothetically, right, potentially over a level body of water, and when I'm saying level, I'm meaning, horizontal, there's waves and shit, but it's pretty much, an even surface, flat, no curvature. But the bridge does look like it's curving. So this is what Del and Gav and others were digging, like that. Then you start to get into optics.
Yeah.
So,
right, boys, I've got to go have dinner. I've got to go have dinner,
yeah,
boys.
no worries.
The chat. I'll talk to you later.
I've got to
go to beer soon anyway.
Okay. Yeah.
Yeah, it always comes down to optics and what you should and shouldn't use and what people will and won't accept.
Exactly. And just that things can distort like that.
Do you think, Mel, if a lot of these flat earthers or globe deniers, do you think if they were taken high enough off the earth to see that it's actually a globe, and yes, I'm saying a globe just for this thought experiment, do you think that change really? I mean, some of them seem pretty hard and fast that nothing could change them.
I mean, let's go one step. Well, let's go one step further with the experiment. Just say, so the windows are
sure.
Just you know,
sure.
There's no fuckery, and you can
you can put your face.
all your doubts are just like met, and then
Yeah,
all
you
you got
can
to
put
do
your
then
face
is
right up to the glass.
yeah,
to
and all you got to
alleviate
do
any curvature.
Yep, and all you got to do then is just go up, and what you see will be there, right? And it is what it is. And if you got into the upper atmosphere and looked down, and there was a big sphere, a big planet, there's nothing you can say. It is. It speaks for itself.
There is.
Or you could say, "Oh,
hold on,
no, that's CGI." But nah, not CGI.
Highlander, just a quick one. People can say they were knocked out and taken into some sort of holographic chamber, and this was all a projection. It was all made to look that way.
That's what
there's always going to be. The fact is, there's always going to be something that's not quite good enough. Sorry, Highlander, go ahead, mate. Cut you off.
See, I was going to say I asked Nathan Oakley that question, right? I asked him, if I start a GoFundMe page for you, Nathan, to let you have a trip to the ISS so you can see for yourself with your own eyes, and he said, you know, I said, would you go? And he said, no, because all NASA would do is drug me and fake everything and then have me come back, making me believe I actually went up there when I actually didn't. I was just in a room all drugged up.
And
Well,
that's what happens.
That's what we call in
a conspiracy.
That's what we call in the classics as psychological desperation.
Yeah, that's just preempting stupidity, in my view.
A conspiracy is a cover-up, like a conspiracy.
No,
I've heard some flat earthers say I wouldn't even get into rocket because they'll have it designed to explode.
Well, don't we already have high altitude balloons showing that it's flat and enough satellites to show that it's
but
flat?
wouldn't that be a good headline? Hey, look, flat Earth
that
goes
it's round
up in space and blows up. Wouldn't that be like what they would want to show us? So that's just like a temptation right there.
No, it's got nothing to do with that. If you went up and looked out and there was a planet there, there's nothing you can say. There's nothing you can do. Again, it's that moment. You just have to deal with it.
But let's
just have to wear it.
Can I be heard?
Merlin, let's be
Can I be
fair.
heard? Hey,
NASA
Dodger,
will
can you hear
tell
me?
us nobody can get that perspective of the Earth, right? Nobody can get that perspective, can they?
You see, there's already denying.
You can see the planet. How can you see the planet? How do you do that?
See, Merlin's already denying the possibility at all.
How do you see the planet unless you went to Mars?
Listen to him.
How can you see the planet?
No, we were just talking about a hypothetical. We were just talking about a hypothetical.
You can't even do that.
You don't have to go as far away as Mars. Yeah.
How far you have to go?
Himawari 8 takes a full picture of the Earth. It is far enough away.
Dude, look at him right. Doesn't even have the colors right, bro. Come on, get real.
We weren't talking about any of that. We're talking about any of us going into the upper atmosphere, looking out the window, and then it's like, you expect to see dog cam or something, right? But you're actually, it's you. It's not dog
this is
cam.
a thought. This is a thought experiment to see
you
how
look
people
out
think.
the window, and you're like, holy fuck! It was a planet. Imagine that moment. Like you'd spin out, wouldn't you? You'd be like, fuck. What happened then?
Merlin, how far?
It's a hypothetical, It's just you just have to be real with yourself, right? If you saw it,
how far do you have to go to see a planet? Mathematically.
Well,
wait, hey Merle, isn't the point that we should have like undeniable, like millions and millions of hours of footage of the Earth if that were even possible? Shouldn't we already have that with satellites showing like the zoom in to like planes flying upside down and all that stuff? mean, if it were possible, we'd have that because we
Why?
supposedly have all the satellites out there and lots of
Planes,
travel in space. Right?
hold on. Planes flying upside down relative to what?
Well, if you're in space, you could zoom in on the bottom of the Earth and show that the planes are flying upside down, right?
If you were in space, you can take the James Webb, point it at the Earth, and see planes flying upside down. Do you understand that?
And sideways and upside.
You
All
understand
those
that?
are
weird, really quickly.
Hold on.
Exactly.
You do know Himawari zooms in and takes pictures of the local Japanese weather system. Yeah.
Yeah. The Himawari 8's
Right.
been pretty thoroughly debunked, but you have to look into it to actually see that.
They don't even have the colors right, man. Come on.
What colors? What are you talking about?
The Himawari 8's been way. I mean, flat earthers have torn that apart over the
It
last.
tells you that the continents are red-brown. How does that
No,
even
they
work?
haven't.
How can the continents
they
be
have.
brown?
There's pretty definitive explanations for everything Himawari 8 shows us.
Right.
Yeah,
Okay,
that's
back
true.
on Merlin. Merlin, the correct answer is you'd have to go to the moon or halfway to the moon to see the planet that you claim that you would see if it were a globe. Here's the problem. Nobody can do that. We can't do that. We can't test it ourselves. So we have to trust NASA to tell us what the Earth looks like from space because we can't go there ourselves. That's why you have that hypothetical wasn't a good one.
Plus, we have tons of high altitude balloons.
Yeah.
It's just a plane. I mean, the high altitude balloons
Here's
show
another-
that. There's
Right,
tons
so
of it.
obviously not every flat earther on the planet is going to be able to go there and see for themselves, right? So there has to be someone in the flat earth community that you guys can trust that if they went there and came back and said, look, I've seen it, it is a globe, the earth is not flat, you would have to believe them.
Explain all the hundred other
Maybe
reasons that
somebody
it couldn't be a globe.
maybe
You'd have to
somebody
explain
like
all the other reasons that it's not a globe along with that, though. You'd have to all the other reasons.
All those other reasons, all those other reasons would automatically fall down, like you try to do with the what do you call it, Black Swan? You try to collapse everything with that one picture. So if the flat earther comes back and says it's a globe, everything automatically falls down.
I think
Right,
anything
so if you're God,
I was using I was using the term loosely.
Yeah.
If your God QE went up there, came back and said, "Look, I've actually seen
He's
it.
not-
It's a globe." Right?
QE is just the dude. Don't worry about it.
Yeah, but he's one of the big flat Earth leaders, is he not?
Not really. There's no leader.
No,
That wasn't meant to go into the whole QE thing.
Yeah, he's
There's
just a militant flat
I was
earther.
just using it as an example. I wasn't meaning for the whole discussion to go down the QE path.
Right. Yeah. It's not. There's not really like anybody that's being followed, and other than like the information they give, it's just like each individual has
Listen,
some good things that they say, some things we don't agree with. You know.
Right. So what you're telling me is that there is no one in the flat Earth community that if we sent up there and they came back and said, "I've seen it, it's a globe," you wouldn't believe them.
No, because it's not about trusting anybody. That's what this whole thing's about.
Highlander, where
You can't
is there
trust.
now?
You have to trust people on this kind of thing when it's obvious that it's not a globe. It's obvious in 100 ways to everyone that it's not a globe. Personally,
Highlander.
your personal experience, you know
Are
it.
you saying
You
that
know. Deep
they're
down,
gonna
you know.
send Are you saying they can send a flat earther to the moon? Is that what you're saying, Highlander? What are you saying? How far is there? Where is there? Between the moon and the earth? Where is it?
I haven't had
Whatever
that
you
personal
want to send
experience.
them.
I'm asking you, man. I'm asking you. And here's the thing. Wherever you say that they're gonna send them, nobody can send them there. It's just a hypothetical. There has to be an astronaut on the way to the moon to see a quote unquote planet. And that's never gonna happen, so you can't test it. So it's a really bad analogy. It's a bad hypothetical.
It is not to be QE-like, but it is a violation of the second law of thermodynamics.
Well,
look, if somebody didn't believe Australia didn't exist, here's the thing: they can go fly there. Here's the thing: but we can't fly to see a planet. That's the thing. So, it's just nonsense.
We can cut to the chase quite quickly. So, Highlander, if we took you up and same situation, same hypothetical, and you looked out and you saw no curvature and a stationary plane, what would you do?
Well, have you not just debunked yourself with that? Because I thought the Earth was flat with a dome, so therefore
really
you
an
can't
answer.
get
It's
to
not
the
really
other.
an answer,
Yeah,
though. It's
yeah,
not
but
really an answer.
your
Not
hold
everyone says the flat Earth is like
your
that.
model, right? On your model, right? You can't
Not
get
answering.
far enough away.
Let him go.
On your model, you can't get far enough away to determine whether the Earth is flat or a globe. Yeah,
But Highlander, you know there's no model
because of
and
the
no one's
fucking
claiming a
dome.
dome. Highlander, you know
Highlander,
there's no model and no one's claiming a dome.
I don't think Mills
Okay,
adheres to
sorry,
that
not a
model,
dome,
if you want to call it
it's a
that.
container, right? So
We
it's
just did
not a
the
dome,
same
it's a container.
Listen,
Wait,
a
Just
very
did
Highlander,
the
hang on.
same. Hang on,
Go ahead.
Ludwig. Let me just, because they did the hypothetical with me. It's no big deal. It's a no one's going to die, guys. Just chill. But so Highlander, just flip it. So you go up, you look down, stationary plane. What would you do? Just be real. It's no big deal.
The first thing I'd say is, did you find a door in your container?
Don't worry about models, domes, containers, or anything like that, mate. It's just a thought experiment that if you went up there and looked back down and it was flat, there was no sphere. It's just a thought experiment. How would you react? What would you do?
I'd obviously, my mind would be blown and I'd have to rethink everything, wouldn't I?
Respect. No problems, mate. That's good enough for me.
That's an honest answer. Thank you for that.
Yeah.
I'd freak out too. Like, how the hell does everything work? That would be my first question.
Yeah. And then I would start saying, well, obviously the physics that the humans have learned and known for years has now got to be rewritten.
Mm-hmm. Yeah, it would be a big shock, definitely.
And you have to be digging around for a massive lie. That's what I'd be doing. I'd be digging around for absolute definitive evidence of a lie.
Science is always making errors and it changes. And science changes to the next paradigm.
And no one's found one yet, so it'd be impossible.
But once you had that in your back pocket, was like, it wouldn't be much of a stretch to be like, okay, there's JFK, there's the moon landing, there's fucking a lot of things kind of wrapped up quite quickly, right?
You could still have them.
Yeah.
See, the thing for me is, right, because the way the laws of physics work here on the Earth for us tell us it's a globe, right? But then if I was taken up and I see it's flat, then I'd be like, right, okay, so the laws of physics down there work, but it's meant to be a globe, but I'm up here seeing it's flat. Okay, so where's the mainframe for the fucking Matrix? Because that would be the only explanation for it.
It'd have to be some sort of simulation, I guess. Yep.
Yeah.
What?
That.
Don't take it there.
Well, the Earth's really flat, but they're simulating a globe.
If
you're down on it.
That's a good
So it'll be some sort of simulation.
Yeah,
I
mean, I say
simulation. You can break out and see those matrix green numbers go up and down. You break out.
I say the globe's a multimedia project.
I know. I've heard you say that. Yeah.
It's got nothing to do with science. It's got to do with multimedia, like people who are good at that sort of stuff.
Except for the bits that have got everything to do with science.
Does anybody think you'd wake up?
Science is one thing. Creating images and artistic sort of license is another. But they do touch up
those images that are created as an artist's rendition or depiction of something. That's that artist using. That's that artist creating that image from the science.
So you admit there are artists across space. You admit that?
I can't hear you.
Or just using a paint palette and putting a bit of blue here, a bit of a cloud there, a bit of a green bit here.
Don't forget to draw sex in the clouds. It has to say sex backwards, because that's how.
But that's the science giving them the knowledge to know how much blue to put here and how much cloud to put there. Those sorts of things.
Either it's the science giving them the knowledge to do that, or
there will be an element.
Dude,
There will
if you-
be an element. Oh,
as long as you
How
put
would you-
sex
how
backwards,
would you know?
it's good. As long as you put sex backwards, we're gonna let it go through.
Thanks, Godric. You're great. Fantastic. Good on you, mate.
Probably better example.
Say it one more time, mate. I didn't hear the first two times. Can you say it one more time, mate? I didn't hear the first two.
Has to say sex, bro.
Sex, S-E-X, right? You're not saying six with the Kiwi
No,
accent.
if you also draw a penis, that's
Sucks.
cool too.
Sucks.
Sucks. Fish and chops.
I mean, guys, would it be all that surprising if you found out the reason you don't feel like you're spending is because you're not? Would that be all that surprising? Come on.
Yes, it would be very.
That's funny though, because I mean, think about it. I mean, that would be the most logical conclusion, right?
I am thinking about it, and just because it doesn't feel like I'm spinning, doesn't mean anything.
Well, that's what I'm saying is that's what surprises us. The people that feel like that, it makes way more sense that the reason we don't feel it is because
I've
we're
been
not.
sat on a stationary
And we
train
get
and thought I was
surprised when
moving.
It means nothing to you. It should mean something. I mean, that should be taken into consideration in this argument.
I think the main question
It would
is
be a surprise.
If you were told that or proven beyond doubt that it is what you think it's not, then what difference is that going to make to your life? I mean, for me, if I was told, if the governments and NASA come out and said it's flat, it's stationary, we're not rotating, I'm still going to get up. I'm still going to look after my family. I'm still going to go to work. It's not going to change any part of my life whatsoever.
Would you be more skeptical of other things that you're told, though?
I'll tell you why it would be a surprise, because I've been in that situation where I was set on a stationary train. The train next to me was moving, and I thought I was moving, and it was a surprise to find out that I wasn't, that I was actually standing still.
Yeah, just because there's one instance of it feeling like that for a minute doesn't mean your direct experience 100% of your life should be that.
If you slowed time down for that,
Highlander, wouldn't it make you more skeptical of other things?
Down to a lifetime, it wouldn't make a difference.
Okay, regardless, Highlander, wouldn't it make you more skeptical of other things? That's how it might change your life. Just back to that. You said it wouldn't make a difference.
Yeah.
But let's say there's another big government program that's put in place that you might be more skeptical about, and you might avoid something that you might have fallen for in the future if you were to realize that the lie could be this big. That's the value in it. Gives you discernment.
Entertaining what ifs here.
Well, could I
it's obvious.
Just remember that.
Could I answer Highlander? Like, what difference does it make? For me personally, man, it's the most significant topic or subject there is. And it shows you how much the earth itself, or the mother, if you will, Mother Earth, is being disrespected. That's what it's about. Like, whatever we're standing on, people just rape and pillage it. They couldn't give a fuck about it. And that's what it brings you back to, where you actually are. And people have just lost sight of the earth itself and what it really is. Most people couldn't care less. Like you say, they're just living their lives.
Well, wouldn't you think, though, that people care now because they're convinced that this is a planet that we're ruining and we have to now take care of it because otherwise we're going to have to leave the planet, and that's the only reason that people care about it, when it should be like because it's, not what we're told and we need to rediscover exactly where we are and all that?
Well, it provides everything we have.
There's no way of knowing how the whole human race will react.
It provides our food source, our air, right?
Everything.
Yeah. And if you find out it's flat, you guys, you basically lose most of science. You lose evolution, you lose the Big Bang, you lose gravity. Nothing makes sense.
That's what's so exciting about it. That's why
But
it's such an
everything
important
makes way more sense, wouldn't you think, Godric? Doesn't everything make way more sense?
I meant that.
Just
that
starting with
makes
your
sense
direct
in the current
experience.
science paradigm. You'll have to throw out science and start over.
No, not science. No, there's lots of science. This is about protecting science from pseudoscience. It's not about denying science or not believing in science. It's about making sure that the science that we are valuing has value.
New perspective. This isn't the colleges, right? It's in education. It's in government media.
Yeah, but when you say science in a broad sense, the way that a lot of ballers like to use the term science is like it includes, if you're denying space travel, then you must be denying all of science. But that's not the case. There's lots of valuable science. And that's the reason that this is important. Because if we're mixing in pseudoscience and then just using a broad term of science, including it all in there as if it's the same thing, then that's where the problem is, right?
I'll give that to you. You can say you want to separate science from pseudoscience. You can say that.
Yeah. Okay. Thanks. I thought you might think the same. I'm sure you do.
The good thing is too, like new perspective and other. I don't know about your journey, Godric, but we had the good fortune of being on panels that were like a round robin, like never ending kind of place we could all go and talk about it. You know, we've been preparing ourselves and discussing this and analyzing it for years. You know, it's sort of, I think we've all counseled each other through it in a way.
Yeah,
we're
one of those things.
You know, we've learnt so much together. I said that's a phase.
Counseled each other through what? The fact that
The shock of
the world is round.
The shock
That
of
it's flat.
finding out that it's not what we've been told. Yeah.
Well,
Okay,
yeah,
and what do you
something
think
you
it is?
realize. It's not something you believe. It's something you realize.
Okay, cool.
As far as it's just not what they told us. So it's not like we were counseling each other because we're still in doubt of it being a spinning ball or not.
Is it when I heard
there's a point where you can't come back from that. You can never bring yourself to believe in the ball again.
Yeah,
That's
once
where
you see, you can't unsee it. Like once you see Australia in the moon and you realize that that's Australia in the moon, you can't unsee that, right? And that's what I mean when somebody says
Australia in the moon. Where did that come from?
Well, don't worry about that. No, that's just my
That's
my thing. No, it's just my thing that I've seen. But the thing that was interesting was when somebody said you've got to protect the science. I was like, well, we're protecting lies now? That's interesting.
No, protecting the real science, the valuable science, the science that actually does things for us that is valuable. Not the science of the globe. That's the pseudoscience we need to protect the real science from. That was my point.
Awesome. I'm just making sure I appreciate that because it's the thing that I can't. Sorry about the background noise. The thing that I can't get past is the observation of down and the perpendicular